course by Intellipaat. Have you ever wondered how Amazon recommends the right product you are looking to buy? How applications like Ola and Uber predict the easier route and precise location of arrival? All this possible using data analytics. You must have heard numerous of times that data is new oil of 21st century, and any business, if they want to succeed, they have to use data analytics. Well, companies in 2024 have already started leveraging data analytics, and if you don't switch now, it will be too late. On LinkedIn, there are 98,000 plus data analytics jobs available, and this is just in India. In United States, there are 1,74,000 plus jobs available. If we talk about salaries, Glassdoor reports that in India, you can expect a salary between 6 lakh rupees to 29 lakh rupees. Whereas in United States, you can earn between 97,000 US dollars to 200,000 US dollars. Companies are hiring aggressively for data analytics professionals right now. So are you ready to make your next big move? If you are, then this free analytics bootcamp is all you need. This data analytics course has been taught by top industry experts from companies like Microsoft, Google, Meta, etc. and aims at making you job ready. Throughout this data analytics for beginners course, we are going to cover important tools such as Excel, R, SQL, PowerBI through a rigorous hands-on approach. Towards the end, we will also cover the important and most commonly asked data analytics interview question by top MNCs. Let us understand what we all be covering in this session. First, we will start with what is data analytics. Then we will look into introduction to SQL and introduction to RStudio. Then we will try to understand data manipulation, data visualization, and statistical analysis. Then we will cover introduction to Excel and formatting and validating data using Excel. After that, we will learn what is business intelligence and stages of business intelligence. Then we will move on to introduction to Power BI and hands-on demonstration for Power BI. At the end, we will cover data analytics interview questions.
What is data analytics? Data analytics is the buzzword you would have heard a lot about in the recent years. To put it simply, it's the process of analyzing raw data to get insights and find patterns about the information. Using various techniques and processes, the raw data is transformed into a format which could be further visualized and be made human readable. To understand the definition in an even clear way, let's take a look at this example. John, who is a digital marketing professional, is running an online advertising campaign to promote a new smart television. John starts by targeting the group of people who might have bought the previous versions of the smart TV in question. As said campaign runs, data analytics comes into the picture through the data generated whenever people clicked on the published advertisement. Now, by inspecting the data about these users' interest and their buying patterns, you might come across that many of them are interested in streaming 4K UHD video. The reason behind this might be that the new smart TV has a better streaming quality than the previous versions. Using this information, you could tune in your advertisements to focus on users who bought the previous version of the smart TV and are interested in getting 4K streaming quality. This data can also be used to attract new customers who did not go for the previous version of the smart TV but are very interested in a better version of the TV. Why is data analytics significant? Businesses use data analytics to optimize and grow by making better business decisions and finding more efficient ways of doing business. The company can build new and better products with the buying patterns and better understanding what the customers need. So how do data analytics work? The data analytics process has some components that can help a variety of initiatives. By combining these components, a successful data analytics initiate will provide a clear picture of where you are, you have been, and where you should go. Generally, this process begins with the descriptive analysis. This is the process of describing historical trends in data. Descriptive analytics aims to answer the question, what happened? This often involves measuring traditional indicators such as return on investment. The indicators used will be different for each industry. Descriptive analytics does not make predictions or directly inform decisions. It focuses on summarizing data in a meaningful and descriptive way. The next essential part of data analytics is advanced analytics. This part of data science takes advantage of advanced tools to extract data, make predictions, and discover trends. These tools include classical statistics as well as machine learning. Machine learning techs such as neural networks, natural language processing, sentiment analysis, and more enable advanced analytics. This information provides new insight from data. Advanced analytics addresses what if the question. Data analytics affects every aspect of our day-to-day lives. You may not even realize it, but you probably use data analytics almost every day. Here are some of the everyday applications of data analytics. Social media stats instantly register anytime there's a visitor or a post to a page. Cell phone bills can pull up months of calling data to show you patterns of usage. Sensors monitor the changing weather and report that data to you instantly on your smartphone. Sports fans collect statistics on their favorite athletes and often use the data to form the term of fantasy leagues. Schools across the nation are involved in high-stakes testing that generates voluminous data on each student's progress. Educators then utilize data generated from extensive reports to drive their instruction. Data analytics is a growing field and will always be a top domain to get into. The average salary of a data analyst in India is 7 LPA and in the US it's $70,000. There are 27,000 plus data analytics jobs available only on LinkedIn, and there are very few skilled professionals to fill that gap.
So this brings us quickly to the introduction to SQL. Well, so what is SQL? Well, SQL is one of the standard languages we use when we go on about dealing with relational databases, which can be used to create, read, update, and delete database records, guys. So these are some of the operations we can perform. So what does SQL stands for? Well, SQL is simple. It stands for Structured Query Language, guys. You're going to find out why we call it the query language in just a moment. But then you read the term relational databases. So what is a relational database? Well, a relational database is basically just a type of database that stores and provides accesses to all the data points which are related to one another. Well, how are these data related to one another, guys? So basically, when we call it a relational database, there has to be some relation with respect to the data. Using SQL and all the DBMS, we call it the RDBMS because it's relational database management systems. Here we have the data organized in tables, which you'll see in just a second, and then we map the data so that the database knows what's important and what's not, and we do this using something called as keys. Well, keys such as primary keys, candidate keys, secondary keys, all of these provide relation between one column of the data to the other column of the data, guys. You'll see all of this in a couple of moments. But then coming to a little bit more about relational databases. Well, relational databases are pretty much based on what we call as a relational model, where we pretty much map one concept to another, the other concept is mapped to another, and we have this interdependency, interrelationships which are built throughout the data, guys. And then this makes it very intuitive and extremely straightforward. Pretty much it gives us a very straightforward way of representing the data in the form of tables, as I just mentioned. And then the other good thing about the relational database, as I already told you, is that each row has something called as a record, and there is some unique ID called as key as well. Again, we're going to check all of these in the upcoming slides. And then we have something called as columns, which any data table will have. And then these columns basically hold all of the data, and each record in this column basically is mapped onto a unique thing. And then we go on about establishing something called as interdependency relationships and much more among all of the data present, guys. And if you're wondering how SQL is pronounced, it is pronounced as either SQL or it's called SQL, guys. Pretty much you will find developers, enthusiasts, and many others either calling it SQL or SQL. So whenever you heard of the term, whenever you hear the term SQL, make sure to map it into SQL, guys. It's pretty much simple and straightforward.
So this is the syntax to create a database in SQL. We will give in the keywords create database and then give the name of the database which you want to create. So let's go ahead and create a database in SQL. So let's create a first database, guys. So I will give in the keywords create database, and let's say I want to name the database as happy, right? So I'll press semicolon over here. I'll hit execute. So see that commands have been completed successfully. Now let me hit refresh over here. So initially we just had two databases, Igneous and Sparta. After implementing this command create database happy, we have successfully created a new database happy. Now after we have created a database, we need to know how to select a database from our existing list of databases. So we have the use database statement for this. All we have to do is give the keyword use and then state the name of the database. Now this database which you selected remains default until the end of a session or execution of another use statement with some other database. So if I put my mouse pointer over here, so we see that currently we are using the Sparta database. So now I want to use the happy database instead of the Sparta database. So I will write the command for that, use, and then after that I need to give in the database which would be happy. I'll press semicolon, I'll hit execute. So again, commands have been completed successfully. So now we see that the database has changed from Sparta to happy. So currently we are inside the happy database. Now we'll see how to delete a database, or in other words, how to drop a database. So we have to give in the keywords drop database and then specify the name of the database which you want to drop. So now I want to drop this Igneous database. So let me write the command for that. Drop database and then the name of the database is Igneous. So I'll press semicolon over here. I'll hit execute. So again, commands have been completed successfully. Now I'll hit refresh. So we have only two databases, Happy and Sparta. So the database Igneous has been dropped. So a data type basically defines the kind of data that will go into a particular column. Now it needs to be kept in mind that all the entries of one particular column would have the same data type. So let's take this e-salary column for example. We see that the first entry is of integer type. The second entry is also of integer type. Similarly, all the entries of this e-salary column are of integer type. Now let's take this department column. Here we see that all the entries of this particular column are of character type. Now that we've understood what exactly are data types, let's have a look at the different data types available in SQL. Let's start with the numerical data types. So we have the big int data type, which helps us to store really big values. So you can see the range of big int over here. Then we have the int data type, which helps us to store reasonably big values. After that, we have the small int data type, and the range of small int is from minus 32,768 to 32,767. Then there's tiny int, and the range is only between 0 to 255. After that, we have the decimal data type, and it is used to store fractional values. So the decimal data type takes in two arguments. First is the size of the value, that is the total number of digits. Then we need to specify the number of digits after the decimal point. Let's say we want to store the decimal value 12.50. Here the size would be 4 because the total number of digits are 4, and value of d would be 2 because there are 2 digits after the decimal point. Now let's have a look at the character data types. So first we have the char data type. This takes in one argument, which is the size of the value. Let's say you set the size to be 20. This would mean you cannot give in a value which would have more than 20 characters. Now you need to keep in mind that char is a fixed length data type. That is, if you set the size to be 30, but you given only 3 characters, then the memory which would be consumed is of 30 characters. So you are basically wasting the memory over here. Then we have the varchar data type. This again takes in size as the argument. Now varchar is a variable length data type unlike char. So here if you set the size to be 30 and given only 3 characters, the memory consumed would be only 3. Then we have the text data type. So this data type can take in a string with a maximum length of 65,535 characters. Then we have the date and time data types. Well, start with the date data type. So this data type helps us to specify the date in this format over here. Let's say we want to store the date 2nd January 2019. Then first we will give in the year, which would be 2019. Then we'll specify the month, which would be 01, And finally, we'll specify the day, which is 02. After that, we have the time data type, and this helps us to specify the time represented in the format over here. Now, let's say I want to store the time 8:30 a.m. 23 seconds. So first I'll specify the hour, which would be 08. Then I'll specify the minutes, which is 30. And finally specify the seconds, which would be 23. Then we have the year data type, which just holds the year values such as 1995 or 2011. So constraints are basically used to specify some rules on the data and limit the type of data that can go into a table. And in this session, we will look at these 4 constraints: not null, default, unique, and primary key. Let's start with the not null constraint. So by default, a column can hold null values. And with the help of the not null constraint, we can ensure that a column does not have null values. So the not null constraint basically ensures that a field always contains a value. For example, if we assign the not null constraint to this e-salary column over here, then every single entry of this column should have a value. Then we have the default constraint. So the default constraint is used to provide a default value for a column. So the default value will be added to all the new records if no other value is specified. For example, if we assign the default constraint to the age column and set a default value of 25, then all the entries of this column will have the default value of 25 if no other value is specified during insertion. Then we have the unique constraint, which ensures that all the values in a column are different. For example, if we assign the unique constraint to this ename column, then every entry of this column should have a unique value. And finally, we have the primary key constraint. So the primary key constraint uniquely identifies each record in a table. Or simply put, it is just a combination of the not null constraint and the unique constraint. So when we assign the primary key constraint to a column, then that column shouldn't have any null values and all the entries should also be unique. For example, if we assign the primary key constraint to the employee ID column, then there should be no null values in this column and all the entries should also be unique. So let's have a look at the steps to create a table in SQL. So first, we'd have to start off by giving a name to the table. After naming the table, we'd have to define the columns which should be a part of our table. And finally, we'd have to assign a data type to each of the column which we have defined. Now let's have a look at the create table syntax. So first, we'd have to specify the 2 keywords which are create table, and then we'll give a space and then give a name to the table. And inside the parenthesis, we will define all of our columns and assign them their respective data types. Now finally, if you want to give a primary key constraint, we can do it over here. So we will give in the keywords primary key and then give in the name of the column which would be a primary key. So as we have already learned in a previous session, a primary key basically helps us to uniquely identify all of the records in our table. And guys, also keep this in mind. A table cannot have more than one primary key. So now that we've understood the syntax of create table command, let's go to MS SQL Server and create our employee table. Right, so this is MS SQL Server. So I'll start with the command. I will give in the keywords create table. Then I will give in the name of the table, which would be employee. And inside the parenthesis, I will give all of the columns. So the first column would be employee ID. So I will type EID, which is the name of the first column, and this is of type integer. Now after this, I will also put in the not null constraint. So this not null constraint means that all of the cells in this column should definitely have a value. And then I will give in the second column. So the second column is employee name. So E name, and this is of type varchar. So varchar stands for variable length character, and the maximum length would be 20. Then I'll give in the third column. So the third column would be employee salary. So I will name the column to be E salary, and this would be of type integer again. After this, we have the employee's age. So the column name would be E age, and this is of type integer too. Then we have the employee's gender. So I will name the column to be E gender, and this would be of type varchar. So this is of variable length character, and the maximum length is 20. And then we will give in the final column. So the final column would be the department in which the employee works. So let me name it to be EDEPT, and this would be of type varchar2 and a maximum length of 20. Now after this, I can set in the primary key. So I want this employee ID column to be the primary key. I will type primary key and inside the parenthesis, I will give in EID. Right. Now I will put in semicolon over here to indicate that this is the end of the syntax. Now I will select all of this and click on execute. Right. So we have successfully created the employee table. We can insert records with this insert into statement. Now let's understand this command properly. So first we'd have to type in the keywords insert into, then we'll give in the table name, following which we'll give in the keyword values. And inside the parenthesis, we'd have to give in the values for each of the column respectively. Now let's go to MS SQL Server and insert records into our employee table. So let me start with the command. So I will type in insert into, then I'd have to give in the name of the table, which would be employee, after which I will give in the keyword values. And inside the parenthesis, I can give in all of the records. So let me start with the first record. Right. So we'll have to start off with the employee ID. So the employee ID is, let's say 1. Then the second column is the employee's name. And this is of type varchar. That is why I will give in the value inside these single quotes. So the employee's name is Sam. After this, we would have to give in the employee's salary. So Sam earns $95,000 per annum. I will give in 95,000 over here. Then we have the employee's age. So Sam's age is 45. After which we have the employee's gender. Again, since this is a variable character, so I will use the single quotes over here, and Sam is male, obviously. After which we'd have to give in the department in which the employee works. So again, this is variable length character. I will give in single quotes, and Sam works in operations. So let me type in operations over here. Right. Now I will put in semicolon over here. I will select all of this and I will click on execute. So we have successfully inserted one record into our table. Now let me follow the same procedure and insert another record. So insert into employee values, and inside the parenthesis, the first column is employee ID, which would be 2. After this, I'd have to give in the name of the employee. So the name of the employee is Bob, and Bob earns $80,000, which is his salary. So let me put in 80,000 over here. Then we have the employee's age. So Bob's age is 21. Then we have the gender of the employee. So Bob is male, obviously again. Then we'd have to give in the department in which the employee works. So Bob works in support. Again, I will put in semicolon. I'd have to select all of these. Let me click on execute. Right, so we have also inserted the second record. Now let me insert the third record. So again, it would be the same command. Insert into employee values. Inside the brackets, let me give all of the values for the columns. So employee ID is 3. The name is Anne, and Anne's salary is $125,000 per annum. She's quite rich, isn't she? And her age is 25. And she's obviously female. Now we'd have to give in the department in which the employee works. So Anne works in analytics. Let me type in analytics over here. So it seems like people who work in analytics earn quite a lot, doesn't it? So let me put in semicolon over here. I'll select all of these and let me click execute. So similarly, I will insert 3 more records into the same table. Right, so we have successfully inserted 6 records. So the select query is one of the most important commands in SQL, and it is used to get data from our table. So let's have a look at the syntax. So first we'd give the keyword select and then list down all of the column names that we want to select. Following which we'll give the keyword from and then finally give the table name from which we are supposed to select these columns. So let's select some data from our employee table. So let's say I want to extract only the employee name column from the employee table. So for that, I would have to give in select and then I would have to give in the name of the column. So the name of the column is ename and then I will give in the from keyword, after which I will give in the name of the table, which is employee. So let me put in semicolon and let me hit execute. Right, so I have successfully extracted only the name column from the entire employee table. So similarly, if I wanted to extract only the age column from the employee table, we would have to put in a similar syntax. So it would be select employee age from, and the name of the table is employee. Execute, right? So we have extracted the age column from the entire employee table. Now we can also extract multiple columns from our table. So for that, we'd have to separate each of the columns with a comma. So let's say I'd want to extract the name column, the gender column, and the salary column from the entire employee table. So let me write the syntax for that. So it would be select. So I will give in the first column, which would be e-name. Now I would also want the gender. So I will put in e-gender. I'll put in a comma. And then I would also want the salary column. So I will put in e-salary. After which I will use the from keyword, and then I will give in the name of the table, which would be employee, semicolon, and let me hit execute. Right? So I have extracted 3 columns from the employee table, and those 3 columns are e-name, e-gender, and e-salary. So this is how we can extract multiple columns from the same table. Now we can also extract the entire data from our table. And to extract the entire data from our table, we'd have to use the asterisk operator. So let me show you guys how it's done. So the command would be select, and then I will put in star, after which it will be from employee. So as simple as that, guys. Select star from employee. So whatever table it is, all you have to do is select star from, and then you'd have to give in the table name. So this is how you can extract all of the data from a particular table. So I will give in semicolon and let me hit execute, right? So when I gave the command select star from employee, I was able to extract all of the data from the employee table. Now let's look at the select distinct statement. So a column often contains many duplicate values, and sometimes we'd want to extract only the distinct values from the column. So this is where select distinct comes in. So the syntax of select and select distinct is pretty much the same. The only difference is we follow up the select keyword with the distinct keyword. Now let's select some distinct values from our employee table. If we have a glance at this gender column, we see that these 2 values are being repeated. So we just have 2 values, male and female, and these 2 values are being repeated. So now if I wanted to extract only the distinct values, so this would be the command for that. So I will type in select, and I'll follow up the select keyword with the distinct keyword. After which I'll give in the column name whose distinct values I'd want. So the column name would be e-gender, and then it'll be from the name of the table, which is employee. So let's see, what do we get? Select distinct e-gender from employee. Right? So we see that we only get the distinct values, which are female and male. Now let me actually remove this distinct keyword and let me hit execute. So let's see what is the difference, right? So if I remove the distinct keyword, we get all of the values. So male, male, female, female, male, and female. Now, so if we use the distinct keyword, we'll only get the values which are different. So these are the cases where select distinct can be used. So the where clause is used to extract only those records that fulfill a specified condition. For example, we'd want to extract those records where the age of the person is more than 60. Or filter out those records where the occupation of the person is doctor. Now let's have a look at the syntax of where clause. So we'll start with the select keyword. Then we will give in the list of all of the columns which we want to select. Following which we'll use the from keyword and give the table name. And finally use the where keyword and follow it up with a condition that would determine which records are to be extracted. So let's filter out some records from our employee table. Now let's say we'd want to find out all of the female employees of our company. So for this, I'd have to extract those records where the gender equals female. So let me go ahead and write the command for that. So that would be select star from, I will give in the table name, which is employee, and then I will use the where keyword and follow it up with the condition. So the condition would be e gender is equal to female. Right, so what I'm basically doing is I am extracting all of the female employees from this employee table. Let me hit execute. Right, so Anne and Julia are the only female employees. Now I want to find out those employees whose age is less than 30. So let me write the command for that. Select star from employee where I will give in the condition. So this time the condition would be age is less than 30, right? So the age needs to be less than 30. I'll give a semicolon. Let me hit execute, right? So these are the three employees, or these are the three records where the value of age is less than 30. So Bob, Ann, and Jeff, these are the three employees whose age is less than 30. Now similarly, let's say I want to find out all of those employees whose salary is greater than $100,000. So let me write the command for that. So this time the command would be select star from employee where. So the condition would be E salary is greater than 100,000 semicolon and execute. So Anne, Matt and Jeff are the three employees whose salary is greater than $100,000. So Anne's salary is $125,000, Matt's salary is $159,000 and Jeff's salary is $112,000. In this session we'll learn how to implement the inner join. We'll be implementing the inner join on these two tables. First is the employee table, which comprises of employee ID, employee name, employee salary, age and gender, and the department in which the employee works. Then we have the department table, which comprises of department ID, department name, and the location where the department is present. So the inner join basically gives us those records that have matching values in both the tables. So let's say we have two tables, table A and table B. And when we apply inner join on these two tables, we'll get only those records which are common to both table A and table B. So let's have a look at the syntax. We'll give the select keyword first and then the list of the columns, following which we'll give the from keyword and give the name of the first table. Then we'll use the keywords inner, join and give the name of the second table. After which we'll use the on keyword. So this on keyword tells SQL that this inner join needs to be done on some condition. And that condition would be values from column X of table 1 should be equal to the values of column Y from the table 2. Now this might sound complicated, so let's just implement this inner join on the employee table and the department table. So before I go ahead and implement the inner join, let me have a glance at both of the tables. So I'll start with the employee table. Select star from employee. Right, so this is our employee table. So we see that we have this department column over here, which tells us about all of the departments in which the employees work in. Now similarly, let me have a glance at the department table. Select star from, I will give in the name of the table, which would be department. Right, so we have three columns over here and I have this D name column over here, which gives me all of the names of the departments. So this is the common column between the employee table and the department table. So we'll be applying the inner join condition on the D name column of the department table and the EDEPT column of the employee table. So let me go ahead with the syntax of inner join. I will give in the select keyword and then give in all of the columns which I'd want to select. So I'd want to select the E name column and EDEPT column from the employee table. So first I would have to give in the name of the table, which is employee. Then I'll put dot over here and then give in the name of the column. So I want the name column from the employee table. And similarly, I'd also want the department column from the employee table. First, I will give in the name of the table. I'll put in dot over here and then give in the name of the column, which is EDEPT. Right. Now I'd also want the department name column and the department location column from the department table. So first, I will give in the name of the table, which is department. I'll put in dot over here and then give the name of the column, which is D name. Similarly, I'd want to extract the department location column from the department table. First, I will give in department over here, which is the name of the table. I'll put in dot and then I will give in the name of the column, which is D underscore location. After this, I will give in the from keyword and then give in the name of the first table, which would be employee. Then I will give in the keywords inner, join and give in the name of the second table, which would be department, right? So I am selecting these four columns and the inner join would be on the employee table and the department table, right? Now I will use the on keyword and give the condition. So the condition would be the values of the EDEPT column of the employee table and the values of the DNAME column of the department table should be equal. So employee dot EDEPT should be equal to department dot DNAME. Right guys, so this is the complete syntax to implement inner join on these two columns of the employee table and the department table. And I am selecting the E-name and E-department columns from the employee table and D-name and D-location columns from the department table. Now let me hit execute. Right, and this is what we get. So we have these four columns over here: employee name, employee department, department name and department location. And since this is inner join, we have only those records where the values from EDEPT have matched to those values of DNAME. So the left join basically returns all the records from the left table and the matched records from the right table. So if we take table A and table B, then applying left join on these two tables would give us all the records from table A and only the matched records from the table B. So let's have a look at the syntax. We'll start with the select keyword and then give the list of the columns, following which we'll give the from keyword and give the name of the first table. Then we'll use the keywords left, join, and then give the name of the second table. After which we'll use the keyword on. So this on keyword tells SQL that this left join needs to be done on some condition, and that condition would be values from column X of table 1 should be equal to values from column Y of table 2. So let's implement this left join on the employee table and the department table.
Let's have a quick quiz question guys, and the question is, which of the following is a primary goal of data analytics? Option A, storing data for future use. Option B, predicting the future with absolute certainty. Option C, extracting valuable insights and knowledge from data. And option D, reducing data collection efforts. Please do mention your answers in the comment section below.
Just a quick info guys, Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as PowerBI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So before I implement the left join, let me actually have a glance at both of the tables. So I'll start with the employee table. Select star from employee. And these are the columns present in the employee table: employee ID, employee name, employee salary, employee age, employee gender, and employee department. So I'll be taking this employee department column from the employee table. Now similarly, let me have a glance at the department table. Select star from, the name of the table is department. So we have the department ID, department name, and the department location. And from this department table, we'll be selecting this DNAME column. So we'll be applying the left join on the EDEPT column of the employee table and the DNAME column from the department table. So let me start with the syntax to implement the left join. So I will give in the select keyword first, and then I will give all of the columns which I want to select. So I want to select the employee name column from the employee table. So first I will give in the name of the table, which is employee. Then I'll put dot over here, and then I will type employee name. Now I'd also want the employee department column. So first I will give in the name of the table, which is employee. I'll put dot over here, and then I will give in EDEPT over here. Then I'd want the department name column and the department location column from the department table. So I will give in the name of the table first, which is department. I'll put a dot over here, and I will select the department name column from the department table. Similarly, again I will type in the table name, which is department, and I'll put a dot over here, and then I'll also select the department location column. So now that I've selected all of the columns, let me give in the keyword from, and then give the name of the first table, which is employee. Then I'll give the keywords left, join, and then give the name of the second table, which is department. Now I'll give the on keyword and then give the condition. And the condition would be the values from the employee department column from the employee table should be equal to the values of the department name column from the department table. So employee dot EDEPT, these values should be equal to department dot dname. I'll press semicolon over here. Now let me hit execute. Right, so this is the result when we apply the left join operation on the employee table and the department table. So we've got all of the records from the left table, which is the employee table. And we see that we get only the matched records from the department table, which is the right table over here. And wherever the records haven't matched, we get null values. So we see that the operations department is not present in the department table. So that is why we have null values over here. So the right join basically returns all the records from the right table and only the matched records from the left table. So if we take table A and table B, then applying right join on these two tables would give us all the records from table B and only the matched records from table A. So let's have a look at the syntax. We'll start with the select keyword first and then given the list of the columns. Following which we'll give the from keyword and then give the name of the first table. Then we'll use the keywords right, join, and then give the name of the second table. After which we'll use the keyword on. So this on keyword tells SQL that this right join needs to be done on some condition. And that condition would be values from column X of table 1 should be equal to values from column Y of table 2. So before I go ahead and implement the right join, let me actually have a glance at the employee table and the department table. So I'll start with the employee table. Select star from employee. So this is our employee table, which comprises of these columns: employee ID, employee name, employee salary, employee age, employee gender, and employee department. And we'll be implementing the right join with respect to this column, employee department. Now let me also have a glance at the department table. Select star from the name of the table as department. I'll hit execute. So the department table comprises these three columns: department ID, department name, and department location. And we'll be implementing the right join with respect to this dname column. So now let me go ahead and write the syntax for the right join. So I will put in the select keyword first, and then I'll give in all of the columns which I want to select. So from the employee table, I want to select the employee name and the employee department columns. So for that, I'd have to give in the name of the table first, then I'll put dot, and then I will give in the name of the column which I want to select. So employee name. Similarly, I also want the employee department column. So first I will give in the name of the table, which is employee dot, and then I'll select the EDEPT column. And then I want the department name and department location columns from the department table. So I'll have to give in the name of the table, which is department. I'll put in dot over here and then give in the name of the column, which is dname. Similarly, I'd also want the department location. So I'll put dot and then select department location. Now I will give in the from keyword and then give in the name of the first table, which would be employee. After that, I will type the keywords right, join, and then give the name of the second table, which is department. Then I'll use the on keyword and then give the condition. So the condition would be values of EDEPT column from employee should be equal to values of dname column from the department table. So employee dot EDEPT should be equal to department dot dname. I'll put semicolon over here. Let me hit execute. And this is the result which we get when we apply right join on the employee table and the department table. And since this is the right join, we see that we have all the records from the department table and we have only the matched records from the employee table. So we see that there is no content, tech, and finance departments in the employee table. So that is why we have null values over there. So the full join basically returns all the records from the left table and also all the records from the right table. So if we take table A and table B, then applying full join on these two tables would give us all the records from table A and also all the records from table B. And wherever the join condition is not met, we'll get null values in that place. So let's have a look at the syntax. We'll start with the select keyword first and then give in the list of the columns. Following which, we'll give the from keyword and then give the name of the first table. Then we'll use the keywords full, join, and then give the name of the second table. After which we'll use the keyword on. So this on keyword tells SQL that this full join needs to be done on some condition. And that condition would be values from column X of table 1 should be equal to values of column Y from table 2. So before I go ahead and implement the full join, let me actually have a glance at the employee table and the department table. So I'll start with the employee table first. So select start from, the name of the table is employee. So we have these columns in the employee table: employee ID, employee name, employee salary, employee age, employee gender, and employee department. And we'll be applying the full join on the employee department column. Now let me also have a glance at the department table. Select star from, the name of the table is department. I'll hit execute. So the department table has these three columns: department ID, department name, and department location. And we'll be applying the full join condition on this department name column. So let me start with the syntax for the full join. So I will give in the select keyword first, and then I'll give in the list of all of the columns which I want to select. So I want to select the employee name and the employee department columns from the employee table. So first I'll give in the name of the table, which is employee, and then I'll give in the name of the column, which would be employee name. Similarly, I'd also want the employee department column. So I'll give in the name of the table, employee. I'll put dot over here, and then I'll select the EDEPT column. After that, I'd also want the department name and department location columns from the department table. So I'll give in the name of the table, department. I'll put dot over here, and then I'll select department name. Similarly, I'll also select the department location column. So I will give in the name of the table. I'll put dot, and then I'll select the department location column. After this, I will use the from keyword and then give in the name of the first table, which is employee. Then I will use the keywords full, join, and then give in the name of the second table, which is department. After that, I will give the keyword on and then specify the condition on the basis of which the full join needs to be done. So the condition is the values of EDEPT column from the employee table should match with the values of the DName column from the department table. So that would be employee dot EDEPT is equal to department dot DName. I'll put semicolon over here. Let me hit execute. So this is the result of the full join on the employee table and the department table. So wherever we see null values, that means that the records have not matched over here. So operations is present in the employee table, but it is not present in the department table. So that is why we have null values in the columns extracted from the department table. Similarly, we have content, tech, and finance departments only in the department table. And that is why we have null values in the columns extracted from the employee table. So the delete query is basically used to delete or remove one or more existing records in the table. So let's have a look at the syntax. We'll start with the delete keyword and then put in the keyword from. Then we specify the name of a table. After that, we'll specify the where condition, but that's optional. Now let's delete some records from our employee table. So we have our employee table right here, and I'd want to delete that record where the age of the employee is equal to 33. So this would be the command for that. I will give in the delete keyword, and then I'll type from and give in the name of the table, which would be employee. After that, I'll use the where clause and give the condition. So the condition would be age is equal to 33. I'll put in a semicolon over here and I'll hit execute. So you see that one row has been affected. Now let me have a glance at the modified table. So I will type in select star from employee. Execute again. Right. So you see that that record where the age was equal to 33 has been removed. So initially we had 6 records. Now we only have 5 records in our table. Now similarly, I want to delete that record where the employee name is equal to Sam. So let me write the command for that. So I will give in the delete keyword first, and then I'll give in the from keyword. After that, I'll give the name of the table, employee, then use the where clause and then give the condition. So this time the condition would be name is equal to Sam. Right. Execute. Again, we have one row which has been affected. Select star from employee, and let's see the modified table now. So see that another record has been deleted, and that record where the name was equal to Sam is the record which has been deleted. Then we have the truncate statement. So the truncate statement deletes all of the data inside the table. So here we'll give in the keywords truncate table and then give the name of the table. So let me go ahead and remove all of the records from this employee table using the truncate command. So I'll type truncate table and then I'll give in the name of the table, which is employee. Execute. So see that commands completed successfully. Now I will type select star from employee. Now let's see what do we get. So we see that all of the records are empty. This is because the truncate table command basically removes all of the data from the table. And the specialty of the truncate command is, even though it removes all of the records from the table, the structure of the table remains intact. So we see that the structure of this table over here, employee table, it is still intact. So the update statement is used to modify or change the existing records in a table. And this is the syntax for the update statement. So we'll start with the update keyword and then given the name of the table. Then we'll use the set keyword and assign new values to the columns which you want to update. And finally, we'll use the where clause to give in the condition which should determine where the columns are to be updated. So I've put in the where clause over here in square brackets because it is optional. Now let's update some records of our employee table. So this is our employee table and I want to set this age value to 42 where the name equals Sam. So this would be the command for that. So I will give in the update keyword and then give in the name of the table, which would be employee, and then use the set keyword and then set the age value to be equal to 42. Then use the where clause and then set the condition. So the condition is the name should be equal to Sam. So where the name is equal to Sam, I am updating the value of age from 45 to 42. Let me put a semicolon. Let me hit execute. So you see that one row has been affected. So now let me have a glance at the change table. Select star from employee. Right. So we see that initially the age value was 45 where the name was Sam. So the age value has been changed from 45 to 42. Now similarly, I'd want to change the department to tech wherever the gender value is female. That is, I want to change the department of all of the female employees from analytics to tech. So this is how I can do it. Again, update keyword and then I'll give in the name of the table and then the set keyword. So over here, I want to set the department to be equal to tech where the gender is equal to female. So let me put in female over here. Right. So let me hit execute now and let's see what happens. So we see that two rows have been affected. Now again, let me have a glance at the modified table. Select star from name of the table is employee. Right. So we see that initially the department of both of the female employees was analytics. So that department has been changed from analytics to tech. Now I want all of the employees to have the same salary. So I will update this entire column to have the same value, which is $50,000. So this command would be quite simple. Update and then the name of the table, which is employee, and then I'd have to set the salary to be equal to 50,000. That's it. Let me hit execute. So we see that 6 rows have been affected. Again, let me have a glance at the modified table. Select star from the name of the table is employee. Execute again. Right. So we see that the salary has been updated. So every employee's salary is same. It is $50,000 per annum. So we have the department and employee tables right in front of us and we'll be implementing the same task. So from this employee table, we'll add 10 more to the age values wherever the department location is equal to New York. And since we've already seen that content and analytics are based in New York, so basically these two records where the EDEPT value is equal to analytics, we'll be adding 10 more to these two age values. So let me write the syntax for that. I'll type update and then give the name of the table which I want to update. So that would be employee. After that, I'll use the set keyword and then update the age value. So EAge, and I'm adding 10 more to the EAge value. After that, I'll use the from keyword and give the name of the first table, which would be employee. Then I'll type join and then give the name of the second table, which would be department. Then I'll type on and then state the join condition. So the join condition is the values of the EDEPT column from the employee table should be equal to the values of DNAME column from the department table. So employee dot EDEPT should be equal to department dot DNAME. And finally, we'll specify the where condition, which would be D location should be equal to New York. So I'll select all of this, I'll click on execute. So you see that 2 rows have been affected. Now let me have a glance at the modified employee table. Select star from, I'll type the name of the table, which would be employee. Now I'll execute this. So let me see the original age values. So over here the department is analytics, and we see that the initial age of Anne and Julia is 25 and 30. And after applying the update command, we see that the age has been modified to 35 and 40. So Anne's initial age was 25. After updating, it became 35. Similarly, Julia's initial age was 30. After updating, it became 40. So this is how we can use update with a join condition. Now let's understand how can we use delete with join. So this time from the employee table, I'll be deleting those records where the department location is equal to New York. And since content and analytics are based in New York, we'll go ahead and delete those 2 records from the employee table. So in the final modified employee table, we see that there are no records where the department is either content or analytics. So again, we'll be implementing the same task. From this employee table, I'll be deleting those records where the department location is in New York. So let me write the syntax for that. So I'll type delete and then give the name of the table from which I'd want to delete the records. So that would be employee. After that, I will give the from keyword and then give the name of the first table, which would be employee again. Then I'll type join and then give the name of the second table, which would be department. Now I will give on and give the join condition, which is same again. So the values of EDEPT column from the employee table should be equal to the values of DNAME column from the department table. So employee dot EDEPT should be equal to department dot DNAME. And finally, I'll use the where condition, which would be D location should be equal to New York. So I'll select all of this. I'll click on execute. So again, we see that 2 rows have been affected. Now let me have a glance at the modified table. Select star from employee. So see that there are no records where the department is analytics. So if you have a look at the original table, we see that there are 2 records where the employees were present in the analytics department. And after deleting those 2 records, we just have 4 records present in the employee table. So the merge statement helps us to perform insert, update and delete in just one statement. This means we no longer require multiple statements to perform insert, update and delete. And for the merge statement, we require 2 tables, a source table and a target table. So the source table basically contains all the changes which are to be applied to the target table. And the target table is that table upon which we'll be implementing all the changes. Now the merge statement basically joins the target table to the source table using a common column in both the tables. And based on how the rows match up, we can perform insert, delete and update operations on the target table. Now let's have a look at the syntax of the merge statement. So we'll start with the merge keyword and then give the name of the target table and assign it an alias using the as keyword. Then we'll type using and give the name of the source table and also assign it an alias using the as keyword again. After that, we'll type on and then set the join condition. Then we'll type when matched. So if the rows match up based on the join condition, then we'll go ahead and update the target table. After that, we check when not matched by target. So this basically means that if there are some rows which are present in the source table but not in the target table, then we'll go ahead and insert those rows from the source table into the target table. And finally, we check when not matched by source. So here we are checking if there are some rows which are present in the target table but not in the source table, then we'll go ahead and delete those rows from the target table. And for the practical purpose, we'll be using these two tables. So this is our source table with the name employee source, and this is our target table with the name employee target. So using the merge statement, we'll be updating the e-salary and e-age columns in the target table wherever there's a match. Also, insert the records with employee ID 7 and employee ID 8 into the target table from the source table, and delete the records with employee ID 4 and employee ID 5 from the target table because they're not present in the source table. So let's go to SQL Server and work with a merge, right? So we have our two tables right in front of us. This is the employee source table and this is the employee target table. And we also have the merge syntax to apply on these two tables. So we'll type merge and then give the name of the target table, employee target. We'll assign it an alias T. Similarly, we'll give the employee source table and then assign it an alias S. After that, we'll type on and then set the join condition. So the join condition is t.eid is equal to s.eid. So we basically set the join condition on the employee ID columns of the source table and the target table. Then we have when matched. So if there is a match between the rows of these two tables, then we'll go ahead and update the target table. So here in the update statement, we have t.eSalary equals s.eSalary and t.eAge is equal to s.eAge. So if the records match, then I'll be setting the values of the salary column of the target table to be equal to the values of the salary column of the source table. Similarly, I'll also set the values of the age column of the target table to be equal to the values of the age column of the source table. And then we have when not matched by target. So here we are checking if there are some rows which are present in the source table but not in the target table. And if that is the case, we'll go ahead and insert all of those into these columns of the target table. And the values would be coming from the source table. So this employee ID column from the target table would be getting the values from the employee ID column of this source table. Similarly, this employee name column of the target table would be getting its values from the employee name column of this source table. And finally, we'll check when not matched by source. So if there are some rows which are present in the target table but not present in the source table, then we'll just delete all of those rows. So I'll select all of this and I'll click on execute. So you see that 8 rows have been affected. Now let me type the select statement and have a glance at the modified employee target table. Select star from employee target. I'll select this. I'll click on execute. Right, so this is our modified employee target table. So we also have our original employee target table over here. So let me compare these two tables. So we see that initially Sam's salary was $95,000 and his age was 45. And after applying the merge statement, his salary changed to $93,000 and his age changed from 45 to 40. Similarly, Anne's initial salary was $125,000 and after applying the merge statement, her salary changed to $130,000. And then with the merge statement, we have also inserted the records with employee ID 7 and employee ID 8 and deleted these two records from the employee target table. Now let's have a look at the syntax to add a column to an existing table. So we'll start off by giving the keywords alter table, then we'll give the name of the table. After that, we'll give the add keyword and the name of the column which we want to add to our table. And finally, we'll have to assign a data type to this new column. So to our existing employee table, I'll add a new column, date of birth, using the alter table statement. So let me start with the syntax, alter table, then I'll give the name of the table, which would be employee. After that, I will give in the add keyword and then give in the name of the column. So I'll name the new column to be EDOB, which would stand for employee date of birth. And then I'll finally give the And then I'll finally give the data type of this new column. So the data type would be date. So I'll put a semicolon, I'll hit execute. So commands have been completed successfully. Now let me have a glance at the modified table. Select star from employee. Right. So we see that this new column, employee date of birth, has been added. So you see that this new column, employee date of birth, has been added to our employee table. Now let's see how can we drop a column from a table. Again, we'll start off by giving the keywords alt table, and then we'll give the table name. After that, we'll give the keywords drop column and specify the name of the column which is to be dropped. So I want to drop this new column which I have just added to this employee table. So let me write the command for that. So I want to drop this new column EDOB which I have just added to this employee table. So let me write the command for that. Alter table, and then the name of the table is employee. Alter table, and then the name of the table is employee. After that, I will give in the keywords drop column, and I want to drop the EDOB column from this employee database. I'll put a semicolon, hit execute. So again, the commands have been successfully executed. Now let me have a glance at the modified table. Select star from employee, I'll put a semicolon, execute. So again, the new column which you had just added has been dropped. So temporary tables basically help us to store and process intermediate results. Now these temporary tables are created in the temp DB and are automatically deleted when they're no longer used. So the temporary tables could be very useful in cases wherever we need to store temporary data. And this is the syntax to create a temporary table. So first we'll give the keywords create table, and before we give the name of the temporary table, we'll precede it with a hash. So this hash symbol basically signifies that the table which we are creating is temporary. So let's work with some temporary tables now. So let me create a temporary table with the name student, which has two columns. One is student ID, another is a student name. So I'll type create table, I'll put in the hash symbol, and then give the name of the temporary table, which would be student. So now this would have just two columns. First would be student ID, so SID, and this is of integer type. Then we have the student name, so I'll name the column as SName, and this is of variable length character of maximum length 20. So I'll put a semicolon over here and I'll hit execute. Right, so we see that the commands have been completed successfully. Now I've already stated that this temporary table is stored in the temp DB. So let me show you guys where the temp DB is actually. So you'd have to click on the system databases, and over here you will see the temp DB. And inside temp DB you have all of the temporary tables. So let me refresh this. Right, so we see that we have this temporary table student inside our temp DB database. Now similarly, I can also use the select statement with this temporary table which I've created. So I'll type select star from, and before giving the name of the table, I need to give the hash symbol and then give the table name, which would be student. Right, so let me select this and I'll click on execute. Right, so this is our table and we don't see any values because we haven't inserted any into this table. So similarly, we can also use the insert command and insert some values into this temporary table. So I'll type insert into, after that I'll give the hash symbol and then give the name of the temporary table, which would be student. I'll follow it up with the values keyword and then give the values which are to be inserted inside this. So first is the student ID, which will be 1. Then I'll give the name of the student. So name of the student is Sam. So again, I will select this and I'll click on execute. So one row has been effected. Now I'll select this line again and I'll hit execute. Right, so we have successfully inserted this record inside our temporary table student. In this session, we'll be working with some basic functions in SQL. So we'll look at the min function, max function, count function, sum function, and average function. Let's start with the min function. The min function gives the smallest value in a column. Let's look at the syntax. First we give in the select keyword, then we give the min function, and inside the parenthesis we specify the name of that column from which we are supposed to find the minimum value. So I want to extract the age of the youngest employee of the company. So this would be the command for that. Select, and then I'll use the min function and then pass in the column, which would be EH. I'll use the from keyword and then given the name of the table, which would be employee. So the total command is select minimum of EH from employee. I'll hit execute. So we see that the minimum age in the table is 21. Similarly, if I wanted to extract the salary of that employee who would get the least salary, so the command would be select min, and instead of EH, it would be eSalary from employee. So the salary of the employee who earns the least is $73,000. Then we have the max function. The max function gives the largest value in a column. Here again we give in the select keyword, following which we give the max function, and inside the function we specify the name of the column from which we're supposed to get the maximum value. Now I'd want to extract the maximum age and maximum salary from this table. So this would be the command for that. Select, and I will start off by extracting the maximum age. Inside the max function I will pass in the column which is E of age, and then I'll use the from keyword and then given the name of the table which is employee. So the maximum age of an employee is 45. Similarly, I want to find out the maximum salary. So that would be E salary from employee. Execute. So the maximum salary is $159,000. Then there's a count function. So the count function returns the number of rows that match a specified criteria. That is, if we wanted to find out the number of male and female employees in a company, then we can use the count function. Let's look at the syntax. So after the select keyword, you will use the count function and given an asterisk inside the parenthesis. Then you will give the table name, and finally you will use the where clause to give the condition. So let's use this count function to get the count of number of male and female employees. So I'll start off by getting the count of number of male employees. So select, I will use the count function, and inside the count function I will pass in the asterisk symbol. After which I'll use the from keyword and then given the name of the table which would be employee. Then using the where clause I will give in the condition. So I'd want the count of all of the male employees. So E of gender should be equal to male. Let me see what do we get. So there are 4 male employees in total. Similarly, if I wanted to get the count of all the female employees, the command would be select count of star from employee where E gender equals female, right? So this would be the only difference. I'll hit execute. So I get 2. So there are 2 female employees in the entire organization. Then we have the sum function. So the sum function would give you the total sum of a numeric column, and this is the syntax. So here similarly we will give in the sum function after the select keyword and give the column name inside the parenthesis. So I want to get the total sum of salaries of all of the employees, right? So the sum of salaries of all of the employees. Select, and then I'll use the sum function and then I'll pass in the column which would be E salary from the name of the table which is employee. So the total salary of all of the employees included is $644,000 per annum. And finally we have the average function. So the average function gives us the average value of a numeric column, and the syntax is same as the rest. So we'll give in the average function after the select keyword and give the column name inside the parenthesis. So this time I do want to get the average age of all of the employees. So select, and then I will use the AVG function and then give in the column which would be EH from the name of the table which is employee. So the average age of all of the employees is 30. So first we have the ltrim function, which helps in removing the blank spaces on the left side of the character expression. So let's implement this function in SQL. So let me first create a string with some blank spaces on the left side. So I'll type select, and then I will give some blank spaces on the left side. Now let me pass in a string and I'll name the string to be Sparta. I'll hit execute. Right. So this is the string which has some leading spaces on the left side. Now if I want to remove all of these blank spaces on the left side, all I need to do is use the ltrim function. So I will type select ltrim, and inside this I will pass in the string with the leading spaces. So I'll copy this and I will paste it over here. Now let me execute both of this simultaneously, right? So this is the string with the leading spaces, and when we use the ltrim function, all of those blank spaces on the left side were removed. Then we have the lower function, which basically converts all the characters to the lower case. So let's look at an example. This time, let me actually print a string which has all the characters in capitals. So this is Sparta. So here we see that all of the characters in the string are in capitals. I'll execute this and this is what we get. Now if I want to convert all of the characters into lowercase, I can just use a lower function. So I will type select lower and then pass in the string inside the function. I'll copy the string. I will paste it inside this. I'll hit execute. So this is the string where all the characters were in capitals, and after using the lower function, this string where all the characters were in capitals have been turned to lowercase. Similarly, we have the upper function, which basically converts all the characters to uppercase. So this time I will take in a string which has all the characters in lowercase. So select, I will type hello world. Let me print this, right? So here we see that initially all of the characters are in lowercase. Now after this, I will type select upper and then pass in the string inside the function. I'll copy this. I will paste it over here. I'll hit execute. So this was our initial string, and after using the upper function, we have converted the string into capital case. After that, we have the reverse function, which basically reverses all the characters in the string. So let's implement this too. So let me take in a random string again. Select, and I will type I love ice cream. I'll hit execute. So this is what we get initially. Now after this, I will use the reverse function. Select, reverse, and I will pass in the string inside the reverse function. I'll copy it and I will paste it inside this function over here. Now let me execute. So this is the initial string, and after using the reverse function, we have reversed all of the characters in the string, right? So you see that this is the starting and this is the ending over here. And after reversing it, we get this final string. And finally, we have the substring function, which gives us a substring or part of the string from the original string.
Let's have a quick quiz question, guys. And the question is, which of the following best describes the purpose of SQL? Option A, a programming language for creating websites. Option B, a database management system. Option C, a high-level language for scientific calculations. And option D, a language for managing and manipulating relational databases. Please do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Now let me give in the original string first. So I will type select, and then the string would be this is Sparta. Now let's say I would want the substring Sparta from this entire string. So this is where we can use the substring function. So I will type select substring. Now the substring function takes in 3 parameters. First is the original string. So I will copy the original string and I will pass it into this as the first parameter. Now after that, I need to give in the index value from where the substring starts. So this is the first character of the substring which I want. So the index value would be 1, 2, 3, 4, 5, 6, 7, 8 and 9. So I'll type 9 over here. And then the third parameter would be the length of the substring. So the length of the substring is 1, 2, 3, 4, 5 and 6. So I will pass in 6 over here. Now let me execute all of this and let's see what do we get. So this is the original string, this is pada, and after using the substring function, we have extracted only this part from the entire string. So the SQL case statement helps us in multi-way decision making. So let's take this example to understand case statement properly. Let's say there are 10 buttons starting from 1 to 10. So if the person selects 1, then he wants tea. If he selects 2, then he wants to order coffee. Similarly, if he selects 3, then he wants milk. And for any other case, the person will order water. So this is basically how the case statement works. So the case statement goes through conditions and returns a value when the first condition is met. And this is the syntax for the case statement. So we'll type in case, following which we'll give the when keyword and give the first condition. After that, we'll type then and specify what will happen if this condition is satisfied. And we'll do the same for the rest of the conditions. After that, we'll type else and state what will happen if none of the above conditions are satisfied. Finally, we'll give the AND keyword. So now let's go to SQL Server and start working with the case statement. So I'll check some conditions using the case statement. So first I'll check if 10 is greater than 20, and if this evaluates to true, I'll just print 10 is greater than 20. After that, I'll check if 10 is less than 20, and if this condition evaluates to true, I'll print 10 is less than 20. And if none of these two conditions evaluate to true, I'll just print 10 is equal to 20. So let me write the syntax for that. Select, I'll give the case statement, then type when and give the first condition, which would be 10 is greater than 20. I'll type then and state what will happen if this condition is evaluated to true. So I'll just print 10 is greater than 20. Then I'll type when and then state the second condition, which would be 10 is less than 20. I'll type then, and if this condition evaluates to true, I have to print 10 is less than 20. And if none of these conditions evaluate to true, I'll type else and just state 10 is equal to 20. And I'll finish off the case statement with the AND keyword. So let me hit execute. So you get the result, 10 is less than 20. So we get this result because the first condition has been evaluated to false. Because obviously 10 is not greater than 20. And since 10 is less than 20, this has been evaluated to true and we print 10 is less than 20. So now let's also implement this case statement on top of our employee table. So before we do that, let us actually have a glance at the employee table. So I'll type select star from employee. Right, so this is our employee table. Now using the case statement, I would want to add a new column, grade, which would be dependent on the salary column. So if the salary is less than $90,000, the grade would be C. If the salary is between $90,000 and $120,000, the grade would be B. And if the salary is greater than $120,000, the grade would be A. So let me write the syntax for that. So I'll type select and I want all of the columns from the employee table. I'll type start and I'll add a new column grade and I'll be getting the values in this column with the help of the case statement. So I'll type case and then type the when keyword and give the first condition. So the first condition would be E salary is less than $90,000. And if this evaluates to true, the grade would be C. I'll type when and say the second condition. So the second condition would be if E salary is less than $120,000. So here, if the first condition is evaluated to false, then it would mean that the salary is greater than $90,000. And after that, we'll check if the salary is between $90,000 and $120,000. And if that evaluates to true, the grade would be B. And if none of these conditions evaluate to true, that would mean the salary is greater than $120,000. So I'll type else, and then the grade which I want is A. And I'll finish off this case statement with the AND keyword. And I want all of this from the employee table. So I'll type from and then give the name of the table, which would be employee. I'll type go. I'll select all of this and I'll hit execute. Right, so we see that this new column grade has been added to the employee table. And this grade column is dependent on the salary column. So here we see that the salary is between $90,000 and $120,000. That is why the grade is B. Here the salary is less than $90,000. The grade is C. And over here, the salary is greater than $120,000. That is why the grade is A. So this is how we can work with a case statement in SQL Server. In this session, we will work with the if function in SQL. So the if function is an alternative to the case expression. This if function takes in a Boolean expression as the first parameter and returns the true value if the Boolean expression is evaluated to true. Similarly, returns the false value if the Boolean expression is evaluated to false. For example, let's say in the Boolean expression we are checking if the marks scored by a student are greater than 50, and if it evaluates to true, we'll return pass, and if the Boolean expression evaluates to false, we'll return fail. So this is how the if function works. Now let's implement this if function in SQL. So using the if function, I'd want to check if 10 is greater than 20, and if it evaluates to true, I'll print 10 is greater than 20. On the other hand, if it evaluates to false, I'll print 10 is less than 20. So let me write the syntax for that. I'll type select. After that, I'll use the if function and pass in the first parameter, which is the Boolean expression. So 10 is greater than 20. And if it evaluates to true, I would want to print 10 is greater than 20. On the other hand, if it evaluates to false, I would want to print 10 is less than 20. I'll hit execute. Right, so what we get is 10 is less than 20. So we get this result because this Boolean expression has been evaluated to false and it is redirected over here and we get the false result, which is 10 is less than 20. Now I'll go ahead and also implement this if function on top of the employee table. So before I do that, let me actually have a glance at the employee table first. So I will type select star from employee. So we have our employee table right in front of us. Now using the if function, I'd want to add a new column employee generation, and that new column would be dependent on this age column. So if the age of the employee is greater than 30, then the new column would have a value old employee. Similarly, if the age of the employee is less than 30, then the value in the new column would be young employee. So let me write the syntax for this. I will type select and list down all of the columns which I want from the employee table. So I want the employee ID column, employee name column, employee age column. Now after this, I will use the if function to add the new column. So I'll give the first parameter, which would be the Boolean expression. So here I will check if E of age is greater than 30. And if the age is greater than 30, I would want the value to be old employee. On the other hand, if the age is less than 30, I would want the value to be young employee. Now I will name this new column as employee generation. So let me just type the name of the column employee generation over here. And I would want all of this from the table employee. Now I'll select this. I'll hit execute. Right. So we see that a new column has been added to this. And the name of this column is employee generation. So here, if we have a glance at this age value, it is 45. And the corresponding value in employee generation is old employee. Similarly, here it is 21. And since the value is less than 30, we get young employee. And these two, it is 25 and 30. And since these two values are also not greater than 30, we have young employee over here. And Matt, whose age is 33, we have the value old employee. And we have Jeff, whose age is 27. He's a young employee too. So these are the two types of user-defined functions in SQL. We have scalar-valued functions and table-valued functions. We'll start with the scalar-valued functions. So as the name states, a scalar-valued function always returns a scalar value. So a scalar value could be int, varchar, date, and so on. And this is the syntax for a scalar valued function. So we'll type create function and then we'll give the function name. And inside the parenthesis, we'll specify the names of the parameters and their data types. And since the function is going to return a value, we'll type the returns keyword and specify the type of data which will be returned. After that, we'll type as begin and then give the function body and then return the final scalar value. Finally, we'll use the end keyword to end the function. So let's go to SQL Server and create our first scalar valued function. So I'm going to create a scalar valued function which will take one integer value, add 5 more to the original value and return the updated value. So let me type the syntax for that. Create function, and then I'll give the function name, which would be add phi. And inside the parenthesis, I'll pass the first parameter. So I'll name the parameter to be num, and this would be of integer type. After that, I'll type the returns keyword, and then the type of data which we'll be returning is also of integer type. After that, I'll type as begin, and since all we have to do is add 5 more to the original value, so I'll not write anything inside this. So I'll directly type the return keyword, and inside this return keyword, I will add 5 more to the parameter value. So that would be @num plus 5. So what we are basically doing over here is the value which is sent as parameter inside this function, will take it and add 5 more to that value and then return it. And finally, I'll type the n keyword to end this function. So let me hit execute. Right, so we have successfully created this add 5 function. Now let me go ahead and call this function. So to call the function, I'll type select, and then I'll have to type dbo dot, and then I'd have to give the function name, which is add 5. Now let's say I'll pass in the number 10. I'll select this, I'll hit execute. Right, so we see that this function works properly. So I've sent 10 and the result which we've got is 15. Similarly, let me send 100 as the parameter. Now I'll select, I'll hit execute. Right, so the value which is returned is 105. So this is how we can create a scalar valued function. Then we have table valued functions. So these table valued functions return a table instead of a scalar. And this is the syntax for a table valued function. So here the return type is table. So after the returns keyword, we'll type in table because we are supposed to return a table. After that, we'll give the keywords as return and then give in the select statement. Now you need to keep in mind that there are no begin and end keywords for the table valued function. So let's go to SQL Server and create our first table valued function. Now I'll be creating a function which would help me to individually extract the male employees and the female employees from the employee table. So before I do that, let me actually have a glance at the employee table first. So I'll type select star from employee. Right, so we have this employee table right in front of us. Now let me go ahead and create the command. So again, I'll type create function, and then I'll give the name of the function, which would be select gender. Now inside the parenthesis, I will pass in the parameter. So I'll name the parameter to be gender, and this would be of varchar type. So as varchar, and the length would be 20. After that, I'll give the returns keyword, and since this is a table valued function, the return type would be table. So I'll type as return and then give in parenthesis, and inside the parenthesis I will give my select statement. So the select statement would go something like this: select star from employee where gender is equal to @gender. So this gender is basically the gender column from the employee table, and this @gender is the parameter which will be passing inside this function. So let's say if the user passes the value male inside this function, then we'll be extracting all of the records where the gender value is male. Similarly, if the user passes the value female inside this, then we'll be extracting all of the female employees from this table. So let me select this, let me hit execute. Right, so we have also created this select gender function. So now using this function, let me extract all of the male employees from the employee table. So to do that, the syntax would be a bit different. Select star from, and then I'll type dbo dot and then give the name of the function, which would be select gender, and inside the parenthesis I will pass in the value, and since I want all of the male employees, I'll type male over here. Right, so I'm typing select star from this because this will basically return a table, and from the table which is returned, I would want all of the records. So let me select this, I'll hit execute. Right, so we have successfully extracted all of the male employees from the employee table. Similarly, if I'd have to extract all of the female employees, the syntax would be similar. So I'll type select star from, and then I'll type dbo.select gender, and then I will pass in the value female. I will select this, I'll hit execute. So again, we have successfully extracted the female employees from the employee table. So this is how we can create table valued functions in SQL. So the select function helps us to manually select one or more columns from the entire data set. So let's go to RStudio. Right, so we are back to RStudio. Now I'll just use the view function to have a glance at the data set. So I'll type out view of customer churn. Right, so we have our data set in front of us. Now I'll load the deployer package first. I'll type out library of deployer because we would have to use the select function from the deployer package. Right, the loading of the package is done. Now we can finally work with the select function from deployer package. Right, so let's say I would have to select the second column from the entire data set. So that is, I would just want the gender column. So what I'll do is I'll type out select. I'll give the name of the data set, which will be customer churn, and following which I'll give the number of the column. So this will be the second column, and I will save this in, let's say, C_2. So let me have a glance at this now. I'll type view of C_2. So we have used the select function to just select the second column, which is the gender column from the entire customer churn dataset. Now let's say similarly we would want to select the tenure column from this entire dataset. So let's do the same thing. I'll type out select over here. I'll give the name of the dataset, which is customer churn, and I'll give the column number. So tenure is at number 6. I'll give 6 over here, and I'll save this in C_6. Right, view of C_6. Right, so from this entire customer churn data set, I just wanted this tenure column, and I use the select function to do that. Right, now let's say I would want a bunch of columns from this data set. So I would want column number 1, 4, 7, and 12. So how can I do that? So for that, I'll be using the select function again. So let me just show it to you guys. I'll type out select, and I'll give the name of the data set. Now all I have to do is give out the numbers of all of the columns that I want. So I would want column number 1, column number 4, column number 7, and column number 12. Right, and I will store this in C bunch. And let me have a glance at this now. View of C_bunch. Alright, so column number 1, 4, 7, and 12. So let me just verify if these are the right columns or not. So 1, 2, 3, and 4. 4 is partner, right? So 4, 5, 6, 7. 7 is phone service, which is right again. So 8, 9, 10, 11, 12 is device protection, which is what we have. So again, from the entire customer churn dataset, we have selected the 1st, 4th, 7th, and the 12th column. Now let's just see if we wanted the sequence of columns. That is, if I wanted all of the columns from, let's say, starting from column number 5 to column number 10. That is, so this would be the column number 5. So from here till column number 10. Now we can again use the select function for that. So all you have to do is give the name of the data set, and after the name of the data set, so I will start with 5. I'll give a colon, and I'll go till 10. That is, I am selecting all of the columns from 5 to 10, and I'll store this in, let's say, C_5_10. Now let me have a glance at this view of C_5_10. Alright, so this is the 5th column, and this is column number 10. So let's just verify. So right, this is dependence, and next we have over here, which is online security. Right, so we have this continuous bunch of columns starting from column number 5 to column number 10. Right, now, so this was one way by giving the column numbers. So we can actually give the column names as well to select those columns. So, right, so if I wanted the gender column, I can also give the name of the column. So I'll start off by giving the name of the data set. Then I'll just give the name of the column that I want. So let's say I would want the gender column. I have given the name of the column, and I'll store this in, let's say, C_gender. Let me have a glance at this now. View of C_gender. right? So I've just selected this gender column from this entire data set. Now, similarly, if I wanted the gender column, tenure column, and partner column, I could use the same thing. So I'll type out select, I'll give the name of the data set. And since I want gender column, I'll type gender. I need the partner column, so I'll type partner. And I need the tenure column, I'll type out tenure. And I'll store this in C underscore. I'll give this as GPT. Right. Let me have a glance at this view of C underscore GPT. Right, so from the customer churn dataset, I have selected gender, partner, and tenure columns. Right now, again, let's just say if I wanted all of the columns starting from gender to, let's say, contract over here, I can do that. So all I need to do is use the select function, give the name of the dataset, and starting from gender, right? So I'll type out gender over here till contract. So let me just see if C is capital or small. So it's capital over there. I'll type out contract. Right. And I'll store this in C underscore gender underscore contract. Right. So view of C underscore gender underscore contract. So this is our result where we have selected all of the columns starting from gender column to contract column. Right. So now R also provides us a feature with which we can select certain columns starting with a particular string. So let's just say I would wanted those columns where the column name starts with streaming. That is, I would want these two columns. And since both of the column names starts with streaming, let me see what I can do with select. I'll use select, I'll give the name of the data set, and then I'll use the starts with attribute over here. Right, and inside starts with, I'll just type stream. And I will store this in C underscore stream. Right, so let's see the result, view of C underscore stream. So with the help of starts with attribute, I have selected the streaming TV and streaming movies columns. So similar to starts with, we also have the ends with column. Now over here, let's say we have, we would have the monthly charges and total charges columns with end with the tag charges. So now I would want to select all of those columns which end with charges. So I can use select for that again. So I'll type out select. I'll give the name of the dataset, which is customer churn, following which I'll type ends with, right? And inside ends with, I will give charges. Now I'll store this in C underscore charges. So let me have a glance at this view of C underscore charges. Right, so from the customer churn dataset, I have selected monthly charges and total charges columns. So this was all of the implementation which we could have done with the select function. So let's go to our studio. Right, so we are back to our studio. Now what I'll do is I'll start off by having a look at the dataset. So I'll type view of customer churn, which is the dataset. Right, so we have our data set right in front of us. Now I'll also load the deployer package. So I'll type library of, and I'll give the name of the package, which is deployer. So we have loaded the package. Now we can happily work with the filter function. Right, so let's say I would want to filter out all of the female customers from this customer churn data set. So for that, we can take the help of filter function. So I'll type out filter. Then I'll give the name of the data set, which is customer churn, following which I'll give the column, which is gender. Now from this gender column, I would need only the female customers. So I'll type the value, which is female. Right, and I will store this in, let's say, C underscore female. Right, so let me have a glance at this now. So I'll type view of C underscore female. Right, so if you have a look at this gender column, we see that all of the values are female. So basically we have used the filter function to filter out all of the female customers from this data set. And we see that there are around 3,488 female customers. Right. Now, similarly, let's say if I would want to filter out all of those customers whose monthly charges are more than $100. Right, so again, let me go ahead and use the filter function. I'll give the name of the dataset, which is customer churn. Now, I'll give the name of the column, which is monthly charges. Right, and over here, I would want the monthly charges to be more than 100. Right, so I'll give monthly charges greater than 100. And I'll store this in, let's say, C underscore high paying customer. Now let me have a glance at this. I'll type C underscore high paying customer. Let me go to the monthly charges column. Right, so we see that all of the values are greater than 100, and there are around 902 customers whose monthly charges are greater than 100. So just to be sure, let me use the range function to find out the range of monthly charges. So I'll type range of C underscore high paying customer dollar monthly charges. Right, so the range starts from 100 to 118. Right, so we are done with this. Now we'll give multiple conditions by using the AND operator. So let's just say I would want all of the female customers whose monthly charges are greater than 100. So let's go ahead and do that. I'll type filter. I'll give the name of the data set. Right, and I'll give the condition over here. So first condition is I would need all of the female customers. So I'll give gender is equal to female. And the next condition is the monthly charges need to be greater than 100. So I will type monthly charges is greater than 100. And I'll store this in, let's say, C underscore high female. Now let me have a glance at this. So view of C underscore high female. Right. So we see that the gender, it comprises of only female customers, and the monthly charges is greater than 100. And we see that there are around 461 female customers whose monthly charges are greater than 100. So similarly, now what we'll do is we'll use the AND operator to find out all of the customers who subscribe to both streaming TV as well as streaming movies. So I'll type filter, give the name of the dataset, which is customer churn. So first condition is the customer needs to have subscribed to streaming TV. So streaming TV is double equal to yes. And the next condition, which is streaming movies. Right. And streaming movies is also equal to yes. So now I'll show this in C underscore stream. So let me have a look at the result. View of C underscore stream. Right. So we see that there are around 1940 customers for those who have subscribed to both streaming TV and streaming movies. Now what we'll do is we'll give three conditions. So let's complicate this a bit more. So let's just say I would want to find out all those customers whose tenure is greater than 50 and whose internet service is, let's say, DSL, and whose contract is, let's say, 1 year. Right, so let's go ahead and give all of these filter, give the name of the dataset, which is customer churn. So the first condition is tenure needs to be greater than 50 and the internet service, which should be DSL. Right, so internet service is double equal to DSL over here, and I'll go ahead and also give the third condition, which is the contract Right, so the contract needs to be of 1 year. I'll store this in, let's say, C underscore EIC. Right, now let me have a glance at this. View of C underscore TIC. Right, so let us first have a glance at the tenure. So we see that tenure is greater than 50 everywhere. Next comes the internet service. So we see that the internet service is DSL. Next comes the contract. So here is a contract and the contract is 1 year. So we see that all of these three conditions have been satisfied. There are 188 customers whose tenure is greater than 50. Their internet service is DSL and their contract is of 1 year. Right, now we'll go ahead and work with OR operator. Now let's just say we would want to find out all those customers whose payment method is either mailed check or electronic check. So let's filter for that. Filter, give the name of the dataset, which is customer churn. So now I'll give the name of the column, which is payment method, and this could be either electronic check or mail check. So right, electronic check. Now I'll give OR logical operator. Again, I'll type payment method as double equal to mail check. Right, and I will store this in, let's say, C underscore pay, view of C underscore pay. Let me directly go to the payment method column. So where is it? Right, so here we have. So now we see that the payment method is either mail check or electronic check. And in total, there are 3,977 customers whose payment method is either mail check or electronic check. Right. So now what we'll do is we'll use the AND logical operator and also the OR logical operator in conjunction. So we'll complicate this a bit more again. Right, so now let's just say I would want to select all of those customers whose let's say contract is either 1 year or 2 year, and also the gender is male. Right, so we'll use the filter condition for it. I'll give the data set, which is customer churn. Right, so now over here I'll use the OR operator. So now our first task is to select all of those customers whose contract is either 1 year or 2 year. So I will type contract as double equal to 1 year. I'll use the OR logical operator. Again, the next condition would be contract is double equal to 2 year. Right, so this is how we have filtered out all of those customers whose contract is either 1 year or 2 year. Now we're not done yet. I'll use the AND operator to make sure that the gender is a female. So I'll type AND gender is equal to female, and this completes our filter command. And I'll save this in C underscore con underscore gen. So let me have a glance at this now. View of C underscore con underscore gen. Right, so I see that the gender is female. Now let me also see the contract. So the contract is either 1 year or 2 year. So let me verify this. So I'll type table C underscore con underscore gen dollar gender. Right, so we have only female customers. Again, similarly, let me check the contract now. Right, so again, the contract is only 1 year or 2 year. Right, so there are no customers who have month-to-month contract in this data set. So now let's go ahead and use some other complicated filter operation. Now I feel like filtering out all of those customers whose internet service is either DSL or fiber optic, and let's say also their tenure is greater than 50, and their monthly charges are greater than 100. So let's go ahead and impose all of these conditions. For that, I'll type filter. I'll give the name of the data set, which is customer. Right. So now let me give my first set of conditions where I'm filtering out those customers where the internet service is either DSL or fiber optic. Right. So I'll type internet service is double equal to DSL. I'll use the OR pipe operator, and again the internet service could be fiber optic. Alright, so we are done with the first OR condition over here. So the customer has to use either DSL internet service or fiber optic, and I'll use and. Now I will give the second set of conditions where I would want the tenure to be greater than 50. So I'll type tenure is greater than 50. Again, I'll use the AND logical operator to select all of those customers whose monthly charges are greater than 100. Right, so I'll type monthly charges is greater than 100. And I'll save this, and let's say C underscore complicated. Let me have a glance at this. View of C underscore complicated. Right. So let's start off by checking the internet service. Right. So internet service is mostly fiber optic, which is true. So it either needs to be DSL or fiber optic. Right. And the next condition was of tenure. So the tenure had to be greater than 50, which is again true. And then the next was monthly charges. So the monthly charges had to be greater than 100, which is also true. Right. So these were some of the examples of the filter function.
Let's have a quick quiz question, guys. And the question is, what is RStudio? Option A, a popular programming language for building websites. Option B, an integrated development environment or IDE for the R programming language. Option C, a statistical software used exclusively for data visualization. And option D, a text editor for writing Python code. Please do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
With the help of Mutate, we can add new columns to our existing data frame. So let's go to RStudio and add some new columns to our customer churn dataset. Right, so we are back to RStudio. Now I'll start off by having a glance at our customer churn dataset. So I'll type view of customer churn. So we have our dataset right in front of us. Now I'll also load the deployer package. I'll type library of deployer. We have loaded the deployer package. Now mutate is a part of the deployer package. So I'll use this mutate function to add a new column age to this. So you see this already existing column senior citizen, which has values zeros and ones. So if the value is 0, this basically means that the customer is not a senior citizen. And if the value is 1, then this means that the customer is a senior citizen. So depending on these values, I'll generate a new column age. So in that new column, if the customer is not a senior citizen, then I will give his age to be somewhere between 16 to 55. And if he is a senior citizen, then in the age column, I'll generate a value which is somewhere between 56 to 100. So let me go ahead and use the mutate function to do that. Right, so I will type mutate over here. Now the first parameter is the name of the dataset, which will be obviously customer churn. Right, Now after this, I will give the name of the new column, which will be age. Now this age I will generate with an if else clause. So I'll type if else, and the condition depends on this column. So I will type over here senior citizen is double equal to 0. Right, so I have given the test condition over here if senior citizen is double equal to 0, or in other words, if the customer is not a senior citizen, then I will generate a random value which is somewhere between 16 to 55. And similarly, if the customer is a senior citizen, then I will generate a value which is between 56 to 100. Right. So I'll explain this once again. So first I've given the name of the dataset, then I've given the name of the new column. And in this I'm using the if else clause, and here I give the test condition. So if the customer is not a senior citizen, then I'll generate a value in the age column which will be somewhere between 16 and 55. And if the customer is actually a senior citizen, then I'll generate a value which will be somewhere between 56 and 100. Right, so let me copy this, let me paste this over here, and I will store this back into the customer churn dataset. Right, so let me have a glance at this dataset now. View of customer churn. So this is our dataset. Let me maximize this and show it to you. So we see that initially we did not have this age column, but after using the mutate function, we have generated this age column. So let me just verify this properly. So we have the senior citizen column over here. So from row number 1 till row number 21, there is no senior citizen. So let me just verify. So all of these ages are less than 55 over here. So 52, 29, 25. So let me go ahead and see where does the first senior citizen come. So over here the age is 72, and let me verify over here again. Right, so this guy is a senior citizen, and that is why we have generated a value which is above 55 for this guy. And then we have age of 85 over here. So let's verify this again. So this guy again is a senior citizen. That's why we have sampled a random number 85 to this guy. Right, now similarly we will add another column. So you see the monthly charges over here. So let me actually check the range of monthly charges. So I'll type range of customer churn dollar monthly charges. So we see that the range is somewhere between $18 to $118. Now depending on this range, I will create a new column which will classify the customer into 3 categories. So the first customer will be a low paying customer, the next would be medium paying, and the third would be high paying customer. Right, so let me do that using the mutate function again. So let me delete this. I will type mutate again. I will start off by giving the name of the dataset. Now after giving the name of the dataset, I need to give the name of the column which I need to generate. So I'll name this column as customer category. Alright. Now again, I will generate this with the help of if else clause. So over here, I will give the test condition. So the test condition is dependent on monthly charges. So let's say these would be my conditions over here. So if the customer's monthly charges are less than $45, then I would categorize him into low paying customer. And if his monthly charges are somewhere between $45 to $90, then I'll categorize him as a medium paying customer. And if his monthly charges are more than 90, then I'll categorize him as a high paying customer. Right, so I'll give the first condition, so which will be if monthly charges are less than 45. Right, then over here, if this is true, I just need to give a value which will be low paying. Right, now if the monthly charges are not less than 45, so over here I will give another if else condition, right? And so in this if else clause, I will generate another condition. Now I will check if monthly charges are less than 90. I hope all of you guys are following this properly, right? So if else of monthly charges is less than 90. So what is basically happening is, if this is true, then he'll be categorized into low paying. If this is not true, or in other words, if this is false, then this will be evaluated. And again in this, I am giving two conditions. So now over here, if his monthly charges are between 45 and 90, I will categorize him as medium paying. And if this is false, then that would basically mean that his monthly charges are more than 90. And that is where I will categorize the customer as high paying, right? So I'll go through this code again. So I started off by creating the mutate condition over here, and I gave the name of the data set. And after that, I named the new column to be customer category, and I used the if else clause. And inside the if else clause, I checked if the customer's monthly charges were less than 45. And if his monthly charges were less than 45, I categorized him as low paying. And if this test condition proved to be false, then I generated another if else condition. So if his monthly charges are between 45 and 90, I will categorize him as median paying. And again, if this is false, then finally that would mean that his monthly charges are more than 90, and I categorized him as high paying. Right, so let me select all of this, and let me put it back to customer churn. And now let me have a glance at this view of customer churn. Right, so we have modified the dataset and we have added this new column customer category. So you see this over here. So his monthly charges are 29.85, and since it is less than 45, he's a low paying customer. His monthly charges is 56, which is greater than 45 but less than 90, so he's medium paying. So let's check this guy out, high paying. So his monthly charges are obviously greater than 90, which is 104, and that is why he's a high paying customer. Again, so these all customers over here, they have a monthly charges of greater than 100, and that is why. So sample n and sample frac basically help us to get a random set of values, and count helps us to get the count of different categories. So let's go to RStudio and work with these. So we have RStudio right in front of us, and this is our customer churn dataset. So I'll start off by loading the deployer package. So I'll type library of deployer. And since all of the above mentioned functions are a part of deployer, we had to load this package. So I'll start off with a sample n function. So I'll type sample n. So now this function is used to randomly sample a dataset. Now let's say the network is organizing a lucky draw and it wants to select randomly 10 customers and give them a discount of 50%. And for that purpose, we can use the sample n function. So what I'll do is, I will start off by giving the name of the dataset. So this is the first parameter, and then I will give the size, that is the number of customers that I want to sample or randomly sample. So let's say I want 10 customers, 10 random customers. So I'll give 10, and I'll store this in a new object and name it as random 10. Now let me have a look at the result. So I'll type view of random 10, right? See that these are the 10 random customers which have been selected for lucky draw. Now similarly, let's say if we wanted 100 random customers, all you had to do was type sample n, give the name of the dataset, and then give 100 over here, and I will store this in, let's say, random 100. So I will type random 100 over here. Now let me have a glance at this new object. So I'll type view of random 100. So this is our new data set, which gives us a random set of 100 customers, right? Quite interesting, isn't it? Now similar to sample n, we have another function which is sample frac. So sample frac gives us a fraction of the entire data set. Now let's say I wanted 10% of the entire data set. So for something like that, we can use sample frac. So now if I want 10% of the entire data set, I will give 0.1. and I will store this in random, let's say 10%. Let me have a look at this. View of random 10%. Right. So we get the 10% of the entire data set. So this is the entire data set, which is 7043. Now 10% of 7043 is 704. Right. Now let's again say if I wanted 50% of the entire data set, so I'll give 0.5 and I'll store this in random 50%. Let me have a look at this. I'll type view of random 50%. So 3522. Now let me just divide this 7043 divided by 2. How much do I get? So that's 3521. Again, since we can't get a fractional value of number of rows, so we have got 3522, right? So this is random sampling of the 50% of the data set from the original data set. This is how we can work with sample and sample frac. Now we'll use the count function from the deployer package, and let's learn how to count different categories of this data set. So let's say I would want to find out the number of males and number of females in this column. So all I need to do is type count, give the name of the data set, and then give the name of the column. So name of the column is gender. Now let us see the result. So we see that in total there are 3488 female customers and 3555 male customers. Now similarly, if I wanted to find out the distribution with respect to internet service, so all I have to do is give count, give the name of the data set, and then give the name of the column, which is internet service. Right. So we see that there are around 1526 customers who don't use internet at all. There are 3096 customers who use fiber optic, and there are 2421 customers who use DSL. Now similarly, if we wanted to find out the distribution with respect to contract, so again we will type count over here, give the name of the data set, which is customer churn, and give the name of the column, which is contract. Right. So over here there are 3875 customers whose contract is of type month to month. There are 1473 customers whose contract is of 1 year. There are 1695 customers whose contract is of 2 years. Now similarly, if you wanted to find out how many customers had subscribed for paperless billing and how many did not, all you have to do is count, give the name of the data set, and then give the name of the column, which is paperless billing. Right. So there are 4171 customers who have opted for paperless billing, and the rest of them have not opted for paperless billing. So summarize basically helps you get a nice summary of data, such as getting the mean salary, minimum salary, and maximum salary. Now many times it happens that we want the summarized results with respect to a particular column, such as mean salary with respect to gender or mean salary with respect to age. So let's go to RStudio and work with these. So this is RStudio, and we have our same old customer churn dataset right in front of us. So now I'll go ahead and load the deployer package. Right. And I'll start off by working with the summarize function. Now the summarize function takes in the dataset as the first parameter. So I'll go ahead and give the dataset, which is customer churn. And then since summarize helps us to get summarized results, so let's say I would want to get the mean, minimum, and maximum tenure of a customer. So now let's say I would name this as mean underscore tenure, and all I need to do is give the mean function over here, and inside it give the column. So this is all I need to do. And we finally get the mean tenure of the customer, which is 32 months. Right. So similarly, if I would want to find out the minimum tenure of a customer, I'll change this as min underscore tenure, and I'll change this function to be min. Now let's see the minimum tenure of a customer. So the minimum tenure of a customer is 0. So most of the customers churn out before even completing the first month. Again, similarly, the maximum tenure, I'll change this as max underscore tenure, and this will be max function. Right. So there are some customers who have been using this network for 72 consecutive months. Right. So this was summarized results with respect to tenure column. We'll also do the same with respect to monthly charges and total charges. So I'll type summarize. I'll get the name of the dataset, which is customer churn. Now I do want to find out the mean monthly charges. So I'll name this as mean underscore MC, and I'll give the mean function over here, and inside it I'll give the name of the column, which will be monthly charges. Right. So let's see the result now. So the mean monthly charges of a customer is $64. That is, on an average, a customer spends around $64 per month. Right. So similarly, let's get the minimum monthly charges. So I'll change this to be min over here, and I'll be using the min function again. Right. So the minimum monthly charges are 18.25. And again, let's go ahead and find the maximum monthly charges. So I'll change this to be max over here, and again I'll be using the max function. Right. So there are some customers whose monthly charges are around $118, and these are the highest paying customers. So similarly, let's do the same for total charges column. Summarize, I'll give the name of the data set. Right, and then I would want to find out the mean of the total charges. So I'll name this to be mean underscore TC. I'll use the mean function, and I'll give the name of the column, which will be total charges. Right. So now we see that the result is NA. So why is that? This is because there are some records over here which have NA values in them. So now to change that, all I need to do is include NA.RM equals true. So this will remove all of those NA values. So now let's see the result. Right. So you see that on an average, a customer's total charges are around $2,283. So similarly, let's find out the minimum total charges. I'll change this to be min underscore TC, and I'll be using the min function for this. Right. So the minimum total charges for a customer is $18. Again, let's go ahead and find the maximum. So I will change this to be max underscore TC, and over here I'll be using the max function. Right. So there is a customer who has been paying $8,684, and he's the highest paying customer. Right. So this was the summarize function. Now we'll go ahead and work with group by. So now let's say I would want to find out the mean tenure with respect to the payment method column. So let's see how we can do that. So now again I will type summarize over here, and inside summarize what I'll do is I'll use the group by function. Now over here inside the group by function, I'll give the name of the data set followed by the column by which I want to group. So the column will be payment method. So let me type payment method over here. Right. So now inside the group by function, I've given the name of the data set and the column by which I want to group by. Now after this, I would want to give the summarized function that I want to use. So this is the mean of tenure. So I will name this as mean underscore tenure. Right. And I will be using the mean function, and I will give the column over here. So let's see the result. Right. So we see that we've got 4 results over here. So the mean tenure of a customer whose payment method is bank transfer is around 43.7. Again, the mean tenure of a customer whose payment method is credit card is around 43 months again. And the mean tenure of a customer whose payment method is electronic check is 25 months. And the lowest tenure of a customer whose payment method is mail check is 21 months. Right. So similarly, let's say we would want to group by internet service. So now let me change this to internet service and see the difference, right? So internet service, now let me see the result. So we see over here that if the customer uses DSL, then his average tenure would be around 32.8 months. If he uses fiber optic, then again his tenure is 32.9. But if he doesn't use internet service at all, then his tenure is likely to be lower, which is around 30.5 months. Right, now we'll go ahead and find out the summary results with respect to monthly charges. So I will change this to monthly charges over here. And let's say I would want to group this with respect to partner, right? So I am trying to find out the monthly charges of a customer with respect to if he has a partner or not. So let's see what the result is. This needs to be mean underscore monthly charges. Let's see the result. Right. So if the customer does not have a partner, his monthly charges are likely to be around $61.9. And if the customer has a partner, then his monthly charges are likely to be around $67. Interesting observation, isn't it? Right. So similarly, let's group this with respect to internet service now. So I will change this and put internet service over here. Now let's see the result. Again. Right. So if the customer uses DSL, then his monthly charges would most likely be around $58. And if he uses fiber optic, then his monthly charges are around $90. And if he doesn't use internet service at all, then his monthly charges are likely to be very, very low, which is around $21. So through the course of this module, we have worked with different functions from the deployer package. And now finally, we learn how to combine all of those functions together using the pipe operator. So let's go to our studio and do that. Right. So we have our studio right in front of us. Let me quickly load the deployer package. So I'll type library of deployer. Right. So you have loaded the package. And now I'll show you how the pipe operator looks like. So it is percentage symbol, greater than sign, and the percentage symbol again. So this, what you see in front of you, is nothing but the pipe operator, guys. Right. So now let me use a very simple example to show you guys how the pipe operator works. So this pipe operator basically helps us to join different things. So like two functions or making a connection between the data set and different functions. So now I would want to select the first 5 columns from this customer churn data set. So I can do that using the pipe operator. So I'll start off by giving the name of the data set, which is customer churn. And from this data set, I want to select the first 5 columns. And I am making that connection with the help of this pipe operator. So customer churn, and from this customer churn data set, I will select the first 5 columns, right? And I will store this in, let's say, C underscore 15. Let me have a look at the result. View of C underscore 15. So we've got the result over here where we see only the first 5 columns from the entire data set, and we were able to do this with the help of the pipe operator. Now let me complicate this, and let's say I would want to find out the first 5 columns, and I would also want to filter out all of those records where the gender is male. So let me also do that. So it'll be customer churn, and from the customer churn data set, I would want to select the first 5 columns. And after doing that, I would also want to filter off all of those records where gender is, let's say, male, right? So over here, I've used 2 pipe operators to make 2 connections. From the customer churn dataset, I am selecting the first 5 columns, and I'm also giving a condition by which I'll be filtering records, and that condition is gender needs to be male. Right. So let me save this in C underscore 15 male. View of C underscore 15 male. So this is our result, guys. So there are around 3,555 entries where I have selected only those customers where gender is male and only the first 5 columns. Interesting, right? Okay. So now I'll be using the pipe operator to make a connection between 3 different functions. So I'll be using the filter function, group by function, and summarize function. So let me start off by giving the name of the dataset, which will be customer churn. Right. And from this dataset, I would want to filter off all of those records where internet services, let's say DSL, right? So all of those customers who use internet services DSL, I would want only those records. So for that, I would want to use the filter function, filter, where internet service is double equal to DSL, right? Now, after I do this, I would want a summarized result which gives me the mean monthly charges with respect to the gender column. So for that, I would need the group by and summarize functions. So first, I would have to use the group by function. So pipe operator again, and it'll be group by, and I need to group with respect to the gender. Now, after I do the grouping, I need to have a summarized result where I'll say mean monthly charges equals, right. So I will use the mean function and I will give monthly charges over here, right. So let me have a look at the result. So we've got a result. So this is the result for all of those customers where internet service is DSL, and I have a summarized result which tells me that if the customer is male, then his monthly charges is somewhere around 57.6, and if the customer is female, then her monthly charges would be somewhere around 58.6. Right. So in the next example, I'll be making a connection between select and filter functions. So customer churn. Now what I'll do is I'd want to select the first column, second column, and let's say I would also require the monthly charges and payment method. And after that, I'll be using the filter function to find out all of those customers whose monthly charges are greater than 100 and gender is male, right? Select 1, 2, and I would need monthly charges as well. Monthly charges, and then I require payment method as well. Right. I have selected all the columns that I need. Now I also need to filter out the record. So it'll be filter where monthly charges are greater than 100, and the second condition would be gender equals male. Right. And let me store this in, let's say, C male payment, right? Okay, there seems to be an error over here. So there needs to be a comma here, right? So let me have a look at the result. View of C underscore mail payment. Right, so this is what we wanted. We required these 4 columns and we needed those customers where monthly charges is greater than 100 and also the gender is male, right? So in the next example, I'll be combining group by, summarize, and arrange. So what I need is a summarized result of the mean tenure, and I want it in descending order. So it'll be customer churn, and from this customer churn dataset, I'd have to group it with respect to payment method. Right now, after I do that, I would have to use summarize. It will be mean tenure, and I'll give the mean function. I'll give tenure over here. Right. Now let me have a look at the result first. So now this gives me a result in ascending order. So that is why I'll be using the arrange function as well. So I'll use the pipe operator to join it. Arrange. Right. And I'll arrange it in descending, and it will be payment method. Right. So this was the initial result, and this is the result after arranging it in descending order. So going ahead, we'll be combining select, filter, and arrange. I'll give the name of the dataset. Now I'd want to select the first column, second column, and all the columns from column number 10 to column number 21. So pipe operator again, select first column, second column, and all the columns from 10 to 21. Right. So now after I do this, I would have to filter the records on the basis of contract. So let's say I would want only those records where the customer's contract is 1 year or 2 year. So what I'll do is I will type contract is double equal to 1 year or contract is double equal to 2 year, right? So I have given the filter condition. Now I need to arrange this with respect to the contract itself. So pipe operator again, I will use arrange and this will be contract. So let me store this in C underscore contract. Let me have a look at the result. View of C underscore contract. So this as the result, guys, I have selected the first column, second column, and all the columns from column number 10 to column number 21, right? And the filtering condition was that all of the records were the contract is either 1 year or 2 years, right? And we have arranged it with respect to the contract column only. That is why initially we have all the records where the contract is 1 year, then we have all the records where the contract is of 2 years. Okay, interesting enough, right? Then we'll head to the final example for today's session where I'll be combining filter, group by, and summarize. So again, the name of the dataset, which is customer churn. I'll use the pipe operator, and I would want to filter out all of those records where the paperless billing is no. So in other words, I would want the records of all of those customers who have not subscribed to paperless billing, right? So it will be filter of paperless billing is double equal to no. Now, after I do that, I would want a summarized result with respect to the tenure, and I will group it with respect to, let's say, tech support. Okay. So for that, I would need to use group by, and the column would be tech support. And since I need a summarized result, I would have to type summarize, and I will name this as mean underscore tenure. I'll give the function which is mean. I'll give the name of the column which is tenure. So let's have a look at the result. Right. So this is our result, guys, where we have filtered out only those customers where paperless billing is no. And after that, I have grouped with respect to tech support. And that is why we have three options over here. And the summarized result is with respect to tenure. That is, we have the mean tenure of these three customers. So the SQLDF package is a great resource for RDBMS folks who are working with R. And this package allows manipulation of R data frames with SQL. So let's just go to our studio and start working. Right, so we have our studio right in front of us. And this is our same old customer churn dataset. So my first task would be to load the SQLDF package. So for that, I'll type library of SQL DF. So now that we have loaded the package, we'll start off with the select query. And the select query basically helps us to select some values from the dataset. Now let's just say I wanted to select just the customer ID column from this entire dataset. So for that, I'll type SQLDF and I will give double quotes, and inside the double quotes, I'll type select, and then I'll give the name of the column, which would be customer ID. So select name of the column, which is customer ID, from name of the table, which will be customer churn. So in this case, the table is actually a data frame. So this is how we can select the customer ID column from the entire data set. So the command would be select customer ID from customer churn. And I'll store this in a new object and I'll name this as C underscore ID. Right. So view of C underscore ID. And we have successfully filtered out or selected the first column from the entire data set. Right now, similarly, if I wanted to select multiple columns from the data set, let's just say I wanted customer ID, gender, and monthly charges and total charges from the entire data set. So for that, again, I'll type SQL df of, and I will type select. So the first column would be customer ID, then I need gender, following which I would need the monthly charges column. So I will type monthly charges, and then I would also need the total charges column. Right, so select customer ID, gender, monthly charges, total charges from the name of the table, which will be customer churn. and I will store this in, let's say, C underscore multiple columns. Now let me have a glance at the result. So view of C underscore multiple columns. And this is a result. So we have customer ID, gender, monthly charges, and total charges from this customer churn data set. Right. Now let's say I wanted to select all of the columns from this data set. We can also do that. So for that, the command would be select star from the name of the table, which will be customer churn. And I will store this in, let's say, C underscore all. Let me have a glance at it. View of C underscore all. And I have selected all of the columns from the original set over here, right? So the command is select star from the name of the table, which is customer churn. Right, now we'll go ahead and also learn how to impose a condition with the where clause. Now let's just say I wanted to select all of the columns where gender is male. So for that, the command would be sqldf. So select star from customer churn. After this, I'll give the where clause and give the condition. So the condition would be gender equals. Now kindly have a note over here, guys. So over here, I'll be giving single quotes. Okay. And inside this, I'll give the value which is male. So basically, I would need all of those records where gender is male. And I will store this in, let's say, C underscore male. Let me have a glance at the result. View of C underscore male. If I have a look at the result, I see that we only have male customers. Let me just verify it with the table function. Table of C underscore male dollar gender. And we see that there are only male customers. Now let's say similarly, I wanted to select all of those customers whose tenure is greater than 50. So the command would be something like this: sqldf of double quotes select star from the name of the table, which will be customer churn. I'll give the where clause, and after this I'll give the name of the column, which is tenure, and this needs to be greater than 50, right? And I will store this in, let's say, C underscore high tenure. Right, let me have a glance at it now. View of C underscore high tenure. So if I have a look at it, I see that for all of the customers, the tenure is greater than 50. Again, let me verify by using the range function. So it'll be range of C underscore high tenure dollar tenure. As simple as that, guys. Right? So we see that the tenure starts from 51 months to 72 months. So we have all of the customers whose tenure is at least 51 months over here. And we were able to do this with the help of the where clause. Now again, if I wanted to select all of those customers whose let's say internet service is DSL, again the condition would be something like this. So till here, the command would be the same. Select star from customer churn where, and then I'll give the name of the column, which is internet service. And internet service needs to be equal to DSL. As simple as that, guys. And I'll store this in C underscore DSL. Again, view of C underscore DSL. And this is our result. Let me check the internet service column. So there are 2,421 entries where the internet service is DSL. Or in other words, we have 2,421 customers whose internet service is DSL. So let me verify this by using the table function. So table of C underscore DSL dollar internet service. And we see that there are only customers whose internet service is DSL. Okay, so we are done with it. Now we learn how to impose multiple conditions by using the AND operator. Okay, so now I want to select all of those customers whose gender is male and whose contract is at least 1 year. So all of the male customers whose contract is at least 1 year. So let me go ahead and do that. SQL df So select star from customer churn, then I'll give the where clause, after which I'll give the first condition. So the first condition would be gender equals male, right? And then following which I'll give the AND operator. Okay, so this is what helps us to give multiple conditions. So select star from customer churn where gender equals male and the contract, right? So C needs to be capital over here. Contract is 1 year, right? And I will save this in C underscore mail 1 view of C underscore mail 1. So this is a resultant data set where we see that the gender is only male. Now let me also check the contract, and the contract is 1 year, right? Quite simple. Let me again verify it by using table. So it will be table C underscore mail $1. First would be the gender. So we see that we have only male customers. And then again, let me check the contract. Right, so we see that the contract is of only 1 year. Right, now we'll go ahead and give 3 conditions at the same time. So now I would want to select all of those senior citizens whose internet service is fiber optic and all of them use tech support. Okay, so let me go ahead and do that. SQL df, right? Select star from, I'll give the name of the table, which will be customer churn. I'll give the where clause, and then I'll give the first condition. And the first condition would be senior citizen is equal to true, or senior citizen equals 1. So I'll get the name of the column, which is senior citizen. This needs to be equal to 1. And then I will give the next condition where I want the internet service to be fiber optic. So this actually needs to be A and D. Keep this in mind, guys. Right, so internet service equals fiber optic. And then I'll give the final condition by using the AND operator again. And tech support. Tech support needs to be equal to yes as well. Right. So I will store this in C SIT view of C underscore SIT, and this is a resultant data set. So we see that we only have senior citizens, and then let me check the internet service as well. So internet service is only fiber optic, and then again let me check the final condition. So that will be the tech support. So we see that tech support is yes, and there are 171 senior citizens who use internet service as fiber optic, and they also avail the tech support. So this was the AND operator. Now we'll go ahead and work with the OR operator. Now let's say I would want to select all of those customers whose contract is either 1 year or 2 year. So we can use the OR operator to find that out. SQL df of select star from customer churn where again I'll give the first condition, which will be contract equals 1 year, following which I'll type OR. Then I'll give the second condition, which will be contract equals 2 year. So let me explain it properly now. So till here it's same. So it's select star from customer churn where now here comes the change. So we have 2 conditions over here separated by the OR operator. And now when we use OR operator, when either of these 2 conditions is evaluated to true, then we'll get that record. So if the record we see over here, even if it has 1 year or 2 year, then we'll get it in the result, right? So I will store this in C underscore 1 underscore 2 view of C underscore 1 underscore 2. Let me have a glance at this now. Let me look at contract. So I only have two values which are 1 year and 2 year. Let me verify it by using the table function. So it will be table of, I'll give the name of the data set, C underscore 1 underscore 2 dollar contract. Right. So all of the customers, their subscription is of either 1 year or 2 years. Right. Now, similarly, if I wanted to select all of those customers whose payment method is either mailed check or electronic check, I can use the OR operator for that as well. So I will type SQLDF again, select star from customer churn, where I'll give the first condition. The first condition will be payment method equals electronic check. I'll type R, and the second condition is payment method needs to be mailed check. So let me show this in a new object. I will store this in, let's say, C check. View of C underscore check. Let me have a glance at the payment method column. Right, so we see that all of the records, for them the value is either mail check or electronic check. So in other words, we have filtered out all of those customers whose payment method is either mailed check or electronic check. Right, so this was the OR operator. Now we'll work with the count function, which helps us to find out the count of some categorical columns. So let's say I would wanted to find out the number of male customers or the number of female customers. I can use count for it. So I'll type SQLDF double quotes, select, and I'll type count. And inside count, I'll give the name of the column, and it will be gender. And since I would want to find out the count of all of the female customers, I'll type select count of gender from customer churn, where gender equals female. Right? So there are 3,488 female customers. Similarly, if I wanted to find out the count of all of the male customers, all I needed to do is change this to male over here, and we'll get the result. Right? So we have 3,555 male customers and 3,488 female customers. Now it's finally time to work with group by. So if ever we wanted grouped results like finding out the average tenure with respect to a particular column, or finding out the average monthly charges with respect to a particular column, we can use group by. So now for this purpose, I would want the average tenure with respect to the payment method, right? So let's say some customer whose payment method is electronic check, I would want to know what is his average tenure. Similarly, if someone's payment method is mail check, I would want to know what is his average tenure. So it is group by payment method. So let me write the SQL query for it. Again, SQLDF double quotes, select. Now over here I want to select the average tenure, so it will be AVG. I'll give the name of the column, which is tenure. Now I would also want the payment method beside it, so I will type payment method. Right, so I'm selecting the average tenure and also the payment method, and I want this from the customer churn dataset, and I'll be grouping it with respect to the payment method. So let me have a look at the result. So this is our result over here, guys. So this is the average tenure with respect to the payment method. So if there is some customer whose payment method is bank transfer, then his average tenure is somewhere around 43 months. And if it's credit card, again his average tenure is 43 months. If his payment method is electronic check, his average tenure is 25. If his payment method is mail check, again his average tenure is 21. Right. So now we'll perform the last manipulation operation for today, and we would want to find out the average monthly charges with respect to contract, right? With respect to this column. So I would want the average monthly charges. So over here I will change this to monthly charges, and I would also want the contract column. I'll delete this. I'll put contract over here from customer churn, group by, and I also need to group it with respect to contract, right? Enter. So this is a result, guys. So this is the average monthly charges with respect to the contract. So if contract is month to month, then average monthly charges are 66. If contract is 1 year, then average monthly charges are 65. And if contract is 2 years, average monthly charges is 60. So bar plots help us to visualize the distribution of categorical values. Histograms help us to visualize the continuous values, and density plots are just a variation of histograms for smooth distribution by smoothing out the noise. So let's go to our studio and do some visualization. Right, so we have our studio right in front of us, and this is our same old customer churn dataset. And base plotting in R is actually quite simple. So we'll start off with the bar plot. So to do that, I will type plot over here, and let's say I would want to understand the distribution of this dependence column. So let me select that column. So I'll type customer churn, and using the dollar symbol, I will select the dependence column. Right. Let me plot it now. So we have our bar plot right in front of us. So let me zoom this. So this is our bar plot for the dependence column. So what we can infer from this is there are around close to 5,000 customers who don't have any dependence on them, and there are around 2,000 customers who have dependence on them. Now we can also change the color of this bar by using the COL attribute. So let me do that. COL, and let's say the color is coral. So this is what we get. So this color which you see over here is coral. Okay, so we can also add the X label, Y label, and also give a title to this plot. So let's go ahead and give the X label to this graph. So for that we have the XLab attribute. I'll hit equal to, and I'll give the X label as dependence. So we have got the X label over here. Similarly, let's also add a title. And to add a title, I'll be using the main attribute. And let's say the title is distribution of dependence. So let me type it out. Distribution of dependence. So we also have a title over here. So this is our final plot. So this color which you see over here is coral. This is our X label, and this is our title. Okay, so this was our first bar plot. Now we'll go ahead and understand the distribution of phone service column. Again, it'll be the same process. I'll type plot, and I will select that column by using the customer churn dataset $phone service. Right, so this is our bar plot over here. And what we see is there are close to around, let's say, 700 or 800 customers who don't have a phone service. And most of the customers, and there are around 7,000 customers who have a phone service. Right. Again, let me add a color to this. I'll use the COL attribute, and the color which I'll give is aquamarine 4. Right. So this color which you see over here is aquamarine 4, guys. Okay. So now I'll also add a X label. So X label will be phone service for this. Right, and I will also add a title. Title will be distribution of phone service. Let me hit enter, and we've got the color, we've got the title, and we've also got the X-axis label. Right. So now going ahead, we'll understand the distribution of internet service column. So this is our internet service column. So let me make a bar plot for this as well. Again, it's the same procedure. Plot of customer churn $, and I'll select the column which will be internet service. Let me plot it out. And this is our internet service bar plot, guys. Right? So we see that most of the customers use fiber optic followed by DSL, and there are very few customers who don't have any sort of internet service. Right, again, let's go ahead and give some color to this. And the color which I'll be giving to this is, let's say, simple orange. I'll type orange. Right. So this is our plot after giving the color orange to this. Again, I'll add the X label and the title for this. So xlab equals internet service, and the title is distribution of internet service. So main equals distribution of internet service. I'll hit enter. Right, so we have got the x-axis label and the title and also the color. Okay. So now we'll go ahead and find the distribution of some other column. So let's say we would want to see the distribution of this contract column. I'll type plot. I'll use the name of the dataset, which is customer churn, and select the contract column. So this is what we get over here. So what we see is most of the customers have a month-to-month contract followed by a 2-year contract and 1-year contract. That is, most customers have month-to-month contract, and there are very few customers, or the minority is of those customers who have a 1-year contract. Okay, again, interesting inference. So let's give a color to this as well, and the color which I'll be giving to this is pale green 4. So COL equals pale green 4. So color is done. Now I'll also add the X label. So X label will be contract. After giving the contract, I'll also add a title. So title will be distribution of contract. I'll hit enter. So we have added color, we have added X label, and we have also given a title to this graph. Right, so this is how we can work with bar plots. Now we'll also go ahead and implement some histograms. So as I've told earlier, histograms help us to work with continuous values. So we have 3 continuous valued columns over here. One is tenure, then we have monthly charges, and then we also have total charges. Right, so I'll start off by understanding the tenure column. So for that, I'll type hist. I'll give the name of the dataset, use the dollar symbol, and select the tenure column. And I'll just hit enter. And we have got our histogram right over here. Right? Quite an interesting histogram. So we see that most of the customers churn out in the first 5 months itself. So these are 4 bars over here. So if we count properly, this will be 5, 10, 15, and 20. So most of the customers churn out in the first 5 months itself, and there are very few customers who are using the network for at least 70 to 75 months. So this is what we can infer from this graph over here. Again, I'll add a color to this. So it'll be the same thing. I will add COL equals, and the color will be olive drab. Interesting color, isn't it? And also this looks much more prettier. Okay, so we now also have an option of changing the number of bins over here. So for that, we have the breaks attribute. So let's say we would want to increase the number of bins. So I'll type breaks equals 30. Now the distribution is much better, right? So again, we have 5 bins over here. So this will be 2, 4, 6, 8, 10. So what we can see is there are around 800 or 850 customers who churn out in the first 2 months. And there are around 600 customers who are using the same network for around 72 months. Okay, so this was the distribution of the tenure column. So similarly, let's go ahead and understand the distribution of monthly charges. So for that, I'll type hist. I'll give the name of the dataset, which will be customer churn. I'll use dollar, and then I'll select the monthly charges column. Right, so this is what we get over here. So this is the distribution of monthly charges. So you see that for most of the customers, the monthly charges is around $25 or $30. So there are just around 200 customers whose monthly charges are around $110 to $120. Again, let me give a color to this. So I can give a color by using the COL attribute. So COL equals, I will give the color of pale violet red. Quite an interesting color this is. So this color which you see over here, this is nothing but pale violet red. Okay, so now this is done. Now after this, I'll again increase the bin size and I'll give the number of breaks to be 50. So again, this is a better distribution than the previous one, right? Okay, so this is how we can work with histograms. Now we'll also work with density plots. As I've told earlier, density plots are just a variation of histogram so that we get a smooth curve of the distribution. So to make a density plot, I need to type plot and then inside plot, I'll type density and inside density, I'll give the name of the column. So it'll be customer churn $tenure. So this is what we get over here. So this is the distribution of the tenure of the customer. So the inference that we can draw from this plot is there are two peaks over here. So one is somewhere around 10 months and one is somewhere around 70 months. So now again I can change the color of this by using the COL attribute. So I will give the color of blue to this. So this is what we get. Right. So now similarly, let me make a density plot for the monthly charges column. So all I need to do is change this and put monthly charges over here. And I'll give the color of red to this. So this is the distribution for monthly charges. Right. So there is one maxima and this maxima is around $20. Okay, so this is how we can work with bar plots, histograms and density plots. So these histograms basically help us to understand the distribution of continuous values. So let's go to RStudio and build some histograms. Right, so we have RStudio right in front of us and this is the same old customer churn dataset that we were working with. So I'll start off by loading the ggplot2 package. So I'll type library of ggplot2 and we have loaded the package. And as we have learned in our previous sessions, that ggplot2 is based on something known as grammar of graphics. And in grammar of graphics, we have different layers on top of each other. And the first layer is the data layer. So over here, I am mapping the customer churn dataset to the data layer. Now after this, we have the aesthetics layer. So over here, I am mapping the tenure column to the X aesthetic. So X equals tenure. And finally, we have the geometry layer. And since we're working with geom histogram, so let's go ahead and type geom histogram over here. Right. Now, let's analyze this distribution of tenure. So let me zoom this. Right. So we see that there are around 600 customers who stopped using the network in less than 1 month. And there are around 500 customers who use this network for more than 60 months. If you want a better distribution of this graph, we can change the number of bins. So I'll say the number of bins is 50. And this gives a better understanding of the tenure of the customers. So right, this peak which you see over here, so there are more than 800 customers who stop using the network in less than 1 or 2 months. And there are around 300 customers or more than 300 customers who use this network for more than 70 months. Right, quite an interesting analysis, isn't it? Now we can also make this plot more pretty by giving it colors. So we have fill attribute for it and we'll give this bar some color with the help of this fill attribute. Right, so let's say I would want to give the color of pale green 4 for this. Right, so I've just assigned the color of pale green 4. Right, looks pretty, doesn't it? Now I'll also add a boundary color by using COL attribute. So COL equals, let's say I'll just give normal green color. Right, so we also get the boundary colors over here. And this is a pretty distribution of the tenure of the customers. Right, so now we'll do something interesting. So now what I'll do is I'll map different columns onto the fill aesthetic. So over here, we have actually used fill as an attribute, but now we'll be using fill as an aesthetic. And I'll start off by giving partner to the fill aesthetic. So let's go ahead and do that. So I'll remove the fill and color from this, and over here X is obviously tenure, and I am assigning partner column on top of the fill aesthetic. Right. Now what I'll do is I'll also change the position over here. So I'll assign position equals identity. Right, so over here these bars are actually stacked on top of each other. So when I give position equals identity, then the bars will be overlapping each other, and that will help us in understanding this better. Right, so let me zoom this again. So what we see over here is, so all these blue colored bars, so these are the customers who have a partner, and all these pink colored bars, so these are for customers who do not have a partner. And what we can understand from this is, if the customer has a partner, then he's more likely to use the network for a longer period of time. And if the customer does not have a partner, then he'll probably churn out in around 20 months or so. Right? So this is a very big peak over here. So these are all of the customers who do not have a partner, and they stop using the network after a month or so. And these are around 450 customers who have a partner, and they are still using the network after more than 70 months. Right? Interesting observation again. Now, similarly, I will map the online security column onto the fill aesthetic. So let me do that. Online security. Right. So now we have three different colors over here. So what we understand from this is, so let's start with these green colored bars over here. Right. So this is for all of those customers who do not have internet service. And if they do not have internet service, they'll most likely stop using the network after 20 months or so. Now we'll analyze these two. So this is for all of those customers who have internet service but have not subscribed to online security, and this is for all of those customers who have internet service and have also subscribed to online security. So what we can understand from this is, if the customer subscribes to online security, then he'll most probably stick to the network for a longer time. And if he does not subscribe to online security, then he'll pretty much churn out in the initial months itself. Right, so this was online security with respect to tenure. Now again, we'll understand how does the contract of the customer vary with respect to tenure. Right. So I will type contract over here. So I'm mapping contract column onto the fill aesthetic. Let me zoom this. So we see that there are three different types of contracts: month to month, 1 year, and 2 year. So let's start with this. So if the customer has a month to month contract, then he'll pretty much stop using the network in the initial months itself. So if the customer is on a 2-year contract, then obviously he is bound to use the network for a longer period of time. So we can do all of these different types of analysis with GEOM histogram. Now finally, I'll also map the churn column on top of the fill aesthetic. So let me understand this as well, right? So this is all of those customers who are churning out, and these are all of the customers who are not churning out. Again, a similar observation. So what we see is, if the customer decides to churn out, then he'll churn out in the initial months itself. Or in other words, he'll stop using the network in the first 3 or 4 months itself. And if the customer uses the network for, let's say, more than 60 months or more than 50 months, then pretty much he'll be using the same network for a very, very long period of time. Right? Okay, so this was the distribution of the tenure column with respect to other columns as well. Now I'll go ahead and try to understand the distribution of monthly charges. So I'll type ggplot of, again, data as customer churn, right, aesthetics, and I will be mapping the monthly charges on to the x-axis, right. Again, it is GEOM histogram. Right, so we see that for most of the customers, the monthly charges is around $25, and there are very few customers. So there are around 300 customers whose monthly charges is $100, right? and this is very less over here. So let's say this is around $110 or something. So very few customers whose monthly charges is around $110. Right. Now again, let me increase the number of bins to have a better understanding of this distribution. So I'll see bins equals 50. Right. So there are around at least 900 customers and their monthly charges is around $20 or so. And over here, if we see this, we can see that there are around probably 20 or 25 customers whose monthly charge is around $110. Right. Now again, we'll be making this plot more pretty by giving the fill and call attributes. Now I will assign Coral to the fill of this. So let me see how this looks. And I will make the boundary color to be consilk. So call equals consilk. Right. Again, a very pretty plot, isn't it? Okay. Now, again, since over here I have used fill as an attribute, now I'll go ahead and use fill as an aesthetic. So let me remove all of this from over here. Right, and I will start off by mapping the phone service column onto the fill aesthetic. So let me try to understand if the customer has subscribed to phone service, how will his monthly charges vary. Right. So again, over here, what I'll do is I'll put up the position to be identity. Position equals identity. Right. Let me zoom this now. So blue is for all of those customers who have subscribed to phone service, and pink is for all of those customers who don't have a phone service. Now, so for all of those customers who don't have a phone service, their monthly charges is somewhere around, let's say, $20 to at max $75, right? And most of the customers who have subscribed to phone service, only they will get a monthly charge of greater than $100. So again, let me reiterate this. So if a customer has not subscribed to phone service, then there is absolutely no chance that his monthly bill is greater than around $75. So quite an interesting analysis again, right? Okay. So now let me map internet service column onto the fill aesthetic. Right. So let me analyze this now. So you see that there are three options over here. So there are customers who have subscribed to DSL, there are customers who have subscribed to fiber optic, and there are customers who don't have any sort of internet service at all. And this is for all of those customers who do not have an internet service. So if you are one of those customers, then your monthly charges mostly will be somewhere around, let's say $18 to $25. And if you have subscribed to DSL, then your monthly charges would be around $25 to $75. And if your internet service is fiber optic, then you'll have the maximum monthly charges, and they'll be somewhere around $70 to $110. Okay, right. So now what I'll do is I'll map the streaming TV column onto the fill aesthetic. Streaming TV, right? Okay. Over here we have three options again. Those customers who have not opted for streaming TV, those customers who don't have internet service only, and those customers who have opted for streaming TV. So if the customers have opted for streaming TV, then they'll have the maximum monthly charges. And if they don't have internet service itself, then their monthly charges would be somewhere around $18 to $25. And if you have internet service but you have not subscribed to streaming TV, then you'll have around median charges of $75 or something. Okay. So now we'll map the total charges onto the X aesthetic and try to understand how does the total charges of the customer vary. So I will type total charges over here. I will remove all of these extra parameters. Remove position attribute from over here. Right, so again, quite an interesting plot, isn't it? So you see that most of the customers, around 900 of them, they have very less total charges, right? and there are very few customers whose total charge is greater than $7,500. So again, what I'll do is I'll increase the number of bins to have a better distribution. So I'll give the number of bins 50 over here. Right. So over here we see that, let's say there would be around 10 or 15 customers whose total charges would be close to $8,000, and there are around 700 customers whose total charges is around, let's say, not even $20 or so. Again, I'll make this plot more pretty by giving the fill and call attribute. Now let's say I would want to give the fill of fire brick 4. This needs to be capital over here, right? So this fill is fire brick 4 and call is let's say gold. Okay, so this is our plot over here, and the fill is fabric 4 and the call is gold. Now again, I will map another column to the fill aesthetic. So I'll remove these parameters and I'll use fill as an aesthetic instead of an attribute. And now I'll be mapping the device protection column onto the fill aesthetic. So I'll type device protection. Right, so again we have three options over here. So green is for all of those customers who don't even have internet service, pink is for all of those customers who have internet service but have not subscribed for device protection, and blue is for all of those customers who have internet service and have also subscribed for device protection. And we see that if they have subscribed for device protection, then most likely they'll have the highest total charges, and if they don't even have internet service, then most likely they'll have the lowest total charges, right? And according to this, there is a greater percentage of customers who have internet service but have not subscribed to device. Right, so we have our studio right in front of us, and this is our customer churn dataset. And I will start off by loading the ggplot2 package. So I'll type library of ggplot2, and we have loaded the package. Now again, I'll type ggplot and I'll start off by loading the data layer. And since our data set is nothing but customer churn, I'll give customer churn over here. Then comes the aesthetic layer, where I'll be mapping a column to some sort of aesthetic. So in this case, I'll be mapping the senior citizen column to the X aesthetic. Or in other words, I'd want to understand the distribution of the senior citizen column. Okay, so I have mapped the senior citizen column to the X aesthetic. And then finally comes our geometry layer. And since you're working with geom bar, I'll just type geom bar over here. Okay, so this is our visualization. Now we basically find out that most of the customers are not senior citizens. So there are basically around close to 6,000 customers who are not senior citizens, and there are just about 1,000 customers who are senior citizens. Quite an interesting visualization, isn't it? So now I'll go ahead and use the fill attribute to just make it more prettier. So I'll type fill equals, and I'll give the color of aquamarine 3 to this. Aquamarine 3. So this does look more pretty, doesn't it? Okay. So now I'll also add a boundary color to this, and for that I'll use COL, and the boundary color is, let's just say, black. So we have basically given the fill color and the boundary color by using fill and call attributes. Now, instead of using fill as an attribute, we can also use it as an aesthetic. Or in other words, we can map a column to the fill aesthetic. So let's go ahead and do that. So now if I want different colors for these two different bars. So I want one color for this and one color for this. All I need to do is map the senior citizen column to the fill aesthetic. So I'll delete all of this over here, and I'll go to the aesthetic layer, put a comma over here. I'll use the fill as an aesthetic, and I will map senior citizen to it. Okay, so let's see the result now. So what has basically happened is we have two different colors for both of these bars. So if it is pink, then it basically means that the customer is not a senior citizen, and if it is blue, then it means that the customer is a senior citizen. And this we got because we were able to map senior citizen to the fill aesthetic. Okay, now let's go ahead and understand how does the distribution of senior citizen vary with some other columns. Let's say internet service. So all I need to do is remove this and I'll map internet service to the fill aesthetic over here. Let us have a glance at the result. Right, so we see 3 colors for this bar and 3 colors for this bar. Now what this basically means is if the color is pink, then the customer has subscribed to DSL internet service. If it is green, then it is fiber optic. If it is blue, then the customer has not subscribed to any sort of internet service. It is the same for this as well. Now what we can info from this bar is majority of the customers have subscribed to fiber optic. And the case is similar to over here. Again, most of the customers have subscribed to fiber optic, and there are very few senior citizen customers who have not actually subscribed to internet service. So the second inference would be if the customer is a senior citizen, then there is a very good probability that he might have subscribed to.
Let's have a quick quiz question, guys. And the question is, which of the following operations can be considered a data manipulation task? Option A, data collection. Option B, data visualization. Option C, data cleaning and filtering. And option D, data model training. Please do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Fiber optic internet service. Now what we'll do is we'll change the position of bars, and for that I will give the position attribute and I will give the value as dodge over here. Now let us see the result. Let me zoom this. Now this is quite an interesting observation. So what we can infer from this is if the customer is not a senior citizen, then he is most likely to subscribe either fiber optic or DSL. Similar is the case to this. Again, if the customer is a senior citizen, he is most likely to subscribe to fiber optic and DSL again. Okay, now we'll go ahead and map payment method to the fill attribute. Let's see what we get. So now we have 4 different colors over here. So if it is pink, then it would mean then the customer's payment method is bank transfer. If it is greenish yellow, then the customer's payment method is credit card. If it is blue, then the customer's payment method is electronic check. If it is purple, then the customer's payment method is mail check. So it's pretty much the same in both the cases. So what we see over here is whether the customer is a senior citizen or not, most likely his payment method will be electronic check. So this is the first highest over here if the customer is not a senior citizen, and the second highest is mailed check. But in case if the customer is a senior citizen, then he'll most likely be subscribed to electronic check, followed by bank transfer, followed by credit card, and in the last is mail check. Okay, so this was the distribution of senior citizen column. Now let's go ahead and change this, and this time I'd want to understand the distribution of gender column. So again, I'll do the same thing. It'll be ggplot, and I will map customer churn to this, and the aesthetic layer would be gender. That is, I am mapping gender to the X aesthetic, following which I will give a geometry which is geom bar. Right. Now in this we basically find out that there is equal distribution between the female and male customers. So both of these, they are close to the 3500 mark. So there are around 3,500 male and female customers. Okay, so now I'll go ahead and make this more pretty by adding a fill to it. Let's just say I give the color of cadet blue to it. So this color which you see over here is cadet blue. Next, I'll also give the boundary color, and the boundary color would be coral. Right, so this is our resultant graph over here. This is cadet blue, and this boundary color which you see over here, this is nothing but coral. Okay, so now we'll be using the fill as an aesthetic and not as an attribute. So let me delete all of this. Let me put a comma inside the aesthetic layer. I'll type fill, and I'll be mapping the online security column to the fill aesthetic. Online security, let us see the result now. So we have three different colors over here. So pink is for those customers who have not subscribed to online security. Green is for those customers who don't even have internet service, and blue is for those customers who have subscribed to online security. So we see that for both the cases, that is, if the customer is male or female, then it is more likely that they do have internet service, but they have not subscribed to online security. Then this constitutes the minority of the customers. That is, there are very, very few customers who don't even have internet service. Okay. So now I will map streaming movies to fill aesthetic. Let me do that. So now in this case again we have three colors, pink, green and blue, and if it is pink then the customer has not subscribed to streaming movies. If it is green then the customer doesn't even have internet service, and again if it is blue then the customer has subscribed to streaming movies. Now this seems a bit difficult to draw some sort of inference. So again what I'll do is I will use the position, I will change the position to be dodge. So position equals dodge over here. Now let's understand this better. So what we can infer from this is now, so if the customer is female, then there is equal number of those who have subscribed to streaming movies and equal number of those who have not subscribed to streaming movies. And if the customer is male, then there is just a slight majority of customers who have not subscribed to streaming movies. Again, in both the cases, there are very, very few customers who don't even have internet service. Okay, so this was the distribution of the gender column. Now we'll go ahead and understand the distribution of dependence column. So let me do that again. ggplot. Data is nothing but customer churn, aesthetic layer over here, and I will map dependence to the X aesthetic. After I do that, all I need to do is add the geometry layer, which will be geom bar. So this is our distribution of the dependence column. So we see that most of the customers do not have any dependence. So it is close to around 5,000 customers. So close to around 5,000 customers do not even have any dependence. And this is around 2,000. So around 2,000 customers have dependence on them. Okay. Now again, I will go ahead and add some color to this using fill. So I'll give the color chocolate because I love chocolates. Right, so this is what the graph looks like after I give it the color chocolate. Okay, so now again I'll use fill as an aesthetic rather than as an attribute. I will delete all of this over here. I'll type fill, and let's say I'd want to map the column device protection to the fill aesthetic. Device protection. Okay. So again, I have three colors over here. Pink is for all of those customers who have not subscribed to device protection. Green is for all of those customers who don't even have internet service. And blue is for all of those customers who have subscribed to device protection. Again, let me change the position to be dodge. position equals dodge. Okay. So in this case, that is, if the customer does not have any dependence, then it seems as if the customer would not have any sort of device protection. And in the second case, that is, if the customer has dependence on him, and there is more probability that he would have subscribed to device protection. Interesting analysis again, right? So the scatter plots basically help us to understand how does one variable change with respect to another variable. So let's go to our studio and build some scatter plots. Right, so we have our studio right in front of us, and this is our same old customer churn dataset. So I'll start off by loading the ggplot2 package. So I'll type library of ggplot2. Okay, and then I'll type ggplot. Now it's time to load the data layer, which is nothing but our customer churn dataset. Okay, so we have loaded the data layer. Now it's time to come to the aesthetic layer. And since we are trying to build a scatter plot, we would need at least two aesthetics, which are X and Y. So I would need one column to map to the X aesthetic and another column to map to the Y aesthetic. Now for this case, I want to understand the distribution of total charges with respect to tenure. So I'll map total charges to the Y aesthetic and tenure to the X aesthetic. So Y equals total charges and X equals tenure. Right. And finally, it's time to add the geometry layer, which is nothing but geom point. Okay. So this is our resultant scatter plot, guys. Now what we can infer from this is, as the tenure increases, the total charges of the customer also increases. So greater the tenure, greater the total charges, lesser the tenure, lesser the total charges. Okay. Now we can also change the color of this plot. So all we need to do is use the COL attribute. And let's say I would want to give this the color of slate blue 3. So this is what slate blue 3 looks like, guys. Okay, so now instead of using COL as an attribute, we'll use it as an aesthetic. Okay, so now I will delete all of this over here inside geom point, and I'll type COL over here, and I feel like mapping the partner column to the COL attribute. So let's see what do we get. Okay. So now we see there are two colored points over here. One is pink and one is blue. So if the color is pink, then it means that the customer does not have a partner. And if the color is blue, then it means that the customer has a partner. So again, what we see from this is, most of the blue dots are at the right end of the screen, which basically means that if the customer has a partner, then it is more likely that his total charges are higher. And if the customer does not have a partner, then it is likely that his total charges are lower. Interesting inference it is. Okay, so now this time we'll map internet service to the COL aesthetic. Right, now let's see what we get as a result. So we have three different colors over here. Green, which indicates all of those customers who have subscribed to internet service of fiber optic. Pink is for all of those customers whose internet service is DSL, and blue is for all of those customers who don't even have internet service. Right. So again, it's simple interference over here. So green, we see that all of the customers who have fiber optic as internet service, they are paying the maximum total charges. And when it comes to DSL, it is somewhere in between. And if the customer doesn't even have internet service, then his total charges are very, very low. So they are not even crossing $2,500. Right. Now we'll go ahead and map online security to the COL aesthetic. Let's do that. Online security. So again, we have three different colors over here. So green, pink and blue. Green is for all of those customers who don't even have internet service. Pink is for all of those customers who have internet service but have not subscribed to online security. Blue is for all of those customers who have internet and also have subscribed to online security. Right. So again, those customers who have online security are more likely to have higher total charges. Okay. So now this was the distribution of total charges with respect to tenure. Now we'll understand how is total charges changing with respect to monthly charges. Let me delete all of this. So ggplot data, and I'll map customer churn to the data layer, aesthetic. So I want to understand total charges versus monthly charges. So y would be equal to total charges and x would be equal to monthly charges. Okay. Then it's time for geometry layer, which is nothing but geom point. So this is what we get. Again, it's the same sort of inference. So what we understand is as the monthly charges increase, the total charges of the customer also increase. Okay. So now this time around I will give this a different color again. So the color that I give to this is, let's say, orange. Okay. Now we'll also understand how to get different shapes for these points. So all we need to do is type the shape attribute and give a number. So when I give the number 1, I get hollow circles. So let me zoom this to get a better view. Okay, so these are hollow circles. Now when I change the shape to be 2, let's see what do we get. So we get hollow triangles. Similarly, let me give a different shape. So now let's say shape equals 3. Now what we get is plus symbol. Again, shape equals 4. Let me press enter. And this time we get cross marks. Right, so this is how we can change the shape of these points. Okay, so now again I will delete all of this and map some columns to the aesthetic layer. So I'll start off by mapping internet service to the color aesthetic. Let's have a look at the result. So we have 3 colors, green, pink and blue, and if it is green then the internet service is fiber optic. If it is pink, internet service is DSL. If it is blue, then the customer doesn't have internet service. So again, if it is green, then the customer has maximum monthly and total charges. If it is pink, then it's in between, and if it is blue, then the customer will have the minimum monthly and total charges. Okay. So now again what I'll do is I will map internet service to the shape aesthetic as well, and let's see what we get. So shape equals internet service. Let's see what is the result now. Now what we see is we have 3 different colors and also 3 different shapes. So for blue it is a square, for pink it is a circle, and for green it is a triangle. Right, so this basically denotes internet service of fiber optic, which is green and triangle. So this is DSL, which is circular and pink, and this is basically for all of those customers who don't have internet service. So this is a square and a blue colored. Right, again we can also assign a column to the size aesthetic. Now what I'll do is put size over here and map internet service to size as well. Let's have a glance at the result. Okay, so what we see is this blue color has the maximum size, green is in between, and pink has the lowest size. And again these are the 3 different shapes. Pink is circular, green is triangle, and blue is a square. Okay, so this is how we can use different shapes and sizes for different aesthetics. Now we can also add a smooth line to understand the trend. So now let me clear this out a bit so that we have a better distribution. I'll delete the shape, I'll delete the size. Okay, let's go back to the normal one. Now I will add a new geometry which is geom smooth, and let's see what do we get. So we get three trend lines over here which you see. So we have one over here, another over here, and another over here. So this basically shows us what is the trend or how is it changing with respect to these two variables. So total charges, monthly charges. So this is how it is changing for DSL, and this is how it is changing for fiber optic. So box plot is used for comparing distributions across groups. So it's actually a visual representation of a 5-number summary. That is, a box plot itself is enough to find out the maximum value, minimum value, and all the three quartiles. So let's go to RStudio and build some box. Right, so we have RStudio right in front of us, and this is our same old customer churn dataset. And I'll start off by loading the ggplot2 package. So I'll type library of ggplot2, and we have loaded the package. Then I'll use the ggplot function, and I'll map our customer churn dataset onto the data layer. This is done. Next comes the aesthetic layer. And for our first example, I'll be using the X and Y aesthetic. And let's say I'd want to understand the distribution between monthly charges and senior citizen column. So I'll map monthly charges onto the Y aesthetic and senior citizen onto the X aesthetic, right? So I'm mapping monthly charges onto the Y aesthetic. Then comes the X aesthetic, for which I'll map the senior citizen column. And we are done with the aesthetic layer as well. Then comes the geometry layer, and since we're working with box plots, this will be nothing but the geom box plot function. Right. So let us see the result now. So this is what we get. So we get two box plots over here. So this is for all of those customers who are not senior citizens, and this is for all of those customers who are senior citizens. Now let's understand a box plot properly. So these three which you see over here, these three endpoints, so this is the 25 percentile mark. This is the median or the 50 percentile mark. This is the 75 percentile mark. And this is the maximum value. And this over here is the minimum value. And these dots which you see over here are nothing but the outliers. So now let's actually draw some inferences from these two box plots. So what we see over here is, if the customer is not a senior citizen, then his median charges would be somewhere around $62. His 25 percentile mark is somewhere around $25, and his 75 percentile mark is close to around $80. Now, when I say 25 percentile mark, it basically means that the rest of the 75% customers earn more than $25. And when I say 50 percentile mark, I basically mean that the rest of the 50% customers earn more than this $62 mark. And this is the 75 percentile mark, which means the rest of the 25 percentile customers earn more than $80. Right? And this over here is the maximum value, which would be around $110. And this is the minimum value, which would be around $18. So similarly, this is for the customers who are senior citizens. So if the customer is a senior citizen, then he'll most likely have higher monthly charges. So when I compare this box plot with this box plot, I can easily draw an inference that senior citizens have higher monthly charges than non-senior citizens, right? Okay. Now we can also add some color to this box plot. So I can use the fill attribute for this. So I'll type fill equals, and I'll give the color of pale green 4. Now this looks much more pretty, doesn't it? So this color which you see over here, this is nothing but pale green 4. Okay. So now we can also change the shape and color of these outliers as well. So now all I need to do is use the outlier dot color attribute. So let me type that outlier dot color, and I'd want to give the outlier color of orange. So let's see the result. See, initially this was black. I've changed the color of the black colored outliers to orange color. Similarly, I can also change the shape of these outliers. All I need to do is use the shape attribute. It'll be outlier dot shape. Right. And now let's say if I give the value of 2, let's see what happens. So this is what we get. Again, let me change the shape and give the value of 3 to this. So we get mini box plots over here. So this way we can also change the shape of the outliers. Okay. So next we'll try to understand how this monthly charges change with respect to dependence. Again, I'll do the same thing. ggplot. I'll map the customer churn dataset onto the data layer. Then comes the aesthetic layer, and I'll map monthly charges onto the Y aesthetic. Then I'll map the dependence column onto the X aesthetic. Right, so aesthetic layer is done. So it'll be geom box plot again. And now let's see what do we get. So let's compare these two box plots now. So this is for all of those customers who don't have dependence, and this is for all of those customers who have dependence. Now, when we compare these two, the inference that we can draw is if the customer does not have dependence, then he'll most likely have higher monthly charges. So you see these median values of these two box plots. So this is around $75 and this is around $62. So the median charges of a customer who does not have dependence are likely to be higher. Okay. So now again, let's give this some sort of color. And the color that I want to give is, let's say yellow green. So fill equals yellow green. Again, this looks much more pretty. Okay. So now this time around, I'll map the internet service column onto the X aesthetic. That is, I'd want to understand how does monthly charges vary with respect to the internet service that the customer has opted for. Let me remove this. I'll map internet service onto the X aesthetic. Right, so we get 3 box plots now. So now this box plot is for all of those customers whose internet service is DSL, and this box plot is for all of those customers whose internet service is fiber optic, and this is for all of those customers who don't have an internet service itself. So now what we can easily figure out is if the customer has opted for fiber optic, then he'll most likely have the highest monthly charges, and if the customer does not have internet service, then he'll have the lowest monthly charges. So a customer opting for fiber optic, his monthly charges would be greater than $80. For a customer whose internet service is DSL, his monthly charges would be somewhere around $48 to, let's say, $68. And if the customer doesn't have internet service, his monthly charges would be close to $18 or $20. Right? Again, let me go ahead and give some color to this. So the color that I give to this is, let's say, violet red 4. So this color which you see over here, this is violet red 4. Again, this is much more pretty than the basic plot. Okay. So next, going ahead, I'd like to understand how does monthly charges change with respect to the payment method. Okay. So I'll remove this fill attribute from here. I'll also remove this internet service column and I'll map the payment method over here. So I'm trying to understand how does monthly charges vary with respect to the payment method column. Okay. So now I get 4 box plots. So this box plot is for all of those customers whose payment method is bank transfer. This is for customers whose payment method is credit card. This is for customers whose payment method is electronic check. And this is for customers whose payment method is mail check. Now, out of this, if the customer's payment method is electronic check, then he'll most likely have the highest monthly charges. And if his payment method is mail check, then he'll most likely have the lowest monthly charges, right? Okay. So next again, let me give this box plots a color. So I'll give the color of tomato 3. So this color which you see, this is tomato 3. Okay. So now finally, I'll go ahead and map some columns to the aesthetic layer. So now instead of using fill as an attribute, I'll be using fill as an aesthetic. Okay. I'll remove this. So now I let these two be the same. The y aesthetic and x aesthetic will be the same. So on y-axis, it'll be monthly charges. On x-axis, it'll be the payment method. So now going ahead, I'll use the fill aesthetic and I'll map the paperless billing column onto the fill aesthetic. So let me see what do we get. So this is the result. So these two plots are for customers whose payment method is bank transfer. These two are for customers whose payment method is credit card. These two are for electronic check and these two are for mail check. Now going ahead, let's look at the color of these box plots. So if the color is pink, then this would mean that the customer has not opted for paperless billing. And if the color is blue, then this would mean that the customer has opted for paperless billing. Now, when we have a closer look at all four of these different payment methods, it is quite obvious that with respect to all four payment methods, if the customer has opted for paperless billing, that is, if the color is blue, then the monthly charges are likely to be higher with respect to the payment method. Okay. So if we take these two plots over here, so this is for customers who have opted for paperless billing. This is for customers who have not opted for paperless billing. So now if the customer has opted for paperless billing, his monthly charges would be around $80. And if he has not opted for paperless billing, his monthly charges would be around $60. Similarly, so let's take this case. So this is the highest monthly charges over here. Again, with respect to both of these plots, if he has opted for paperless billing, then his monthly charges would be somewhere around 80. And if he has not opted for paperless billing, then his monthly charges would be somewhere around $75. Right. So this is the inference which we got when we mapped the paperless billing column onto the fill aesthetic. So now let's map the churn column onto the fill aesthetic. Let's see what do we get. So again, the x and y axis are the same. All I've done is I've mapped the churn column onto the fill aesthetic. So over here, pink is for those customers who will not churn out. Blue is for those customers who will churn out. And again, if we have a look at all of these box plots, we can easily make an inference that if the customer will churn out, then his monthly charges are likely to be higher. So over here, we see that the customer is churning out and his monthly charges are higher over here. So same as this case over here when the payment method is mail check. So if the customer is churning out, then his monthly charges are greater than $50. And if he's not churning out, then his median monthly charges are close to around $25. Okay. Right. Next, going ahead, I'll also map the tech support column onto the fill aesthetic. Let's see what do we get. Right. So this time I've mapped the tech support column onto the fill aesthetic. So we get three box plots for each of the different payment methods. And green is for all of those customers who don't have internet service. Pink is for all of those customers who have internet service but have not opted for tech support. And blue is for all of those customers who have internet service and have also opted for tech support. So again, we can easily make out that if the customer has no internet service, then his monthly charges are likely to be the lowest with respect to all of the payment methods. And if the customer has opted for tech support, then he'll most likely have the highest monthly charges. So for all four of these cases, we see that the median monthly charges are higher when the customer has opted for tech support. Okay. So now going ahead, I'll map the internet service column onto the fill aesthetic. Right? So y-axis monthly charges, x-axis is payment method, and internet service has been mapped to the fill aesthetic. Again, we have three different colors over here. Green is for all of those customers whose internet service is fiber optic. Pink is for all of those customers whose internet service is DSL. And blue is for all of those customers who don't even have internet service. Again, a similar inference from over here. So if the customer doesn't have internet service, then he'll most likely have the lowest monthly charges, and they vary from $18 to let's say $25. And if the customer's internet service is fiber optic, then his monthly charges would be somewhere around $75 to around more than $100. Now, many times what happens is we'll be working with huge data sets. And when we're working with huge data sets, there'd be a lot of categorical variables and a lot of numerical variables. And plotting all of them onto a single graph might lead to chaos. That is why we need to facet our data. Or in simple terms, we need to divide the data into groups. And when we do this, this gives us better visualization. So let's go to RStudio and learn how to work with the facet grid. Right, so we have RStudio right in front of us, and this is our same old customer churn dataset. So I'll start off by loading the ggplot2 package. I'll type library of ggplot2. Now what I'll do is I'll make a very simple example where I'll be building a histogram, and I'll show you guys what is the problem with it. And then we'll go ahead and understand how to make a facet grid. Okay, so ggplot, I'll map the customer churn dataset onto the data layer. Then comes the aesthetic layer, and I'd want to understand the distribution of tenure column. So X equals tenure, and I'll also map the internet service column onto the fill aesthetic. This is also done. And finally, we have the geometry, which is geom histogram. Now let's have a look at the result. So guys, this is what we get. Now what we see is this plot is a bit chaotic, and finding out inferences from this plot is not that easy. So that is why we need to facet our data. So let's learn how to do that. Now what I'll do is I'll store this in a new object and name it as G1. Now on G1, I'll add the facet grid layer. Inside the facet grid function, I'll put a tilde symbol. Following the tilde symbol, I'll give the name of the column by which I need to facet the data. So I want to facet the data with respect to the internet service column. So that is what I'll do. Tilde, internet service. Now let's see what do we get. So we see that our plot has been faceted with respect to the internet service column. So we have 3 facets in total. One facet is for all of those customers who use DSL. One facet is for those customers who use fiber optic. And this is the facet for those customers who don't even have internet service. Now, when we have a closer look at all 3 of these graphs, the inference is quite simple. Now, when we look at this graph, we can easily say that there are around more than 250 customers whose tenure is greater than 72 months if they use fiber optic. Again, when we look at this facet, then we can easily conclude that if the customer does not have internet service, then there are around 100 customers whose tenure is more than 70 months, right? So faceting basically helps us to reduce the chaos and understand the graphs easily. So this was the previous plot, which was chaotic, and this is much more prettier because we have faceted our graph, right? So now in the second example, I'll build a geom bar, and then we'll understand why is it chaotic, and then we'll go ahead and build a facet grid. Okay, so ggplot, and I'll map the customer churn dataset onto it. Next comes the aesthetic, and I'd want to understand the distribution of the payment method column. So I'll map payment method onto the x-axis. Then I'll also map the contract column onto the fill aesthetic. Right. And finally, we have the geometry, which is nothing but geom bar. Okay, so this is what we get. Again, we have 4 bars over here, and we have 3 different colors. Again, finding out inferences from this graph is not that easy. So that is why I'll store this in a new object and name it as G2. And on top of G2, I'll build the facet grid, and I want to facet it with respect to the contract column. So this is our new graph. This was our previous graph. So let me zoom this and analyze this properly. So this facet is for all of those customers whose contract is month to month. This facet is for those customers whose contract is of 1 year. This facet is for those customers whose contract is of 2 years. So now if we have a look at this, we see that if the contract of the customer is month to month, then most of the customers pay using electronic check. Again, if the customer's contract is 1 year, then we see that the majority is of credit card. And when we have a look at this, then we see that the majority is of credit card again. right? So inference is basically easier for us because we have visited the data with respect to the contract column. Now similarly, I'll create a scatter plot and also draw some smooth lines, following which we'll also create the facet grid. ggplot. I'll map the customer churn dataset on top of this. So I'd want to understand the variation between the total charges and the tenure column. So I'll map the total charges onto the Y aesthetic, and onto the X aesthetic, I'll map the tenure column. Now I'll also map the contract column onto the color aesthetic. Now finally, it's time to build the geometry, which is nothing but geom point. After geom point, I also need the smooth lines. So I will give geom smooth as well. So this is a very complicated graph and we cannot make any sort of sense out of it. So this is where we need to facet our data. So let's go ahead and do that. I'll store this in G3. Now on top of G3, I'll add the facet grid. I'll put the tilde symbol and I want to facet the data with respect to the contract column. So now we have three facets over here. First facet is for customers whose contract is month to month. Second facet is for customers whose contract is of 1 year. And third facet is for customers whose contract is of 2 years. All right. So now if we look at this, so we see that the relation is mostly linear. That is, as the tenure increases, the total charges of the customer over here also increases, right? And again, the maximum total charges in this case is somewhere around $7,500. Now, if we look at this facet, we see that there are more customers in the bracket of $7,500 to $8,000. Again, if you look at this, again, this is more dense in these two plots. Again, there are more customers in the 2-year facet whose total charges are between $7,500 to $8,000. Right? So again, we were able to draw this inference because we had faceted our data. Now similarly, what I'll do is I'll draw a box plot, following which I'll also divide it with respect to facets so that we can reduce the chaos. ggplot. Data layer is nothing but the customer churn data set. And I'd want to understand the distribution of monthly charges with respect to the payment method. So I'll map monthly charges onto the y-axis and I'll map the payment method onto the x-axis. Following which I'll also map the internet service column onto the fill aesthetic. Finally, it's time to add the geometry, which is nothing but geom box plot. So again, this is what we get. So you see that this plot is not that pretty and drawing inference is also not that easy. So all I need to do is store this in a new object. I'll name the new object as G4. And on top of G4, I will add the facet grid. And I will divide it on the basis of the internet service column. So again, we have three facets over here. First facet is for all of those customers whose internet service is DSL. Second facet is for all of those customers whose internet service is fiber optic. And third is for all of those customers who don't even have internet service. Again, drawing inferences from this graph is very easy. So if we see that the customer's internet service is fiber optic, then their monthly charges are the highest. And if the customers don't have internet service, then their monthly charges are the lowest. And if the customer has subscribed to DSL, then his monthly charges are somewhere in between. Right, so this is what we get. So this is our initial plot, guys. So now what I'll do is I'll go ahead and add a title to this plot. Okay, so now I will store this in a new object and I'll name this as G1. And on top of G1, I'll add the labs layer or the labels layer. Now inside this, I'll use the title attribute and I'll assign a title to this. So the title will be distribution of tenure, right? So we have assigned a title to this plot. Now again, I'll store this in a new object and I'll name the object as G2. Now on top of G2, I will add the theme layer. And inside the theme layer, I'll use the panel.background attribute to give a color to this panel over here, right? So now for that, I need to use the element rect function over here. So the element rect function helps us to modify rectangular spaces. Okay, inside this, I'll give the fill color to be olive drab 3. Let me do that. Olive drab 3. Let's see what is the result, right? So we have successfully assigned a background color to the panel. So this background color which you see, this is nothing but olive drab 3. Okay. So now I'll go ahead and store this in a new object and I'll name the object to be G4. And again on top of G4, I'll add another theme layer. And inside this theme layer, now I'll give a background to the plot. So this what you see is the panel and this entire thing what you see is the plot. Okay. So let me assign a background to the plot by using plot.background attribute. Again, I'll use the element rect function. Inside element rect, I'll assign the fill color, which will be pale green 4. Okay, let us have a look at the result now. Right, now I've also given a background color to the entire plot. So this is a background color to only the panel and this is a background color for the entire plot. Okay. So now finally, I'll store this in a new object which will be G5 and we'll be building the final theme layer on top of it. So G5 plus theme, and this time I'll modify the text of this title. So I'll start off by center aligning the title. Okay, so I'll use plot.title attribute and I'll use element text function because we are modifying the text of this title. And I'll use hjust and I will give the value of 0.5. Now let us see what happens. So when I gave the value of hjust to be 0.5, the text was aligned in the center, right? So this is how we can center align the title. Now similarly, I'll go ahead and make the title to be bold. So I'll use face attribute and I'll type in bold over here. So we have made the title to be bold as well. Now we can also go ahead and change the color of the title. Okay, so now all I need to do is use the color attribute and I'll give this a color of peach puff. Right? So now in the final theme layer, what I did is using hjust, I center aligned it. Using face attribute, I made this bold. And finally using the color attribute, I gave this a color of peach puff, right? So this is our final graph. So we started off by giving a title to this plot. Then we gave a color to the panel, following which we also gave a color to the entire plot. And finally we modified the title of this graph, right? So this was the first example. Now similarly what I'll do is I'll create some smooth lines and we'll add a theme layer to the smooth lines. So again ggplot, I'll assign the customer churn data set onto the data layer. Then it's time for the aesthetic layer and I'd want to understand the distribution of total charges with respect to tenure. So I will map total charges onto the Y aesthetic and the x-axis will be tenure. I'll also add another column to the call aesthetic which will be internet service. Right. Now it's time to get the geometry layer which will be geom smooth. Okay. So now let us have a glance at the result. So this is our initial result which is a bit bland. So let's go ahead and make this much more pretty. I'll store this in T1, and on top of T1 I will use the labs layer, and I'll give this plot a title, and I'll also modify the text for x-axis and the y-axis. Okay, so I'll use the title attribute, and I'll give this a title of total charges versus tenure. Total charges versus tenure. So we have the title over here. Similarly, let me modify the title for the x-axis. So see that the T over here is in small caps. So now let me change it to capital case. Right, so we have also changed the label for the x-axis. So similarly, let's also change the label for y-axis. So now over here there is no space in between total and charges. So let's give a space between those two words. Total charges. Right, so I have given a title to the plot, I have modified the x-axis label, and I have also modified the y-axis label, and I will store this in T2. Okay, and on top of T2 I'll be adding a new theme layer, and using this theme layer I'll give a background to the panel. Okay, so panel dot background equals element rect, and inside element rect I'll use the fill attribute, and I will give this a color of thistle. So this is what we get. So this color which you see, so this is thistle. Okay, so now I will store this in a new object, and I'll name it to be T3. Again, on top of T3 I'll build a new theme layer, and for this theme layer I'll be giving a background to the entire plot. So it'll be plot dot background equals element rect. Inside this I'll use the fill attribute, and I'll give this a color of tomato. Right, so this is what we get. So we have given a color to the panel using panel dot background, and we have also given a color to the plot using plot dot background. Okay, so now again I'll store this in a new object. I will name it to be T4. Right, and on top of T4 I will build a final theme layer. So now this time I'll again modify the title of this plot. So what I'll do is I'll use plot dot title attribute, and for this I'll be using the element text function, and inside this again let me center align the title. So h just equals 0.5. So we have center align the title. Now after doing this I'll make the title to be italic. So face equals italic. So we have changed this to italic now. Now I'll also give a color to the title using the color attribute, right? So the color which I give would be white smoke. So this is a final result, guys. So in the final theme layer, I have center aligned the title, then I have made it italic, then I've also given a color to the title. Right, so we have our studio right in front of us, and this is our same old customer churn dataset. Now I'll go ahead and load the Plotly package. So I'll type library of Plotly. Then going ahead, I'll give the Plotly function. So I'll type plot underscore ly. Now I'll give the first parameter, which would be data, and I'll map the customer churn dataset onto this. Right. So for the first example, I'll be building a histogram, and for histogram, we would just require the x-axis. So I'll type x equals. Now before I give in the column, we need to keep in mind that whenever we are mapping a column onto any aesthetic, we need to give the tilde symbol as a prefix. Okay. So over here, I'll give the tilde symbol, follow it up with the name of the column, which would be internet service. So I have mapped the internet service column onto the x-axis, right? Then comes the type of the geometry. The type would be the histogram, because we want to get a histogram. Okay, I'll hit enter and let's see what we get. So this is the result, guys. So we see that there are 3 bars, and we also see that the plot is quite interactive. Now when I put the mouse pointer on top of this, we see that we get DSL, 2421. So this is basically telling us that the category is of DSL and there are 2421 customers who have opted for the internet service type of DSL, right? Now this tells us there are 3096 customers whose internet service is fiber optic, and this tells us there are 1526 customers who don't even have internet service, right? Now we'll go ahead and also give a color to this plot. So I will use the color parameter over here, and again the color would be determined by the internet service column. I'll hit enter and let's see what do we get. So now we have three different colors. So green is for all of those customers whose internet service is DSL, orange is for all of those customers whose internet service is fiber optic, and purple is for all of those customers who don't even have internet service. We can also map a different column to the color aesthetic. So let's say I'd want to map the contract column onto the color aesthetic. So let me do that. I'll hit enter. Right, so now we see that there are 3 bars for each of these categories. So this time green is for all of those customers whose contract type is month to month, orange is for all of those customers whose contract type is of 1 year, and purple is for all of those customers whose contract type is of 2 years. Okay, so now let's take this case where the customer's internet service is DSL. So when the customer's internet service is DSL, the greatest count is of those customers whose contract is month to month. So there are 1223 customers whose contract is of month to month. Now let's take this category. So over here the internet service is fiber optic, and the greatest count is of those people whose contract is again of month to month. Now let's take the final category. So the final category is for those people who don't have internet service. So as a customer, if you don't even have internet service, then you'd most likely belong to the category where your contract type is of 2 years, right? And we were able to do all of this analysis with the help of this plotly. Right, so this was histogram. Now we'll go ahead and make a scatter plot. So again, I'll type plot underscore ly, and I'll give the data set, which would be customer churn over here. And next, the scatter plot would require the x-axis as well as the y-axis. So I'd want to understand the distribution of total charges with respect to tenure. So I'll map the total charges onto the y-axis. Let me do that. Going ahead, I'll map the tenure onto the x-axis. Right. So I map total charges onto the y-axis and I map the tenure onto the x-axis. So next what I'll do is I'll give the mode to be equal to markers, and let's see what do we get. So we get a scatter plot over here, right? Again, this is very interactive. So we see that as the tenure increases, the total charges also increase. So when I put my mouse pointer over here, so this tells me that there is a customer whose tenure is of 72 months and his total charges are around $8,684. So again, if I put my mouse pointer over here, so there is a customer whose tenure is of 45 months and his total charges incurred are 3,713. Now let me put my mouse pointer over here. Now I see that the tenure of the customer is 1 month and his total charges are $102. Okay, now I'll also give this a color. So the color would be determined by the internet service column. I'll give color over here and I'll map the internet service column onto this. So we see that there are 3 different colors over here. So green is for all of those customers whose internet service is fiber optic. So orange is for all of those customers whose internet service is fiber optic. Green is for all of those customers whose internet service is DSL. And purple is for all of those customers who don't even have internet, right? And we can clearly make out that those customers whose internet service is fiber optic, they'd have the highest total charges. and those customers who don't even have internet service, they'd have the lowest total charges, right? Now let's say if I want to remove one of these categories out of this plot, all I need to do is click over here, right? So when I've clicked on DSL, the DSL category has been removed. So now I can make a thorough analysis with respect to these two. Similarly, if I click on it, I'll get the category back. If I want to remove the fiber optic category, I just need to click on it and it will be removed, right? So now I just have these two categories, DSL and all of those customers who don't even have internet service. So let me get the fiber optic column back. Okay. So that customer whose tenure is 72 months and whose total charges are 8,670. So his internet service is of type fiber optic, right? And if I put my mouse pointer over here, so the customer whose tenure is 53 months and his total charges are 2,854. So now the internet service which he'll be using is DSL. Again, similarly, if I put my mouse pointer over here, so the customer whose tenure is 72 months and his total charges are 1,304, then this customer wouldn't even have internet service. So this was a scatter plot. Now I'll go ahead and make a box plot. So plot underscore ly, and I will map the customer churn dataset onto data. Customer churn, right. So again, the box plot takes in two parameters, and I'd want to understand how does monthly charges change with respect to the internet service. So I will map monthly charges onto the y-axis, following which I'll map the internet service onto the x-axis, right? Okay, so now this time the type which I'll be using would be equal to box. So I get three box plots over here. So this box plot is for all of those customers whose internet service is DSL, and this box plot is for all of those customers whose internet service is fiber optic, and this is for all of those customers who don't even have internet service. Now when I put my mouse pointer over here, so I get all of the So when I put my mouse pointer over here, I basically get the the 5-number summary statistics. So I get the minimum value of monthly charges, I get the maximum value of monthly charges, and I also get the values for interquartile range, right? So the median value of monthly charges when internet service is DSL is around $56. And the median value of monthly charges when internet service is fiber optic is $91. And the median value of monthly charges when the customer doesn't even have internet service is $20. Okay. So now I'll go ahead and add a color to these box plots. So the color would again be determined by the internet service column. Internet service. So the first question that arises in our mind is, what is the need for statistics? So let me make it absolutely clear that statistics is one of the key fundamental skills required for data science. Now, when you try to get into the depth of data science and decide to implement any kind of algorithm, then primary knowledge in statistics is quite important. Actually, statistics and probability are considered as a base knowledge, and they're very essential for building any machine learning algorithm. So let's look at some of the most commonly used statistical terminology in data science. So let's begin with our understanding about population and sample. Now, our population includes all the elements from a set of data. So the whole data set where we have all data of our interest is defined as population. And the sample consists of one or more observations drawn from the population. So we can also say that the population is the collection of all items of interest to our study and is usually denoted with an uppercase N. And the numbers we've obtained when using the population are called as parameters. And a sample is a subset of the population and is denoted with a lowercase n. And the numbers we've obtained when working with the sample are called as statistics. Now let's say we want to conduct a survey of the marks of 100 students. Then 100 students will represent our entire population. So from here, if we take some data, then that data will be a sample. So how do we extract this data from the entire population? Now we cannot just randomly pick it, right? So in a simplified way, we can say that this sample is like an understandable form of the whole population dataset. There are different kind of sampling techniques which we can use to extract the sample data. And we can say that our whole population can be inferred in the sample and we can derive a solution out of it. Now we'll understand what is census and what is survey. So census is something where we gather data from the whole population of interest. So for example, elections or any 15-year census can be considered as a census data. And survey is the gathering of data from the sample in order to make conclusions about the population. So for example, a survey can be opinion polls or quality control checks in manufacturing units. So these two are very general terms which we can mostly hear or see in the newspapers. Now we have already discussed parameter and statistic while discussing population and sample. Now we'll look at them in detail. So a parameter is a descriptive measure of the population. So here any kind of analysis related to population is called as parameter. And some common examples of parameters are population mean, population variance and population standard deviation. So anything related to population data is defined as a parameter. And a descriptive measure of the sample is known as statistic. And the sample data can be sample mean, sample variance and sample standard deviation. So anything related to sample data is defined as statistic. So how are these terminologies actually notated? So here the population parameter is denoted as mu for mean, sigma square for variance and sigma for standard deviation. And the sample statistic is denoted as x bar for mean, s square for variance and s for standard deviation. So these are the standard ways to represent this terminology. Now we'll understand what is sampling. So data sampling is a statistical analysis technique used to select, manipulate and analyze a representative subset of data points in order to identify patterns and trends in the larger data set being examined. So sampling basically allows data scientists, predictive modelers and other data analysts to work with a small, manageable amount of data in order to build and run analytical models more quickly, while still producing accurate findings. So sampling can be particularly useful with data sets that are too large to efficiently analyze in full. So now we'll be moving to an important topic, which is sampling techniques. So as we know, sampling helps a lot in research. It is one of the most important factors which determines the accuracy of your survey result. So if anything goes wrong with your sample, then it will be directly reflected in the final result. And there are a lot of techniques which help us to gather sample data depending upon the need and situation. So to start with, let's have a look on some basic techniques. So what is random sampling? So it is a sampling technique where every item in the population has an even chance and likelihood of being selected in the sample. And here the selection of items completely depends on chance or by probability, and therefore the sampling technique is also sometimes known as method of chances. Here we can take an example of sampling a marble from a vase. We record one or more of its properties, perhaps its color, number or weight, and put it back into the vase. We repeat this procedure n times for drawing a sample of size n, and the idea is illustrated by this figure on the screen. Now when sampling the first marble, each marble has the same chance of 0.1 for being sampled. When sampling the second marble, each marble still has a 0.1 chance of being sampled. This generalizes to all subsequent marbles being sampled. So each time we sample a unit, all units have similar chances of being sampled. This is precisely what we meant with our definition of simple random sampling. So I hope all of you are clear with this. Alright, now if you look over here, it may surprise you that marble 5 occurs twice in our sample. This may happen because we need to replace each marble we sampled. So this technique is known as simple random sampling without replacement. Now let's see how that works. Right, so for the first marble we sample, each marble has a 0.1 chance of being sampled. So far so good, right? So if you don't replace it before sampling a second unit, the first unit we sampled has a 0 chance of being sampled. The other 9 units each have a chance of 1 in 9, which is equal to 0.11 of being sampled as a second unit. So this is how simple random sampling without replacement violates a definition of simple random sampling. And note that this violation gets worse as we sample more units from a smaller population. The next technique is stratified sampling. So with stratified sampling, the researcher divides the population into separate groups called strata. Then a probability sample is drawn from each group So let's consider a situation where a research team is seeking opinions about religion amongst various age groups. So instead of collecting feedback from 320 million US citizens, random samples of around 10,000 can be selected for research. So these 10,000 citizens can be divided into strata according to the age.
Let's have a quick quiz question, guys. And the question is, which of the following is a common statistical analysis technique used to summarize the central tendency of data set? Option A, histogram. Option B, regression analysis. Option C, mean, median and mode. And option D, scatter plot. Please do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
That is groups of 18 to 29, 30 to 39, 40 to 49 and so on. And here each stratum will have distinct members and number of members will also be distinct. So next we have cluster sampling. Now cluster sampling is a sampling technique that divides the main population into various sections or clusters. In the sampling technique, analysis is carried out on a sample which consists of multiple sample parameters such as demographics, habits, background or any other population attribute which may focus on conducted research. It is usually used when groups that are similar yet internally diverse form a statistical population. Instead of selecting the entire population of data, cluster sampling allows the researchers to collect data by dividing the data into small, more effective groups. Now let's consider a scenario where an organization is looking to survey the performance of smartphones across USA. Now they can divide the entire country's population into cities, that is clusters, and further select cities with the highest population and also filter those using mobile devices. Now this multi-stage sampling is known as cluster sampling. So next we'll look at categories of statistics. So as we have already discussed, statistics is concerned with developing and studying different methods for collecting, analyzing and presenting the empirical data. The field of statistics is composed of two broad categories. So the first category is descriptive statistics and the second category is inferential statistics. And both of them give us different insights about the data. One alone doesn't help us much to understand the complete picture of our data, but using both of them together gives us a powerful tool for description and prediction. So let us get the basic idea of what they are. So what is descriptive statistics? Now descriptive statistics is the analysis of data that helps to describe, show or summarize data in a meaningful way. And data can be summarized and represented in an accurate way using charts, tables and graphs. It does not allow us to make conclusions beyond the data which you have analyzed or reached conclusions. And with descriptive statistics, we'll not receive any uncertainty because we are describing only the people or the items that we actually want to measure. So here we are not inferring the properties of a larger population. Now descriptive statistics is actually very important because if we have not presented our data in this way, then it would be very hard to visualize the data. So descriptive statistics help us to present the data in a more meaningful way by which it allows us to make simple interpretations of the data. For example, if we have marks of 1,000 students and we may be interested in the overall performance of those students and the distribution as well as the spread of the marks. Now descriptive statistics provides us the tools to define our data in a most understandable and appropriate way. So in a nutshell, descriptive statistics just describes and summarizes data but does not allow us to draw conclusions about the whole population from which we took the sample. And inferential statistics is about using data from sample and then making inferences about the larger population from which the sample is drawn. Now the goal of inferential statistics is to draw conclusions from a sample and generalize them to the whole population. So it is very important that our sample accurately reflects the population. The reason why sampling techniques are very important is the sample data set reflects the whole population, and then only we do any kind of inferential statistics. Like the mean of sample could be similar to the mean of the whole population, and in case if a sample is not correct or not actually reflecting the whole population, then if you do any kind of inference, that would be wrong because our sample is not reflecting the whole population. For example, suppose we are interested in the exam marks of all the students in UK, but it is not feasible to measure the exam marks of all the students. So now we'll measure the marks of a smaller sample of students. So let's say that can be 1000 students. Now this 1000 student sample will now represent the large population of UK students. And we would consider this sample for our statistical study for studying the population from which it's inferred. And this is the reason that our sample should accurately represent the whole population. And sometimes inferential statistics is also called as inductive statistics. So in a nutshell, inferential statistics makes inferences about populations using data drawn from the population. And instead of using the entire population to gather the data, the statistician will collect a sample and make inferences about the entire population using the sample. When working with statistics, it's important to recognize the different types of data. So the first one is numerical data and the second one is categorical data. For example, if you ask 5 of your friends how many pets they own, they might give you the following data: 0, 2, 1, 4 and 18. Now you need to keep in mind that not all data is numerical. Let's say you also record the gender of each of your friends and you get the following data: male, male, female, male and female. So most of the data falls into one of these two groups, numerical or categorical. So what is numerical data? So numerical data mostly has measurements such as a person's height, weight, IQ or blood pressure, or their account such as the number of stock shares a person owns or how many teeth a dog has. And sometimes this numerical data is also known as quantitative data. Now this numerical data can be further broken into two types, discrete and continuous. So discrete data represents all of those items that can be counted, or in other words, they take on possible values that can be listed out. So the list of possible values may be fixed, also called finite, or it may go from 0 to infinity, making it countably infinite. For example, the number of heads in 100 coin flips takes on values from 0 through 100, and this is nothing but a finite case. On the other hand, the number of flips needed to get 100 heads takes on values from 100, and it goes up to infinity if you never get to that 100th head. So its possible values are listed as 100, 101, 102, and it goes up to infinity, making it a case of countably infinite. And while continuous data represent measurements, their possible values cannot be counted and can only be described using intervals on the real number line. For example, the exact amount of gas purchased at the pump for cars with 20-gallon tanks would be continuous data from 0 gallons to 20 gallons. Now you might pump 8.4 gallons or 8.41 or 8.414863 gallons or any other possible number from 0 to 20. So in this way, continuous data can be thought of as being uncountably infinite. So another type of data is categorical data. So it represents characteristics such as a person's gender, marital status, hometown, or the types of movies they like. And categorical data can also take on numerical values such as 1 indicating male and 2 indicating female. But those numbers don't have any mathematical meaning, like you can't add them together. And this categorical data is also known as qualitative data. Now, categorical data can be further broken into two types, ordinal and nominal. So, ordinal data mixes numerical and categorical data. Now, this data falls into categories, but the numbers placed on the categories have meaning. For example, rating a restaurant on a scale from 1 as lowest to 5 as highest stars gives ordinal data. And this ordinal data is often treated as categorical data. However, unlike categorical data, the numbers do have mathematical meaning. For example, if you survey 100 people and ask them to rate a restaurant on a scale from 1 to 5, taking the average of the 100 responses will have meaning. but this would not be the case with categorical data. And on the other hand, nominal scales are used for labeling variables without any quantitative value. So nominal scales could simply be labels. So here are some examples on the screen. So notice that all of these scales are mutually exclusive and none of them have any numerical significance. So a good way to remember all of this is that nominal sounds a lot like name and nominal scales are kind of like names or labels. So next we'll understand how can we describe data through statistics. So collecting data can be easy and fun, but sometimes it can be hard to tell other people about what you found, and that is why we use statistics. And there are two kinds of statistics frequently used to describe data. So they are measures of central tendency and measures of spread. So these are often called descriptive statistics because they can help you to describe your data. So measures of central tendencies are ways of describing the central position for a group of data. Or in other words, it is a summary statistic that represents the center point or typical value of a dataset. And these measures indicate where most values in a distribution fall and are also referred to as the central location of a distribution. Now you can think of it as the tendency of data to cluster around a middle value. So in statistics, the three most common measures of central tendency are the mean, median, and mode. And each of these measures calculate the location of the central point using a different method. So they basically help summarize a bunch of scores with a single number. And measures of spread, sometimes also called as measures of dispersion, are basically ways of summarizing a group of data by describing how spread out the scores are. Suppose a mean score of 100 students is 65 out of 100. However, not all the students would have scored 65 marks. So the score will be spread out and some will be higher and other might be lower. And to describe and measure spread, we have number of statistics like range, quartile, variance and standard deviation. And these help us to know the spread of scores within a bunch of scores. So let's discuss about the measures of central tendencies in detail. So the mean is the most popular and well-known measure of central tendency. Now it can be used with both discrete and continuous data. So the mean is equal to the sum of all the values in the dataset divided by the number of values in the dataset. So let's say to calculate the mean of the set of numbers 1, 2, 3, 4, 5, first we need to add up the numbers and then divide by 5, which will give us a mean of 3. So in statistics, the mean is denoted as x bar for a set of numbers x1, x2, x3 till xi, and the mean or average is the sum of all x divided by I. So another type of mean is trimmed mean, which is a variation of the original mean. Now, many a times it is noticed by statisticians that the mean is influenced by extreme values. So consider this example of the marks of 5 students with the values 67, 15, 75, 72 and 85. Now the mean of this population is distorted by the influence of one very small value. So we calculate a trimmed mean by dropping the highest and lowest values, which will be equivalent to dropping the lowest and highest 20% of values. So the trimmed mean is calculated as 67 plus 75 plus 72 by 3, which is equal to 71.3. So the value of 71.3 is much closer to the typical values in the distribution than 62.8. And of course, we seldom would be working with a population with only 5 values. But the same principle applies to large populations as well. So another variation of mean is a weighted mean, which we can calculate by multiplying each data value xi by a weight wi and dividing their sum by the sum of the weights. So the formula for a weighted mean is here on the screen. So here are two main reasons for using a weighted mean. Some values are intrinsically more variable than others, and highly variable observations are given a lower weight. For example, if you are taking the average from multiple sensors and one of the sensors is less accurate, then we might lower the weight of the data from that sensor. And in such kind of scenarios, we can put different weights as per the business needs. So in this case, we are manually giving the weights based on our business knowledge, and then we go ahead and calculate the mean. And in the second scenario, the data collected does not equally represent the different groups that we're interested in measuring. For example, let's say there was an experiment conducted and the data obtained could not reflect all the groups in the user base. So to correct that, we can give higher weight to the values from the groups that were underrepresented. And in such cases, weighted mean would give more meaningful sense to the data than in comparison to trimmed mean or normal mean. So that's all about mean, guys. So now we'll go ahead and implement mean in R. So this is our studio, guys. So now to implement mean, all we have to do is use the mean function. And I'd like to get the mean value of the monthly charges column over here. So I'd want to find out the mean of monthly charges. So all I have to do is use the name of the data set. I'll use a dollar symbol and I'll select the column which is monthly charges and I'll get the mean of it. So the mean of this monthly charges is $64. Okay. Now we'll look at median. So the median of a data set is the middle value on the sorted list of data. And in order to calculate the mean, first we have to order our data in ascending or descending order. So the median of the data set is the number at position n plus 1 divided by 2 in the ordered list, where n is the number of observations. So if n equals 7, the middle value is the 7 plus 1 by 2 position value, that is, the fourth value is a median. Now it's actually very simple when we have odd number of observations, but if there's even number of values, the median is the average of two middle values. So this is formally defined as the average of the n by 2th and n by 2 plus 1th value. So if there are 6 values, the median is the average of 6 by 2th and 6 by 2 plus 1th value, or the third and fourth values. Now let's understand the difference between mean and median. So let's say you run a customer satisfaction survey with a sample of 9 members and rate their overall satisfaction score on a scale of 1 to 10. And you get an average of 5.22. And you know that in general, you tend to retain customers with a score over 3. So you're satisfied because this indicates that you're still above where you want to be. But then suddenly you lose 6 of those 9 customers. So now you go back to look at your data and you find these scores. So the median of this group is 3, indicating that at least half of the customers were unhappy. So the scores became lopsided because of the unexpected tens, and this made us miss out on an important part of our data. So in this case, the average can be slightly influenced by few values, making it a bad representative of the majority of the values on the data set. So under these circumstances, median gives us a better representation of the central tendency than mean. So if you have more outliers in a data set, then it is better to use median than mean because mean will give poor central tendency. Now let's implement median in R. Right, so to implement median, we have the median function. So again, I'd like to get the median value of this monthly charges column. Again, I'll take the data set customer churn, I'll give the dollar symbol, I'll give the name of the column which is monthly charges. So the median value of monthly charges is $70. Now we'll look at mode. So mode is the most frequently occurring data point. Now if you consider all of the data we have, then it's not necessary for mean and median to be in the data set. But the mode definitely has to be in it as it is the highest occurring data point in a data set. So next we'll look at variability and spread. So here on the screen we have scorecard of 3 players in a game. So they have played 10 games and these are the frequencies of each player in each game. So in one game, player 1 scored 7, in another he scored 8 and in 2 games he scored 9. Similarly for player 2, in one game he scored 7 and in 2 games he scored 9 and in another 4 games he scored 10. And likewise player 3, in 2 games he scored 3, in one game he scored 6 and he scored 7 in 2 games. So here the mean, median and mode for all the 3 players is 10. So on the basis of this, can we say that the performance of all the 3 players is same? Actually no, because in such a scenario the mean, median, mode are not accurate and we have to use different techniques to understand the variability and spread of data. So one method to calculate variability and spread is range. So range is simply defined as difference between the maximum and minimum observations. So in our example, the range for player 1 can be calculated as 13 minus 7 and for player 2 also it will be 13 minus 7 And for player 3, it'll be 30 minus 3. So range is the difference between the largest and the smallest values in the data. Now we'll implement range in R. So now to implement range, R gives the range function. So range, again I'll give the data set. I'll select the monthly charges column. So this is the range, guys. So this is the minimum value and this is the highest value. Okay. Then we have quartiles. So quartiles tells about the spread of a data set by breaking the data into quarters. So here we have the lower quartile Q1, which is the point between the lowest 25% of values and the highest 75% of values. And it is also called the 25th percentile. And the second quartile, that is Q2, is the middle of the data set. It is also called the 50th percentile or the median. Then the upper quartile, that is Q3, is the point between the lowest 75% and the highest 25% of values. And it is also called the 75th percentile. And the interquartile range is the difference between Q3 and Q1. That is the upper quartile minus lower quartile, and it describes the middle 50% of values when ordered from lowest to highest. This interquartile range is often seen as a better measure of spread than the range as it is not affected by outliers. So if you remember, there is one specific type of graph that is very useful when it comes to describing center, variability and detecting outliers. That graph is a box plot. Now the box plot shows you at a glance Q1, Q2, Q3 along with the outliers. So if we go back to our example, here the third player has scored 30 in one game, which is good, but it is actually an outlier. So if you make a box plot, we can easily point out such outliers. So to get a hang of Q1, Q2, Q3 and outliers, the box plot is the best. So the box plot itself stands for the central 50% of the distribution. That is, the length of the box represents the interquartile range. And the horizontal line inside the box is the median, or in other words, Q2. Now let's implement interquartile range in R. So R provides the IQR function. Let's use it to find out the interquartile range. Again, I want to find out the IQR for monthly charges. So it'll be customer churn dollar monthly charges. So guys, this is the interquartile range for the monthly charges column. Next, we have variance and standard deviation. So variance is something which will tell us how far away is each value in the data from the mean. So first, we subtract the mean from each value in the data, and this gives us a measure of the distance of each value from the mean. So basically, calculating variance involves squaring deviations. So it does not have the same unit of measurement as the original observations. For example, lengths measured in meters have variance measured in meters squared. And taking the square root of the variance gives us the units used in the original scale. And that is actually the standard deviation. So the standard deviation is actually the square root of variance. So here is the formula for variance. So x is the data point and x bar is the sample, and we are calculating how far is the data point from the mean. And standard deviation is just the square root of the variance. So standard deviation is the measure of spread most commonly used when mean is used to calculate central tendency. Thus, it measures the spread around the mean. And because of its close links with the mean, standard deviation can be greatly affected if the mean gives a poor measure of central tendency. So standard deviation is influenced a lot by outliers. So just one value could contribute largely to the results of the standard deviation, and this makes standard deviation a very useful measure of spread for symmetrical distributions with no outliers. And standard deviation is also useful when comparing the spread of two separate data sets that have approximately the same mean. So the data set with the smallest standard deviation has a narrower spread of measurements around the mean and therefore usually has comparatively fewer high or low values. So an item selected at random from a data set whose standard deviation is low has a better chance of being close to the mean than an item from a data set whose standard deviation is higher. And generally, the more widely spread the values are, the larger the standard deviation is. For example, imagine that we must separate two different sets of exam results from a class of 30 students. So the first exam has marks ranging from 31% to 98%, and the other ranges from 82% to 93%. So given these ranges, the standard deviation would be larger for the results of the first exam because the spread is more from 31% to 98%. Whereas in other, standard deviation will be less as it ranges from 82% to 93% and the data is not widely spread. So now we'll implement variance and standard deviation in R. So R provides VAR and SD functions to get the variance and standard deviation. So again, I do want to find out the variance with respect to the monthly charges column. So I'll type customer churn $monthly charges. So this is the variance, guys, 905. Now I'll also calculate the standard deviation. So I need to put SD over here. So I'll select the monthly charges column again. Right, so this is the standard deviation, guys. And these are some properties of standard deviation. So standard deviation is only used to measure spread or dispersion around the mean of a data set. And it is never negative. And standard deviation is sensitive to outliers. So single outlier can raise the standard deviation and in turn distort the picture of spread. And for data with approximately the same mean, the greater the spread, the greater the standard deviation. And if all the values of a data set are the same, the standard deviation is 0 because each value is equal to the mean. Now, learning about probability helps us make informed judgments on what is likely to happen based on a pattern of data collected previously. So let's explore probability. Now, probability seeks to answer the question, what is the chance of an event happening? And an event is some outcome of interest. To calculate the chance of an event happening, we also need to consider all the other events that can occur. So as we can see in the formula, probability of an event happening, that is P of E, is equal to times of an event occurred divided by a total number of opportunities for the event to have occurred, which means the number of ways it can happen divided by the total number of outcomes. Now let's look at an example of probability. So Emma here owns a large fish store with many colors of fish. She keeps all of the fish in a large aquarium. So in her main aquarium, she has 5 orange fish, 6 purple fish, 14 blue fish and 5 green fish. Now, a customer comes into the store and wants to buy a purple fish. So what is the probability that Emma will reach in and scoop out a purple fish on a first scoop? So to calculate this probability, Emma needs to find out the total number of fish in her aquarium. So Emma needs to add the 5 orange fish plus 6 purple fish plus 14 blue fish plus 5 green fish, which is equal to 30 in total. Now Emma must also know the number of favorable outcomes. So in her tank there are only 6 purple fish, and that makes the number of favorable outcomes to be 6. And the formula to calculate probability is the number of favorable outcomes over the number of total outcomes. So the number of favorable outcomes is 6 and the number of total outcomes is 30. So the probability of Emma scooping a purple fish the first time is 6 out of 30. And also remember, all fractions must be in simplest form. So 6 over 30 will reduce to 1 over 5, and hence the probability that Emma will scoop out a purple fish on a first try is 1 by 5. So now we'll look at the major difference between probability and statistics. So probability and statistics are related areas of mathematics which concern themselves with analyzing the relative frequency of events. Still, there are some fundamental differences. So probability deals with predicting the likelihood of future events, while statistics involves the analysis of the frequency of past events. And probability is primarily a theoretical branch of mathematics which studies the consequences of mathematical definitions, while statistics is primarily an applied branch of mathematics which tries to make sense of observations in the real world. Now we'll look at the key terms used in probability. So an experiment in probability is a test to see what will happen in case you do something. So simple example is flipping a coin. So when you flip a coin, you are performing an experiment to see what side of the coin you'll end up with. And an outcome in a probability refers to a single result of an experiment. So in the example of experiment, one outcome would be heads and the other outcome would be tails. Then we have event. So event is the set of group of different outcomes of an experiment. Suppose you flip a coin multiple times, then an event would be getting a certain number of heads. And the sample space is the total number of all the different possible outcomes of a given experiment. So if you flip the coin multiple times, all the different combinations of heads and tails would make up the sample space. So a sample space is also defined as the universal set for the outcomes of a given experiment. Next, we'll focus on a couple of rules which we'll need to follow in probability. So here, this is the total sample space we have, and the probability of this area is 1. Here, if any event occurs, then the probability of an event lies between 0 and 1. So if an event is certain to occur, it will have a probability of 1, and if there is no chance of the occurrence of an event, then the probability will be 0. So the area of the rectangle denotes sample space, and since the probability is associated with the area, it obviously cannot be negative. So now we'll look at mutually exclusive events. So here the events cannot occur at the same time. If event A occurs, then event B cannot. So if A and B are mutually exclusive events, then the probability of A and B happening together is 0. And here the probability that A or B will occur is the sum of the probability of each event. That is, probability of A or B equals probability of A plus probability of B. And there is also a possibility that if event A and B are not mutually exclusive, then we will be removing this intersection part. So when they are mutually exclusive, to calculate probability, we are just adding event A and B. And when they are not mutually exclusive, then the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Now, two events are known to be independent events if the occurrence of one event will have no effect on the probability of the other one. So if A and B are two independent events and probability of A and probability of B be their probabilities, then probability of both A and B occurring would be probability of A into probability of B. For example, the probability of rolling a dice and getting a 2 for the first time and also for the second time. So those events are independent, right? So next we'll discuss different types of probability. So mainly probability can be defined in two categories, frequent and conditional probability. So frequent probability is used to find the chance of a particular outcome. Now let's say we toss a fair coin with the outcome of tail as 1 and head as 0. Suppose if we repeat this experiment 1000 times and after completing this experiment we receive the outcome as 600 times tails and 400 times heads. And if we count how frequent the heads or tails have come in the past, then we'll get the result as 60% tails and 40% heads. And this frequency can be considered as probabilities for fair coin coming up as head or tails, and this is the frequent probability. And then we have conditional probability of an event, which measures the probability of an event if another event has already occurred. So in other words, we can say that the conditional probability of an event is the probability of that event given that another event has already taken place before it. So let A and B be two events associated with an experiment. Then the occurrence of B is restricted by the fact that A will have occurred before B and will affect B. And this is how we can get the occurrence of B given that A has taken place. So let's consider these two events, A and B. So A is the probability for rain and B is the probability that the league game is cancelled. Now from these definitions, you might quickly realize that the two events are not mutually exclusive. That is, both A and B could occur simultaneously. Also, the two events are not likely to be independent of one another. That is, the event of rain will greatly increase the likelihood that the league game is cancelled. So what is the probability that the league game is cancelled given that it rains today? So this probability is called as conditional probability because we are given the condition that it is raining. In other words, event B is no longer a what if. We already know that it has occurred and it may or may not have an impact on the probability of event A. Therefore, given that event B has already occurred, what is the probability of A? Is our conditional probability. So the conditional probability of A given B is denoted by P of A given B, which is equal to P of A and B divided by P of B. And here probability of B should be greater than 0. And if we cross multiply, then probability of A and B becomes probability of B into probability of A given B. And similarly, the conditional probability of B given A is denoted by probability of B given A equals probability of P and B divided by probability of A. And over here, probability of A should be greater than 0. And again, if we cross multiply, then probability of A and B becomes probability of A into probability of B given A. And again later, when we equate these two equations, then probability of A given B into probability of B is equal to probability of B given A into probability of A. And if we take probability of B from LHS to RHS, then probability of A given B is equal to probability of B given A into probability of A divided by probability of B. And this is the base theorem of conditional probability. So next we'll discuss probability distribution. So the probability function for a discrete random variable is the probability mass function. It shows the exact probabilities for a particular value of the random variable. So suppose you're a teacher in a university and after checking assignments for a week, you graded all the students. Now you gave these graded papers to a data entry guy in the university and told him to create a spreadsheet containing the grades of all the students. But the guy stores only the grades and not the corresponding students. And he also made another blunder. He missed a couple of entries in a hurry and we have no idea whose grades are missing. So let's find a way to solve this. So one way is that you visualize the grades and see if you can find a trend in the data. So the plot here is frequency distribution of the data. And you see that there is a smooth curve-like structure that defines our data. But do you notice an anomaly? So we have an abnormally low frequency at a particular score range. So the best guess would be to have missing values that remove the dent in the distribution. And this is how we would try to solve a real life problem using data analysis. So for any data scientist, student or a practitioner, distribution is a must-know concept. It provides the basis for analytics and inferential statistics. And while the concept of probability gives us the mathematical calculations, distributions help us to actually visualize what's happening underneath. And we have different types of distributions like Bernoulli distribution, binomial distribution, normal distribution, exponential distribution, and so on. Now, covariance and correlation are two concepts in the field of probability and statistics. Both are concepts that describe the relationship between two variables. And also, both are tools of measurement of a certain kind of dependence between variables. So what is correlation? Now, when you say that two items correlate, you're basically saying that the change in one item affects a change in another item as well. You'll always talk about correlation as a range between -1 and 1. For example, if you say that two items have a correlation of 0.9, you're basically saying that a change in one item results in a similar change to another item. So for example, all the stock market indexes tend to move together in similar directions. When Dow Jones loses 5%, S&P 500 would also lose around 5%. And when Dow Jones gains 5%, S&P 500 would also gain around 5%. And that is because they are highly correlated. Now there could also be negative correlation where you might observe that as Dow Jones loses 5% of its value, gold might gain 5%. Alternatively, if Dow Jones gains 5% of its value, gold would in turn lose 5% of its value. And in addition, correlation values are dependent on units of measure of X and Y. So what is covariance? Now if you say that two items tend to vary together, then you're talking about the covariance between the two items, which can be positive or negative covariance. To simplify, covariance tries to look into and measure how much variables change together. So positive covariance indicates that higher than average values of one variable tend to be paired with higher than average values of the other variable. And negative covariance indicates that higher than average values of one variable tend to be paired with lower than average values of the other variable. And covariance is not standardized unlike the correlation coefficient. Therefore, covariance values can range from negative infinity to positive infinity. Both covariance and correlation have distinctive types. So covariance can be classified as positive covariance, which means two variables tend to vary together, and negative covariance means one variable is above or below the expected value while compared to another variable. On the other hand, the correlation has three categories: positive, negative, or zero. So positive correlation is indicated by a plus sign, Negative correlation is indicated by a minus sign, and 0 is for uncorrelated variables. Another notable difference is that correlation is dimensionless. So in contrast, covariance is in units, which is formed by multiplying the unit of one variable to another unit of another variable. So covariance provides a measure of the strength of the correlation between two or more sets of random variates. So the covariance for two random variates x and y, each with sample size n, is defined by the expectation value. So in this formula, x represents the independent variable, y represents the dependent variable, n represents the number of data points in the sample, x bar represents the mean of the independent variable, and y bar represents the mean of the dependent variable. So now we'll look at the formula for correlation. Here, COV of xy is the covariance between the x and y, sigma of x is the standard deviation of x, and sigma of y is the standard deviation of y. Now let's look at some differences between covariance and correlation. So the measure used to indicate the extent to which two random variables change in tandem is known as covariance. And the measure used to represent how strongly two random variables are related is known as correlation. Now covariance is nothing but a measure of correlation. On the contrary, correlation refers to the scaled form of covariance. And the value of correlation lies between -1 and +1. Conversely, the value of covariance lies between -infinity and +infinity. And covariance is affected by the change in scale. As against this, correlation is not influenced by the change in scale. So that's the reason we mainly use correlation instead of covariance, because it is the most standardized version. Now let's take an example to understand correlation. In a particular concert, the number of attendees is dependent on how many hours the sunlight is there. Here we have a distribution of sunlight and concert attendance. So here the number of attendants depends upon the sunshine. So if we plot it out, then we'll understand how the sunlight is impacting the concert attendance and whether they are correlated or not. So let's check it out. Now whenever we are plotting any particular scatter plot, we need to make sure that on the x-axis we'll always have the independent variable and the y-axis will always be the dependent variable. So over here our independent variable is sunshine, and based on that we would like to see what is the relationship with the concert attendance. So concert attendance is nothing but the dependent variable. So here we have made a scatter plot of this data set. We have sunshine on the x-axis, which ranges from 0 to 8 hours, and on the y-axis we have the concert attendance in hundreds. So you can see that as the duration of sunlight increases, the concert attendance also increases. So yes, there is a correlation between sunlight and concert attendance. Now there could be different cases in correlation, such as positive linear correlation, negative linear correlation, and there could even be no correlation at all. Here in positive linear correlation, we see that if the independent variable is increasing, then the dependent variable is also increasing, and they are positively correlated to each other. In case of negative linear correlation, as the independent variable increases, the dependent variable decreases. And in the third case, there is absolutely no correlation between the dependent and the independent variables. So now we'll focus on the correlation coefficient. As we know that correlation is a relationship between two sets of variables used to describe or predict information. Therefore, the correlation coefficient is the degree in which the change in a set of variables is related. This means that we are trying to find out if the two variables have a correlation at all, how strong the correlation is, and if the correlation is positive or negative. And to find the exact correlation between variables, you'll need to use the correlation coefficient equation. So when solved, the correlation coefficient equation will give you a number between -1 and 1. The closer the number is to a positive 1, the stronger the positive correlation. A change in the value of one variable will predict a change in the same direction in the second variable. And the closer the number is to a negative 1, the stronger the negative correlation. A change in the value of one variable predicts a change in the opposite direction in the second variable. And the closer the number is to 0, the weaker the correlation. 0 means there is no correlation between the two variables. So coefficient of 0 indicates there is no discernible relationship between fluctuations of the variables. So this is the formula for calculating correlation coefficient, where R denotes the correlation coefficient, which is equal to the covariance of x and y divided by standard deviations of x and y. So here if r equals 1, that means for every positive increase in one variable, there is a positive increase of a fixed proportion in the other. It is associated with perfect positive correlation. That is, with the increase in x-axis, the y-axis will also increase. For example, shoe sizes go up in perfect correlation with foot length. And if r equals -1, this means that for every positive increase in one variable, there is a negative decrease of a fixed proportion in the other. It is associated with perfect negative correlation moving opposite to each other. For example, the amount of gas in a tank decreases in perfect correlation with speed. And when it is 0, this means that for every increase, there isn't a positive or negative increase. The two just aren't related to each other. So now a lot of times we have heard correlation does not cause causation, or correlation does not imply causation, or correlation is not causation. But what does this actually mean? As we know, correlation describes the size and direction of a relationship between two or more variables, while causation indicates that one event is the result of the occurrence of the other event. That is, there is a causal relationship between the two events. This is also referred to as cause and effect. The classic causation versus correlation example that is frequently used is that smoking is correlated with alcoholism but doesn't cause alcoholism, while smoking causes an increase in the risk of developing lung cancer. Now we'll look at different relationship causes like A causes B, which is known as direct causation, or B causes A. So this is reverse causation. Then A and B both are the consequences of the common cause, but they both do not cause each other. Or A and B both cause C, which is another condition. Or A causes C, which causes B. So this is an indirect causation. Thus, there can be no conclusion made regarding the existence or the direction of a cause and effect relationship only from the fact that A and B are correlated. So determining whether there is an actual cause and effect relationship requires further investigation. Even when the relationship between A and B is statistically significant, a large effect size is observed or a large part of the variance is explained. For example, the faster windmills are observed to rotate, the more wind is observed to be. Therefore, wind is caused by the rotation of windmills. So in this example, the correlation between windmill activity and wind velocity does not imply that wind is caused by windmills. It is rather the other way around, as suggested by the fact that wind doesn't need windmills to exist, while windmills need wind to rotate. So wind can be observed in places where there are no windmills or non-rotating windmills. And there are obviously good reasons to believe that windmills existed before the invention of windmills.
So when it comes to statistical analogy, hypothesis basically is a premise or a claim which has to be tested or it has to be investigated. So let's say I just make a claim that whenever I wear a blue shirt, it will definitely rain on that particular day. So this is a claim which I'm making, and now in statistical analogy, this claim has to be tested. So this is the premise of hypothesis testing. So as it is written over here, hypothesis testing is basically an assumption about a population parameter, and this assumption may or may not be true. So I'll just make a claim that if I wear a blue shirt, then it will definitely rain on that particular day. Right? So there is a very good chance for this claim to be not true, or there is also a very good chance for this claim to be true. Right. Now there are two things which we have to learn when it comes to hypothesis testing. So we have something known as null hypothesis, and then we have alternate hypothesis. So when you hear the term null, you basically think of, let's say, zero or empty. So what is null hypothesis? So null hypothesis is basically the claim which you make. So this is your initial claim, right? And when it comes to null hypothesis, we assume that the sample observations result purely from chance. So there is no non-random cause influencing this particular data set or these particular observations. And then we'll head on to alternate hypothesis. So when it comes to alternate hypothesis, this is basically we are stating that no, null hypothesis is wrong and there is a very good possibility that there is something else which exists apart from the null hypothesis. So as it is stated over here, alternate hypothesis basically states that the sample observations are influenced by some non-random cause. And I'll give an example to make this clear. So let's take the time when an apple hit Newton's head. Right? And on the basis of this, he developed calculus and all of the gravitational theory. Now, this would be your null hypothesis. And after, let's say, hundreds of years later, Einstein came in And he said that no, this is not right. So there is a lot more than what is going on in Newton's philosophy of gravitation. So there is time and space involved, and there are a lot of other factors which come into the picture. So this would be the alternate hypothesis. So over here, Newton's theory would be the null hypothesis, and then Einstein's theory would be the alternate hypothesis. And Einstein would give his postulates to make sure that the null hypothesis is removed. And these are the symbols to denote null hypothesis and alternate hypothesis. So null hypothesis is denoted by H0 and alternative hypothesis is denoted by either H1 or HA. Right, now let's understand hypothesis with this example. So let's say you have a coin and you assume that this is an unbiased coin. So there is a 50% probability of getting head and there is also a 50% probability of getting tail. So this is your null hypothesis. So your null hypothesis is that there is a 50% probability of getting head and there is also a 50% probability of getting tails. Right. But what happens is when you actually go ahead and toss this coin 100 times, you get 99 heads and only one tail. So don't you think there is something wrong with this? So you had assumed that you actually have a unbiased coin, but you are dealing with an unbiased coin where you have 99 heads and just one tail. So there is something which is making this coin give you more heads. So with the help of this test, you understand that the probability of getting heads and tails is actually not exactly 50%. So your null hypothesis stated that there is 50% probability for getting both heads and tails. So on the basis of these experiments which you had conducted, you can disprove the null hypothesis, and you're saying that it is not actually 50% probability to get heads and tails. So there is actually a greater probability of getting more heads and less tails, and hence you go ahead and reject the null hypothesis. Right, so this is the structure of the hypothesis test. So you start off by stating the hypothesis, which is basically your null hypothesis, and then your alternate hypothesis, and then you go ahead and formulate an analysis plan. Now after you have an analysis plan, you will go ahead and analyze the sample data, and once you have your results, you have to interpret the results. So this is the basic structure of all of your hypothesis tests. Alright, now there are different types of hypothesis tests useful for different hypothesis scenarios and data samples. So as your data changes, then you'd have to use a different hypothesis test for your different data sets. And these are some of the most frequently used hypothesis tests. So you've got t-test and chi-square test for independence. So let's start off with the first one, which is t-test. So a t-test basically checks if the averages or means of two groups are reliably different from each other. Or in other words, it lets you know if these differences could have happened by chance. Now this definition seems to be complicated. So let's again understand this with the help of an example. So let's say we've got a drug company which wants to test a new cancer drug to find out if it improves life expectancy. So we've got two groups over here, and one group is actually given the actual drug and the other group is given a placebo. Right, so we've got this blue colored group over here and all of the people in this group are given the actual drug, and we've got the second group over here and all of the people in the second group are given the placebo. Now the first group shows an average life expectancy of plus 6 years after taking the actual drug, while the second group shows an average life expectancy of plus 5 years after taking the placebo. Now on the basis of this experiment, can you actually say that the drug works? So this is the question which you're facing, right? So on the basis of this particular experiment, you have actually seen that the first group, which was given the actual drug, has a greater life expectancy than the second group, which was given a placebo. Now, let's say if I take a different population and give them an actual drug, or if I increase the number of people in the first group, then will it work with the other groups as well? Right? So this is what we actually want to know. And this is where t-test comes in. Right, so now when it comes to t-test, we have something known as a t-score, and t-score is the ratio between the difference between two groups and the difference within the two groups. Now if we take these two groups over here, we actually want to understand if these two groups are same or they are actually different, right? Now when it comes to the t-score, so if the t-score is very large, then it would mean that these two groups are very different, and if the t-score is very small, then it would mean that these two groups are actually very similar in nature. And t-score is basically signal upon noise, or in other words, it is the variance between the groups upon variance within the groups. Now let's say we go ahead and calculate the t-score. So the difference between the groups comes out to be around 6 and the difference within groups comes out to be around 2. So when you divide 6 with 2, you get a ratio of 3. So this means that the first group is 3 times more different than the second group. Now this actually tells you that there is quite a bit of difference between the first group and the second group. And on the basis of this, you can actually conclude that this drug might actually work. So that was t-score. Now let's go ahead and understand the next hypothesis test, which is chi-square test for independence. So the chi-square statistic is commonly used for testing relationships between categorical variables. Now the null hypothesis of the chi-square test is that there is no relationship existing on the categorical variables in the population. So they are absolutely independent. So over here, we are trying to determine if there's a relationship between the gender of a student and the result of the exam. So over here, the null hypothesis would state that there is absolutely no relationship between the gender of a student and the result of the exam. Right. Now let's take this example to understand chi-square test in a better way. So we've got 500 students in total again, and out of those 500 students, we've got 300 boys and 200 girls. And all of them are asked what is their favorite color. Is it blue, green or pink? Now, we'd have to determine is there a relationship between gender of the student and the favorite color. So we go ahead and tabulate this. Now this is the formula to calculate chi-square. So O minus E whole square upon E. So over here, O is the observed value of the categorical variables. E is the expected value of the categorical variables. And this symbol which you see, this is basically chi-square test of independence. Right. So these are all of the steps which you would have to perform while implementing chi-square test. So you'd have to start off by defining the null and alternate hypothesis, and then you'll go ahead and state a value for alpha, following which you will calculate the degrees of freedom, and then you'll state your decision rule. Going ahead, you'll calculate the test statistic, and finally you will state the results and the conclusion. So we'll start off with our first step where we'd have to define the null and the alternate hypothesis. So over here, H0 is the null hypothesis, and the null hypothesis for this data would be that gender and the favorite color of the student are not related. And the alternate hypothesis would be for this particular population, gender and favorite color are actually related. So this is your first step where you have defined your null and alternate hypothesis. Then you'll go ahead and do the second step where you're stating the alpha. So before we run any statistical test, we must first determine the alpha level, which is also called the significance level. And by definition, alpha level is the probability of rejecting the null hypothesis when the null hypothesis is true. So let's say the null hypothesis is actually true and the alpha value is 0.05. So this means that there is a 5% of risk of actually stating that there is a difference which exists when actually there is no difference between the categories. Right, so and over here we are taking the alpha level to be 0.05 for this particular example. Going ahead, we'll calculate the number of degrees of freedom. So number of degrees of freedom is obtained by multiplying number of rows minus 1 into number of columns minus 1. So we've got 2 rows over here, it would be 2 minus 1, and we've got 3 columns over here, it would be 3 minus 1. And when you multiply 1 with 2, you get 2 degrees of freedom. And then we'll go ahead and state the decision rule. Now before we state the decision rule, we'd have to find out the critical value. And we can get the critical value using this chi-square table. So this chi-square table has the number of degrees of freedom denoted over here on the rows. And then we've got the alpha value stated over here on the column side. And since we have 2 degrees of freedom and the alpha value is 0.05, our critical value would be 5.991. And on the basis of this, we can state the decision rule that if chi-square is greater than 5.99, we'll go ahead and reject the null hypothesis. Right. Now it's time to calculate the test statistic. So to calculate the test statistic, we already know the formula. So it is O minus E whole square upon E. And over here, we'd actually have to calculate the expected value. So these are the observed values over here, but we would also have to calculate the expected value. So expected value would be frequency of number of columns into frequency of number of rows upon total number of records over here. So let's say if I want to determine the frequency of all of the boys whose favorite color is blue. So that would be frequency of columns since the color is blue. So we'd have to take this column over here, which would be 120. And then we'd have to take the frequency of rows, which is boys over here. This would be 300. So 120 into 300, and then we'll divide this with the total number of records over here, which is 500. So 120 into 300 divided by 500 would give you an expected value of 72. Similarly, let's say if you want to calculate the expected value of boys, green, it would be 180 into 300 divided by 500. For boys and pink, it would be 200 into 300 divided by 500. And when it comes to girls and blue, it would be 120 into 200 divided by 500. When it is girls and green, it would be 180 into 200 divided by 500. And finally, when it comes to girls and pink, it would be 200 into 200 divided by 500. So when we perform all of this, we'll get the expected values over here. So these are our observed values and these are the expected values which we have calculated using the above formula. Now we'll get the final table where we have the observed values and the expected values in the same table. Right, so this is the actual values, and then in the parenthesis we've got the expected values over here. And then we'll go ahead and use our formula and then calculate the chi-square value. So it'll be observed minus expected whole square upon the expected value. So it'll be 100 minus 72 whole square plus 72, and similarly it'll go on. And we calculate the entire thing, we'll get a chi-square value of 276.37. Right, so it's finally time to state our result. Now our decision rule stated that if chi-square is greater than 5.99, we'll go ahead and reject the null hypothesis. And over here, after performing all of our calculations, we've got a chi-square value of 276.37, and that is why we'll go ahead and reject this null hypothesis. Right. So the conclusion is this: in this population, there is actually a relationship which exists between the gender of the student and the favorite color of the student. So one method of evaluating this research question is via a process called as hypothesis testing, which is sometimes also referred to as significance testing. And there are many facets to this. So a statistical hypothesis is an assumption about a population parameter, and this assumption may or may not be true. So hypothesis testing refers to the formal procedures used by statisticians to accept or reject statistical hypothesis. But the best way to determine whether a statistical hypothesis is true would be to examine the entire population. Since that is often impractical, researchers typically examine a random sample from the population. And if the sample data is not consistent with the statistical hypothesis, the hypothesis is rejected. So now we'll look at the types of statistical hypothesis. So mainly there are two types of statistical hypothesis: null hypothesis and alternative hypothesis. So the null hypothesis is denoted by H0 and is usually the hypothesis that the sample observations result purely from chance. And the alternative hypothesis is denoted by H1 or HA and is the hypothesis that the sample observations are influenced by some non-random cause. For example, suppose we wanted to determine whether a coin was fair and balanced. So a null hypothesis might be that half the flips would result in heads and half in tails. And the alternative hypothesis might be that the number of heads and tails would be very different. So symbolically, the hypothesis would be expressed as for H0, P equals 0.5, and for H1, P is not equal to 0.5. So suppose we flip the coin 50 times, resulting in 40 heads and 10 tails. Now, given this result, we would be inclined to reject the null hypothesis, and we would conclude based on the evidence that the coin was probably not fair and balanced. So hypothesis testing is about testing to see whether the stated hypothesis is acceptable or not. And during our hypothesis testing, we want to gather as much data as we can so that we can prove our hypothesis one way or another. So statisticians follow a formal process to determine whether to reject a null hypothesis based on sample data. And this process is called as hypothesis testing, consisting of 4 steps. So the first step is to state the hypothesis. Now this involves stating the null and alternative hypothesis. So the hypotheses are stated in such a way that they are mutually exclusive. That is, if one is true, then the other must be false. Next step is to formulate an analysis plan. So the analysis plan describes how to use sample data to evaluate the null hypothesis. And the evaluation often focuses on a single test statistic. And then in the next step, we will analyze the sample data. So here we will find the value of the test statistic like mean score, proportion, t statistic and z score described in the analysis plan. And the last step is to interpret the results. And here we apply the decision rule described in the analysis plan. And if the value of the test statistic is unlikely based on the null hypothesis, it will reject that null hypothesis. So for example, a cleaning company can publish information that proves that their cleaning product kills 99% of all germs. So if they perform a hypothesis test that has data that proves their hypothesis that their cleaning product kills 99% of the germs. And while these tests can be very helpful, there is a danger when it comes to interpreting the results. It is possible to make two different kinds of errors when interpreting the results. Next, we'll look at the types of errors that can result from a hypothesis test. Now, hypothesis testing in statistics involves deciding whether to reject or not reject a null hypothesis. There are problems that can occur when making decisions about a null hypothesis. And mainly two types of errors can result from a hypothesis test. So it can be either a type 1 error or a type 2 error. So a type 1 error occurs when the researcher rejects a null hypothesis when it is actually true. So this error happens when you say that the null hypothesis is false when it is actually true. Our null hypothesis is the hypothesis for our expected outcome. So if our null hypothesis is that dogs live longer than cats, it would be like saying dogs don't live longer than cats when in fact they do. And to help you remember this type 1 error, think of it as having just one wrong. So you are wrongly thinking that the null hypothesis is false. And in statistics, we label the probability of making this kind of error with this symbol. So it's alpha over here. Now usually it is 0.05, which means that you're okay with a 5% chance of making a type 1 error. Now the lower the alpha number, the lower the risk of you making such an error. And the tricky part with setting the alpha number is that if you set it too low, it may mean that you won't catch the really small differences that may be there. The other type of error is called a type 2 error. So a type 2 error occurs when the researcher fails to reject a null hypothesis that is false. So this type of error happens when you say that the null hypothesis is true when it is actually false. And for a null hypothesis that dogs live longer than cats, it would be like saying that dogs do live longer than cats when in fact they don't. Now to help you remember a type 2 error, think of two wrongs. So you're basically wrongly thinking that the null hypothesis is wrong. And the probability of making a type 2 error is labeled with a beta symbol. So this type of error can be decreased by making sure that your sample size, the number of tests and the number of subjects you have is large enough so that the real differences can be spotted. So for the dogs and cats, this would mean that you need to gather data about enough dogs and cats to see real difference between them. So if you have information about just one dog and one cat, you can't say for sure that the statement that dogs live longer than cats is true or not. And if the dog lives longer than the cat, then you might make the mistake of saying that dogs do live longer than cats, even though the opposite were true. So your sample size isn't large enough for you to see the difference. And if you take this beta value and subtract it from 1, that is 1 minus beta, you will get what is called the power of your test. So the higher the power of your test, the less likely you are to make a type 2 error. So with this, we can easily identify the type 1 and type 2 errors. So type 1 error is false positive and telling a man is pregnant, and type 2 error is false negative and telling pregnant woman is not pregnant. So here is the metrics to understand this example in a better way. So let's look at true positive. So here the interpretation is you predicted positive and it's actually true. That is, you predicted that a woman is pregnant and she actually is. Then we have true negative. So here the interpretation is you predicted negative but it's actually true. That is, you predicted that a man is not pregnant and he actually is not. Then we have false positive. That is type 1 error. So here the interpretation is you predicted positive but it's false. That is, you predicted that a man is pregnant but he actually is not. And finally we have false negative. That is type 2 error. So here interpretation is you predicted negative and it's false. That is, you predicted that a woman is not pregnant but she actually is. Now we will look at some of the decision rules for rejecting the null hypothesis. So a z-value is a measure of standard deviation. That is, how many standard deviations away from the mean is the observed value. For example, if the z-value is plus 1.8 it can be interpreted as the observed value is plus 1.8 standard deviations away from the mean. And the p-values are just the probabilities. So both these statistical terms are associated with the standard normal distribution. So z-score can be calculated from the following formula. So z equals x minus mu upon sigma, where z is the z-score, x is the value of the element, mu is the population mean, and sigma is the standard deviation. For example, let's say you have a test score of 190 and the test has a mean of 150 and a standard deviation of 25. And assuming a normal distribution, your z-score would be 190 minus 150 upon 25, which would be equal to 1.6. So you could say that our score is 1.6 standard deviations above the mean. And this is how we can interpret the z-scores. So a z-score less than 0 represents an element less than the mean. A z-score greater than 0 represents an element greater than the mean. And a z-score equal to 0 represents an element equal to the mean. And a z-score equal to 1 represents an element that is 1 standard deviation greater than the mean. Similarly, a z-score equal to 2 represents an element 2 standard deviations greater than the mean, and so on. And a z-score equal to minus 1 represents an element that is 1 standard deviation less than the mean. Similarly, a z-score equal to minus 2 represents an element which is 2 standard deviations less than the mean, and this goes on. So if the number of elements in the set is large, about 68% of the elements have a z-score between minus 1 and 1, and about 95% have a z-score between minus 2 and 2, and about 99% have a z-score between minus 3 and 3. Now we'll look at p-values. So in simple terms, when you perform a hypothesis test in statistics, a p-value helps you determine the significance of your results. And the p-value, or calculated probability, is the probability of finding the observed or more extreme results when the null hypothesis of a study question is true. So the definition of extreme depends on how the hypothesis is being tested. Now p can also be described in terms of rejecting h naught when it is actually true. However, it is not a direct probability of the state. And the term significance level is used to refer to a pre-chosen probability, and the term p-value is used to indicate a probability you can calculate after a given study. And if your p-value is less than the chosen significance level, then you reject the null hypothesis. That is, you accept that your sample gives reasonable evidence to support the alternative hypothesis, though it does not imply a meaningful or important difference, and that is for you to decide when considering the real-world relevance of your result. And the choice of significance level at which you reject h naught is arbitrary. Now, the evidence in the trial is your data and statistics that go along with it. All the hypothesis tests ultimately use a p-value to weigh the strength of the evidence. That is, what data is telling you about the population. Now, the p-value is just a number between 0 and 1, and it can be interpreted in the following way. So, a small p-value, typically equal to or less than 0.05, indicates strong evidence against the null hypothesis. So, you reject the null hypothesis. Large p-value, which is greater than 0.05, indicates weak evidence against the null hypothesis. So, you fail to reject the null hypothesis. And p-values which are very close to the cutoff, 0.05, are considered to be marginal. Now, you always have to report the p-values so your readers can draw their own conclusions. So for example, suppose a pizza place claims the delivery time is 30 minutes or less on average, but you actually think it's more than that. Now you conduct a hypothesis test because you believe the null hypothesis h naught, that is, the mean delivery time being 30 minutes max, is actually incorrect. So your alternative hypothesis HA is that the mean time is greater than 30 minutes. So you randomly sample some delivery times and run the data through the hypothesis test, and your p-value turns out to be 0.001, which is much less than 0.05. So in real terms, there is a probability of 0.001 that you will mistakenly reject the pizza place's claim that their delivery time is less than or equal to 30 minutes. And since typically we are willing to reject the null hypothesis when this probability is less than 0.05, you conclude that the pizza place is wrong and the delivery times are in fact more than 30 minutes on average. So both z-scores and p-values are associated with the standard normal distribution. So the table on the screen shows the uncorrected critical p-values and z-scores for different confidence levels. Now consider an example. The critical z-score values when using a 95% confidence level are minus 1.96 and plus 1.96 standard deviations. So the uncorrected p-value associated with a 95% confidence level is 0.05. So if your z-score is between minus 1.96 and plus 1.96, your uncorrected p-value will be larger than 0.05, and you cannot reject your null hypothesis because the pattern exhibited could very likely be the result of random spatial processes. And if the z-score falls outside the range, for example minus 2.5 or plus 5.4 standard deviations, the observed spatial pattern is probably too unusual to be the result of random choice, and the p-value will be small to reflect this. So in this case, it is possible to reject the null hypothesis and proceed with figuring out what might be causing the statistically significant spatial structure in your data. So key idea here is that the values in the middle of the normal distribution represent the expected outcome. Now data pre-processing plays a crucial role in data mining. So whenever you are dealing with parameters of different units and scale, it is important to understand the data pre-processing and scaling methods. So scaling or rescaling is nothing but changing the type of data measurement that you are using in your data. And there are two types of rescaling methods commonly used, which are standardization and normalization. Now let us say we have a list of student heights. So some of the data is in centimeters, while some of the data is in the form of feet. Now the data has to be scaled either to centimeters or feet. So this scaling of data is used in a lot of scenarios. And one such application where this technique is used is in machine learning algorithms. So there is a lot of math involved in machine learning, and that is why standardization and normalization is used a lot. So now first understand what is standardization. So standardization is also called z-score normalization, and in standardization features will be rescaled so that they'll have the property of any standard normal distribution with mean 0 and standard deviation of 1. So this is the formula to calculate the z-score: x minus mu divided by sigma, where x is the particular variable, mu is the mean, and sigma is the standard deviation. So standardizing the features so that they are centered around 0 with the standard deviation of 1 is not only important if you are comparing measurements that have different units, but it is also a general requirement for many machine learning algorithms. For instance, consider a shampoo bottle on an online store. Now different websites may describe the weight of this one bottle as, let's say, 20 oz, 20 ounces, 1.25 lb, 567 gms, or 567 grams. So the challenge here is to recognize that all of these are units of weight and they are all the same quantity. So once this is determined, the value can be standardized according to a preset dictionary. So intuitively we can also think of gradient descent as a prominent example of this. Now it is an optimization algorithm used in linear regression, perceptron, and neural networks as well. So in the case of gradient descent, the different scales and weights get updated rapidly. That is, future value stays rolling with the updates, and that is why data is normalized in gradient descent. And other examples are k nearest neighbors and k means clustering algorithms. So these use Euclidean distance measure to standardize the data. And there are also some machine learning algorithms which don't use standardization at all, such as the tree-based classifiers which don't use standardization. So these tree-based algorithms such as decision tree or random forest use scale variant, and hence they don't need the standardization method. And these are the algorithms which require feature scaling or standardization. So k nearest neighbors algorithm needs standardization because it uses the Euclidean distance measure. Now linear regression, logistic regression, and neural networks use the gradient descent optimization method. And as we have already discussed, gradient descent algorithm updates the weight, so that is why it requires standardization. So if it is not standardized, then a few weights will be updated faster and few are not. That is why standardization is important for these algorithms. So another example which you would take would be the dimension reduction algorithm, such as principal component analysis. So principal component analysis uses standardization as the pre-processing step to reduce the number of dimensions so that all the features are on the same scale. Now we'll see what normalization is. So normalization is another rescaling method which we have as an alternative to standardization. And normalization is also called as min-max scaling. Now what happens in standardization is it just scales from 0 to 1. But in normalization, it will have a smaller standard deviation which helps in compressing the effect of outliers if there are any present. So this is the formula for normalization. So we take any particular variable x and subtract it with the minimum variable and then divide it by range. So what we get is a standard variable in the range of 0 to 1. So for example, consider a credit card data set having two variables. Let's say credit cards and income. So now you intend to cluster these records to find similar applicants based on these attributes. Now as you can well imagine, these two will be on different scales, and income being on a much higher scale will influence the distance measure much more than credit cards. And thus normalization is done to avoid this. So another example would be if you're studying the brand effectiveness of some brand and there are several columns which are on the scale like very good, good, average and bad. So in these cases, normalization is performed before doing regression. So now you might be thinking which one is better, normalization or standardization. So let us see. So depending on the application, we can either go for standardization or normalization. So there is no correct way to define whether to go for normalization or standardization. Or we can actually go for both, and based on the results, we can choose the best of those. For example, in clustering analysis, standardization may be especially crucial to compare the similarities within the features based on any feature distance measure. And another prominent example for standardization would be principal component analysis, as we are interested in the components that maximize the variance. Whereas in the case of image processing, for example, the pixel intensity, normalization would be the best choice. So depending on the application, you can choose which is best for you. Now, there is actually a thumb rule that if your data varies a lot, we should choose standardization over normalization. And if you have outliers in the dataset, the normalization would work better when compared to standardization. So we can conclude that both standardization and normalization work best with its features depending on the application. It is actually up to you whether to go for standardization or normalization.
Excel is a powerful tool that can be used for various purposes such as data analysis, financial modeling, and project management. It is widely used in businesses, schools, and even personal life. With its user-friendly interface, Excel allows users to easily input, manipulate, and analyze data. It also offers a wide range of functions and formulas that can help users perform complex calculations quickly and accurately. Talking about the advantages of Excel. One of the biggest advantages of using Excel is its versatility. It can be used for a variety of tasks including budgeting, forecasting, and inventory management. It also allows users to create charts and graphs to visualize data and make informed decisions. Another advantage of Excel is its compatibility with other Microsoft Office programs such as Word and PowerPoint. This makes it easy to transfer data between different documents and presentations. Coming to the disadvantages of Excel. One of the main disadvantages of using Excel is its complexity. While it can be a powerful tool, it requires a certain level of skill and knowledge to use it effectively. This can make it difficult for beginners to get started. Another disadvantage of Excel is its limited capacity. Large datasets can cause the program to slow down or even crash, which can be frustrating for users who need to work with a lot of data. After having a look at the advantages and disadvantages of Excel, now we will have a look at the applications of Excel in a different fields. Excel is a powerful tool for data analysis because it offers a wide range of functions and tools that can help users extract insights from large datasets. Users can sort, filter, and pivot data to find trends and patterns that may not be immediately obvious. In addition, Excel allows users to create custom formulas and macros that can automate repetitive tasks and save time. This can be especially useful for businesses that need to process large amounts of data on a regular basis. Excel is commonly used for financial modeling. Its built-in financial functions and tools make it easy to create complex financial models and projections. Users can create spreadsheets for budgeting, forecasting, and investment analysis. Additionally, Excel allows users to create interactive dashboards and reports that can provide real-time insights into a company's financial performance. This can be especially useful for businesses that need to make quick decisions based on changing market conditions. Excel can also be used for project management. Users can create Gantt charts and timelines to track project progress and deadlines. They can also create task lists and assign responsibilities to team members. In addition, Excel allows users to collaborate on projects in real time. Multiple users can access and edit the same spreadsheet simultaneously, making it easier to work together on a complex project. The Excel start screen will look like this whenever you launch Excel. You can view your recently edited workbooks from here, choose a template and create a new workbook. From the Excel start screen, locate and select a blank workbook to access the Excel interface. First of all, we will be talking about the Quick Access toolbar. The area where you can see the cursor is called as the Quick Access toolbar. This Quick Access toolbar lets you access common commands no matter which tab is selected. You can customize the commands depending on your preference. The area under the Quick Access toolbar is called the ribbon. It contains all of the commands you will need to perform common tasks in Excel. It has multiple tabs, each with several groups of commands. This is the Tell Me box. It works like a search bar to help you quickly find tools or commands you want to use. This rectangle box is the Name box. The Name box displays the location or a name of a selected cell. This is the Formula bar, where you can enter or edit a data, a formula or a function that will appear in a specific cell. The selected area is called a column. A column is a group of cells that runs from the top of the page to the bottom. In Excel, columns are identified by letters. The currently selected area is called a row. A row is a group of cells that runs from the left of the page to the right. In Excel, rows are identified by numbers. Each rectangle in a workbook is called a cell. A cell is the intersection of a row and a column. Simply click to select a cell. Excel files are called workbooks. Each workbook can hold one or more worksheets. To add a worksheet, you can simply click on this plus icon and a new worksheet will be added to your workbook. Click on the tabs to switch between the worksheets or simply right click on it for more options. You can view your worksheets in three views, that is, normal views, page layout view, and page break preview. Simply click on the command to select the desired view. You can use this slider to zoom in and zoom out in your worksheet. The number to the right of the slider reflects the zoom percentage. The scroll bar allows you to scroll up and down or left and right inside your worksheet. To do this, simply click on this vertical or this horizontal scroll bar to scroll within your worksheet. This is the Auto Hide Ribbon option. The Auto Hide Ribbon displays your workbook in a full screen mode and completely hides the ribbon. To show the ribbon, click on the Show the tabs and commands from the list in the Ribbon Displays option. Other than this, we have a Backstage in Excel 2019, which can be accessed by clicking on the File options in the ribbon, where we have Info. The Info pane will appear whenever you access Backstage view. It contains information about the current workbook. New option. From here, you can create a new blank workbook or choose from a large selection of templates. Open option. From here, you can open recent workbooks as well as workbooks saved to your OneDrive or on your computer. Save and Save as option. Use these options to save your workbook to your computer or to your OneDrive. Print option. From the print pane, you can change the print settings and print your workbook. You can also see a preview of your workbook. Share option. From here, you can invite people to view and collaborate on your workbook. You can also share your workbook by emailing it as an attachment. Export option. You can choose to export your workbook in another format, such as PDF, XPS or Excel 1997 to 2003. Publish option. Here, you can publish your workbook to PowerBI, Microsoft's cloud sharing service for Excel workbooks. Close option. Click here to close the current workbook. Now, Account option. From the Account pane, you can access your Microsoft account information, modify your theme and background, and sign out of your account. Options. Here you can change various Excel options, settings, and language preferences. Rows, columns, and cells are essential elements in the world of data management. They are used to organize and display information in a structured manner. Let's understand in brief what are rows, columns, and cells. Rows are the horizontal lines in the spreadsheet. It typically contains related information about a single entity, such as customer or a product. Each row is denoted and identified by a unique numeric value that you will see on the left hand side. Columns are vertical lines of a data in a table or a spreadsheet. They are used to categorize and label information, making it easier to read and understand. Columns are denoted and identified by a unique alphabetical header letter, which is located at the top of the worksheet. One of the key features of Excel is its ability to work with the cells, which are the basic building blocks of any spreadsheet. A cell in Excel is a rectangular box that can contain text, numbers, or formulas. Each cell has a unique address which is determined by its column letter and row number. Now, we will understand how to insert and delete a cell, hiding and unhiding of a cell, inserting and deleting multiple cells, and making use of keyboard shortcuts to perform the same operation. Let's have a look at it one by one. Inserting cells is a special feature in the spreadsheet program that enables users to quickly add a new row or a column to their data without having to manually adjust the entire sheet. Useful for large sets of data. To insert a cell, simply select the row or a column where you want to add the new cell and right-click on it. From the context menu that appears, choose Insert and then select whether you want to add a new row or a column. The new cell will be added to your sheet and you can enter your data as needed. Now coming to how we can delete the cells. Deleting cell is another important function in spreadsheet programs that allows users to remove unwanted rows or columns from their data. This feature is particularly useful when cleaning up data or when you need to organize your sheet. To delete a cell, simply select the row or column that you want to remove and right-click on it. From the context menu that appears, choose Delete and then select whether you want to delete the entire row or column. The selected cells will be removed from your sheet and any remaining cell will automatically adjust to fill the gap. Hiding cells is a useful feature in the spreadsheet programs that allows users to temporarily remove rows or columns from view. This can be helpful when you want to focus on a specific data or when you want to simplify your sheet by hiding unnecessary information. To hide a cell, simply select the row or column that you want to hide and right-click on it. From the context menu that appears, choose Hide. The selected cells will disappear from the view, but they will still be present in your sheet and can be unhidden at any time. Now coming to how we can unhide a cell. Unhiding cell is a simple process in spreadsheet program that allows users to reveal hidden rows or columns. This can be helpful when you need to access information that was previously hidden or when you want to restore your sheet to its original format. To unhide a cell, simply click on the row or column headings surrounding the hidden cells. Right-click on the selected headings and choose Unhide. The hidden cells will reappear in your sheet and you can continue working with the same as needed. Inserting and deleting multiple cells is a powerful feature in spreadsheet programs that allows users to quickly add or remove large sections of data. This can be helpful when working with complex sheets or when making significant changes to your data. To insert or delete multiple cells, simply select the range of cells where you want to make the changes. Right-click on the selection and choose Insert or Delete. You can then choose whether you want to add or remove rows or columns within the selected range. The selected cells will be modified accordingly and any remaining cells will adjust to fill the gap. Keyboard shortcuts are a great way to speed up your workflow in spreadsheet programs. Many functions including inserting, deleting, hiding and unhiding cells can be performed using simple keyboard command. To insert a cell, simply click on Ctrl, Shift and plus sign. To delete a cell, just press Ctrl and minus sign. To hide a cell, press Ctrl plus 9. To unhide a cell, press Ctrl plus Shift plus 9. These keyboard shortcuts can save you time and improve your efficiency when working with spreadsheets. In summary, rows, columns and cells are fundamental elements in the world of data management. They allow us to organize and analyze information in a structured and meaningful way. By following best practices and using these elements effectively, we can create accurate, reliable and easy to understand documents that will help us make informed decisions and achieve our goals. Let's suppose we have the data of the top 5 students of a class and we forgot to add the name of the student who placed third. Now, I want to add the name of that student. So to add the name of the third student, we have to insert a new row. To do the same, right-click on the row above which you want to add and select this insert option from the context menu which appears. Now as you can see, we have successfully inserted our row. Now let's give it a name. Let's say Assis. Now as I mentioned earlier, we have the list of top 5 students, but now we have total of 6 info. So we have to delete the last student's info. To do that, right click on this student info and select delete from this context menu which appears. As you can see, we have successfully deleted our row. Now let's just say you want to hide this name column. To do that, right click on this column and select hide from the menu. And as you can see, we have successfully hide our name column. To unhide the same, right click on it and select unhide. And as you can see, we have successfully unhidden our name column. Now let's just say you want to move this Ujjwal from A3 to D3. To do that, right click on it and select cut option. Now go to C3, right click on it and use this paste option. And as you can see, we have successfully moved our name Ujjwal to C3. Now let's just say you wanted to create a copy of this Ujjwal in D2. Okay. To do that, right click on it and select this copy option from the menu. Now go to D2 and select and right click on it and select this paste option. And as you can see, we have successfully copied our data. Hi folks, in this lecture, we will be seeing what is a quick access toolbar and how we can customize it. The area where you can see the cursor is called the quick access toolbar. The quick access toolbar is a Windows Office feature that contains a set of predefined or commonly used commands that may be used and generated across all environments. The QAT is a fully customizable and allows its users to add or remove a command directly through the toolbar. Let us customize the quick access toolbar. To customize the quick access toolbar, select this customize quick access toolbar and then go to this more commands. You will see a new window will appear which has many commands. To add a new command, click on the command and then click on this add button. And as you can see, we have successfully added our new command. To remove the same, click on the command and then click on this remove button. And as you can see, we have successfully removed our command. You can also customize the quick access toolbar from this file tab. Click on this file tab and then go to this options. Here, a new window will appear where you can see this quick access toolbar. Click on it and you can see the same window which appeared previously. Now, after this, we will be looking at how we can customize the ribbon. First, we will talk about what are ribbons. Microsoft Excel ribbon is the row of tabs and icons at the top of Excel window that allows you to quickly find, understand and use commands for completing a certain task. This part where you can see various tabs is called a ribbon. Let us see how we can customize the ribbon. Go to this file tab and then select this options. You will see a new window that will have this customize ribbon option. Click on it and you can see a new window. You have to add a new group to add a new command. Click on this new group and you can see we have successfully created a new group. To add a command, click on the command and then click on this add button. And you can see we have added a new command. To remove this command, click on the command and then select this remove option. And you can see we have successfully removed our command. Talking about the worksheet views, Excel has a variety of viewing options that change how your workbook is displayed. These views can be useful for various tasks, especially if you are planning to print the spreadsheet. To change worksheet views, locate the commands in the bottom right corner of the Excel window and select Normal View, Page Layout View or Page Break View. Normal View is the default view for all worksheets in Excel. Page Layout View displays how your worksheets will appear when printed. You can also add headers and footers in this view. Page Break View allows you to change the location of page breaks, which is especially helpful when printing a lot of data from Excel. Next up, we will have a look at the window view of Excel. To move more data on the screen, we can temporarily switch to full screen view. Full screen view hides the Microsoft Office Fluent User Interface ribbon, the formula bar and the status bar. To have access to the hidden elements again, you have to return to normal screen view. To switch to full screen view, press Ctrl, Shift and F1. To return to normal screen view, press Ctrl, Shift and F1 again. Next, suppose we want to freeze up some columns and rows. Let's see how we can do that. To keep an area of a worksheet visible while you scroll to another area of the worksheet, go to the View tab, where you can freeze panes to lock specific rows and columns in a place. Or you can split panes to create separate windows of the same worksheet. Let's understand this with the help of a basic example. Let's freeze the first column. To do the same, go to this View tab, select this Freeze Panes option and select Freeze First Column. And you can see we have successfully freezed our first column. To unfreeze the same, go to this Freeze Panes option again and select Unfreeze Panes. Now, let's try to freeze two columns together. Select this third column, go to this Freeze Panes option again and select this Freeze Panes option. And you can see we have successfully freezed our first two columns. To unfreeze the same, go to this Freeze Panes option again and click on this Unfreeze Panes. Now, let's try to freeze the first row and this first column. To do so, select the cell which is below the row and beside the column. And then go to this Freeze Panes option and select Freeze Panes option again. As you can see, we have successfully freezed the first row and first column. Go to this Freeze Panes option again and unfreeze the same. The next thing that we will look into is page margins and orientation. Margins are the empty spaces between the worksheet data and the left, right, top and bottom edges of the printed page. You can manually adjust them to add more or less space around your worksheet data. Before this, we have to make sure that we are in the page layout view. By default, the margins are 0.75 inches at the top and bottom and 0.7 inches at the left and right. Click on the Page Layout tab, and from this margin, which is for the left and right margin, you can extend this. And this margin is for the top and bottom margin. Talking about the page orientation, portrait orientation is the default setting for printing worksheets, but we may want to use landscape orientation instead. Click on the Page Layout tab, select this orientation option and select this portrait option. This portrait option, the paper is taller than it is wide, like a portrait painting. You can also use landscape option. In landscape orientation, the paper is wider than it is tall, like a landscape painting. Lastly, we will deal with headers and footers. You can add headers or footers at the top or bottom of a printed worksheet in Excel. For example, you might create a footer that has page numbers, the date, and the name of your file. You can create your own or use many built-in headers and footers. Headers and footers are displayed only in Page Layout view and Print Preview only. Click on the worksheet where you want to add or change the headers or footers. On the Insert tab, click on this Header and Footer option, and you can see we can write our header as well as our footer also. Let's start by understanding what exactly is a worksheet and also a workbook. A workbook refers to the entire file containing one or more worksheets. A worksheet, on the other hand, is a single tab within a workbook where you can enter and manipulate data, perform calculations, and create charts and graphs. As you can see this sheet 1, to add more sheets, click on this plus icon and you can see we have successfully inserted our 2 new sheets. So the combination of all these 3 sheets is called a workbook. Now, let's understand some basics operations that can be executed within a worksheet, starting from renaming, deletion, and manipulating a sheet. Let's say you want to rename this sheet 1 to demo. To do the same, right-click on it and select this rename option. Then give the name to your sheet and press enter. And you can see we have successfully renamed our sheet. Now, let's just delete this sheet 2. To do the same, right-click on it and select this delete option. And you can see we have deleted our sheet 2. Let's give some random names. Let's say we have provided Anil. And when we press enter, we will be moved to the next row. Now, let's give another name. Let's say that is Raj. To navigate within the row, we have to press up or down arrow. Now, let's just say we are giving the age of Anil as well as Raj. Now, let's say you want to navigate within a column. To do so, press left or right arrow key on your keyboard. Now, let's just say you want to move across the sheets. So, how to do it? Press Ctrl and page up or page down to move within the sheet. As you can see, on this sheet tab, we are moving between the sheets. Now let's see how we can hide and unhide sheets. To hide a sheet, right click on it and select the hide option. And you can see we have hidden our sheet. To unhide the same, right click on it and select unhide option. And you will be asked a permission. Click OK and you can see we have successfully unhidden our demo sheet. Also, now we will see how we can provide a very simple way and the easiest way in which we can protect the sheet, which is just by protecting it as follows. Right click on the sheet, click on this protect sheet and give the password to protect the sheet. Let's say I have given the password and click on this OK button. It will be asking for a reconfirmation. Type your password again and you can see we have successfully protected our sheet. Now if you try to enter any data inside it, you will get an error. Cell or chart you are trying to change is on a protected sheet. To make a change, unprotect the sheet, you might be requested to enter a password. To unprotect the same, right click on it and select unprotect sheet. Now enter the password which you entered previously and click OK. And you can see now we can type the data whatever we want. This is the demo data which I will be using. Let's say I want to merge different cells together. Select the cell range and click on this merge and center option. And you can see you have successfully merged different cells together. To unmerge the same, click on this drop down arrow and select unmerge cells. And you see we have successfully unmerged the cells. You can also change the alignment of the text using this alignment tab where different options are present such as top alignment, bottom alignment and center alignment. You can also change the orientation of your text by clicking on this orientation option and selecting one of the options present inside it. Let's say I chose angle clockwise and you can see it gets successfully applied to my text. Now let's just apply cell style to F10. From this styles tab, select a cell style. Let's say I chose this good one. And you can see I have successfully applied this cell style to F10. Now let's say I want to copy this cell style to G10. To do the same, click on this format painter and click on G10. And you can see you have successfully copied the cell style of F10 to G10. Let's stop the overflow of this schools of vehicle text. To do the same, click on this wrap text option and see the overflow of the sales of vehicles gets wrapped into a single cell. Moving ahead, let's understand cell reference. In Microsoft Excel, a cell reference is the unique identifier of a cell within a worksheet or a workbook. It is used to refer to a specific cell or a range of cells in a formula or a function. Now, let's try to understand how we can reference a set of cells to a particular name. Let's just say I want to give a particular name to this cell range. To do the same, click on this formula tab and go to this define name option and give a name. Let's say I give year 2019 and click OK. Now, when you use a formula, let's say I use equals to sum and inside of it I'll be giving my range name, that is year 2019. And when I will click enter, I will be getting my total of 2000, which is the total of all this, which is the total of this range. Okay. Now we will understand about how we can reference a particular cell. There are two types of cell references in Excel, relative and absolute. A relative cell references changes based on the location of the formula, while an absolute cell reference remains the same no matter where the formula is located. Let's say we have 5 different numbers, let's say 1, 2, 3, 4 and 5. I want the sum of these first 2 numbers, let's say equals to this cell range plus F19, and I will be getting my output as 3, which is the sum of 2 and 1. Now when I will select it and drag it, I will be getting my output as 5, 7 and 9, which is the sum of 3 plus 2, 4 plus 3 and 4 plus 5. This is because of relative referencing. As you can see, in the formula bar, first my cell reference was F18 plus F19. But inside this cell, you can see the formula gets changed to F19 plus F20. That is why I am getting the output as 5. This is what relative referencing is. To make it as absolute referencing, you have to use $sign in front of the row reference and column reference, like this. And when you apply this formula, you can see I get my output as 7, but when I will drag it, only 7 will be displayed. Why? Because my formula will not be changing right now. The data in the above table has date, salary and the name. Now let's see if we want to format the data as per needed. We can do that by changing the format. Let's say I want this date in a long format. To do the same, I'll be selecting the range and clicking on this numbers tab. From here, I'll be using this long format. And see, my date gets translated into this long format. Similarly, for the salary option, it should be in my currency format, right? To do the same, I'll be selecting it and going to this numbers option, and from here, I'll be using this currency option. And as you can see, it gets converted into currency. Similarly, for name, I'll be using text. So I will select this range. I'll be selecting this range and going to this numbers option, and from here I'll be using this text option.
Let's have a quick quiz question, guys. And the question is, what is worksheet in the context of spreadsheet application? Option A, a printed copy of a spreadsheet. Option B, a single page of a spreadsheet that contains rows and columns. Option C, a password used to protect a spreadsheet. And option D, a complex mathematical formula. Please do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
In Microsoft Excel, a list is a range of cells that contains related data organized in rows and columns. Lists are commonly used for sorting, storing and manipulating large amounts of data such as customer information, inventory data or financial transactions. Ensure that the first row of your data contains column headers. Now, let's understand how sorting is done in a list. Sorting a list in Excel means arranging the data in ascending or descending order based on a specific column or multiple columns. This is a useful feature for organizing data, making it easier to analyze and draw insights from it. Let's say you want to sort this 8th column in ascending order. To do the same, select the range and from this Home tab, select this Sort and Filter. There are two options. First is Sort smallest to largest, which will sort your data in ascending order, and the second is Sort largest to smallest, which will sort your data in descending order. So I want to sort my data in ascending order, so I'll be clicking on Sort smallest to largest. From here, click on this Sort button. And as you can see, I have successfully sorted my data in ascending order, which is 27, 27, 28, 29 and so on. Sorting a list in Excel can help you identify trends, patterns and outliers in data more easily and can make it easier to perform calculations and generate reports based on the sorted data. Let's talk about different types of sorting. There are several types of sort available in Excel. Mainly, we will be speaking of single level, multi-level and custom level. Single column sort. This is the most basic type of sort where you can sort data based on the single column in ascending or descending order. The sorting which I just showed you now is called the single level sorting. Next, we will talk about multi-column sort. This allows you to sort data based on multiple columns. Excel sorts the data based on the first column you select and then by the second column and so on. For example, Let me show you the steps how to do it. Select the table, select the data, and from the home tab, select this sort and filter. From here, select this custom sort, and here you can see I am sorting my age column from smallest to largest. I'll be adding a level, and here I'll be specifying the next column which I want to sort. Let's say I want to sort this name and in descending order. Let's change it to ascending order. From when I will click OK, you can see I have successfully sorted my data in ascending order based on the age and then based on the name column. This is what multi-sorting is. Let's say you want to sort this data using a custom sorting where you provide your own list. To do the same, select the data, then from here select sort and filter option and then select custom sort. From here, let's say I want to sort my gender column. Let me delete it first. From here, I want to sort my gender column and based on my custom list. Here, I have already provided this custom list. Let's say it is male and female. I will click OK and you can see in order format, I am getting male and female. When I will click OK, it will give me the table in this format where I'll be seeing the males first and then female. Let's say my order becomes female and male. Let me show you. Let's say my order becomes female and male. So what will happen? I will get my data in this format such as I will be getting the females first and then I will get the male. So the order of your list decides in which order your table is going to be sorted. Finally, let us convert this list as a table. Formatting a list as a table in Excel can make it easier to work with and can also make it more visually appealing. Here are the steps to format the list as a table in Excel. Select this data and from this Insert tab, select this table. Here, a pop-up window will appear where the cell range is given and this My Table Has headers is given. You have always make sure that your table contains a header. Click on this tick button and then click OK. And as you can see, you have successfully created a table out of your data. Once you have formatted your data range as a table, Excel will automatically add a row of filter buttons at the top of the table, which you can see here. And from here, you can select the sorting option, or if you want to filter your data, you can also do the same. You can also use the Design tab of the ribbon menu to make additional changes to the table style, such as changing the font, colors or borders. As you can see, there are various options from here which you can select. Let's say I want to change the style of my table, so I can do the same from here. And as you can see, the style of my table is getting changed. Formatting a list as a table in Excel has several advantages, like it improves our readability of the data. It makes it easy to sort or filter the data. It automatically formats the table. And if you apply a single formula to a single column or single row, it automatically gets applied to the whole table. And it also makes your table a dynamic range. Overall, formatting a list as a table in Excel can save you time and effort, and it can make it easier to work with, analyze your data. Let's use the data to create a table. To do the same, go to this Insert tab and select this table option. You have always made sure that your table contains a header. Click on this and click OK. And as you can see, you have successfully created a table out of your data. The Format as a Table feature in Excel can be used to easily apply table formatting and functionality to a range of data in your worksheet. Some of the main uses and benefits of formatting a table in Excel are: improved data organization. By formatting your data as a table, you can make it easier to read and understand. The table formatting provides clear boundaries around your data, and the alternating row colors can make it easier to distinguish individual rows. As you can see in the table, various alternate columns are having same color. This is what improved data organization means. Automatic filtering. When you format your data as a table, Excel automatically adds filtering buttons to the column headers. This allows you to quickly filter and sort your data by different criteria without having to manually set up filters. Here you can see this drop down arrow. With the help of it, you can provide different sorting and filtering values. Dynamic ranges. As we demonstrated earlier, when you add new data to your table, Excel automatically expands the table range to include the new data. This makes it easy to keep your table up to date without having to manually adjust the range. Let's just say I type in total here, and when I will click enter, you can see it automatically gets included inside the table. Table styles. Excel includes a variety of pre-designed table styles that you can apply to your data. These styles can be helpful to make your data more visually appearing and professional looking, and you can customize the styles to match your preferences. For this, select this tab to Table Design, and from here you can choose various table styles. As you can see, my table is getting changed, right? Let's say calculated columns are another feature of this table. Where you can format your data as a table, you can easily add calculated columns to your table. Calculated columns allow you to perform calculation on your data, such as adding or multiplying values, and the result will automatically updated as you change your data. Let's say I give here a formula that my sum of this age plus this G10 will be 57, and as you can see, I need not to write the formula for the same or drag the formula for the same. It automatically gets applied for whole table. Overall, formatting your data as a table in Excel can help you save time and improve the readability and functionality of your data. Database functions in Excel are a group of functions that are designed to work with data organized in a database like tables. These functions are often used to analyze, summarize, and manipulate large amounts of data in Excel. The most commonly used database functions in Excel includes dsum, dcount, daverage, dmax, dvar, dvarp, and many more. Let's try to understand a few of them. First, this is the dataset which I'll be using. Let's see what this dsum function does. In Excel, the dsum is a database function that stands for database sum. It is used to calculate the sum of values in a particular field or column of a database based on specified criteria. The dsum function takes three arguments, that is, the database range, the field to be summed, and the criteria range. The criteria range specifies the condition that must be met in order for the function to include a record in its calculation. Suppose you have the table of the employees in a company and you want to find out the total salary of all male employees who are over the age of 30. To perform the same, let's first specify the criteria, that is, the gender should be male and the age should be greater than 30. So I have specified the criteria. Now I will write the function. So the function is dsum, and I will give my database range, that is A1 to F11. Now I want this salary to be summed, so I will give that range, and then I will specify my criteria range. And when I will press enter, you can see I got my output as 2,10,000. So this will be the total of all the male employees whose age is greater than 30. Let's say I also want to include this male employee whose age is 25. To do the same, follow the same steps, write the function name, and inside of it specify the database range, then the field to be summed, and the criteria which you want. And now when I will press enter, you can see I got my output as 2,60,000. So this is how you can perform the dsum function. Let's talk about the dcount. The dcount is an Excel database function that is used to count the number of records that meet specific criteria in a database or a table. It can be used to count the number of records that satisfy a certain condition, such as the number of employees who are over a certain age or the number of employees who live in a particular city. Suppose in this data set, we need to find the total number of employees that are having salary less than 60,000. So first we have to specify the criteria, that is, salary must be less than 60,000. Now we will apply the function, that is dcount, and inside of it we will provide the database range, And now we will provide the column to be counted, that is my salary column, and I will specify my criteria, that is salary should be less than 60,000. And when I will press enter, you can see I got this output as 5. We can also verify the same from this database. You can see this is my first employee, second employee, third employee, fourth employee and fifth employee. So there are total of 5 employees whose salary is less than 65,000, which we got as an output from this dcount function. Let's talk about this daverage function. The daverage is a database function in Excel that calculates the average of selected database entries that meet specified criteria. An example for the same can be, let's say we want to find the average salary of a male employee in the data set, where we will be specifying the criteria, that is, let's say my gender should be male, and I will apply the formula or the function, that is daverage, and inside of it I will provide my criteria database range, and then I will provide that I need the salary average, and then I will provide my criteria, that is all the males. Now when I will press enter, I will get 60,000 as an output, which is the average salary of all the males present in this database. Performing operations to calculate and transform data, like using average function, max, min, sum, count, count A, count blank, and performing conditional operations by performing if functions. Next, we will look into some functions that are used for formatting and modifying text like right, left, mid, upper, lower, len, concat, and text join functions. So let's get started with the video. Formulas are equations that can perform calculations, return information, manipulate the contents of other cells, test condition, and more. The structure of a function begins with an equals to sign, followed by the function name, an opening parenthesis, the arguments for the function separated by commas, and a closing parenthesis. As you can see, this is the structure of my function. It begins with an equals to sign, then we have to provide a function name, an opening parenthesis, inside of which we will give our arguments, which can be a single or a multiple argument, and then a closing bracket, closing parenthesis. Arguments can be number, text, logical values such as true or false, arrays, error values such as #NA or cell references. The argument you designate must produce a valid value for the argument. Arguments can also be constant, formulas, or other functions. A tooltip with the syntax and argument appears whenever you type a function. For example, if you will type equals to average, a tooltip will appear with the syntax and the arguments inside of it. Tooltips only appears for the inbuilt functions. So I have prepared various questions for the practice of these functions, and in the right of the screen you can see there are various functions which are mentioned, that includes sum, average, count blank, left, right, etc. So let's get started with our first question. That is, find out the total marks received by the student using the sum function. So we need to apply the sum function, that will be equals to sum, and then we have to provide the table range which includes the scores scored in all the 5 subjects. Then we will press enter, and you can see we got our total output as 368, which is the total of all the 5 subjects scored by Avinash. Let's drag and drop the same, and you will see it will automatically fill the rest of the part. Our second question is, find out the percentage of marks obtained assuming all marks are out of 100. So to calculate the percentage, the formula is the marks which is obtained, that is 368, divided by 500 and multiplied by 100, and it will give me the percentage for Avinash. And as you can see, it is giving the percentage as 73.6. So let's drag and drop the same, and it will automatically fill the data for other students. Our next question is, find out the average marks obtained by the students in each subject using average function. So we have to use the average function to calculate the average of each subject scored by every student. So for that, let's write our function that will be average, and we will provide our data range that will be from D42 to D51, and we will press enter, and you can see the average score for English subject is 78.1. Let's drag and drop, and you will see it will automatically adjust for the rest of the subject. Our next question is, find out the maximum marks obtained by the students in each subject using max function. So we have to find the maximum scored in each subject. So for that, we will use this max function, and we will provide a data range for this and press enter. You will see 92 is the greatest marks out in this English subject. Drag and drop the same, and we will find all the maximum marks scored in every subject. Our next question is, find out the minimum marks obtained by students in each subject using min function. So for this, we will apply our min function, and the data range will be the same as the English subject, and we will press enter, and you can see 61 is the minimum marks scored. Drag and drop, and you will see it will automatically fill the data. Our next question is, using if function, find out who has obtained more marks between Anish and Shivani. So it is asking us for a comparison, right? So we will be using this if function, where we will check if Anish marks is greater than Shivani's marks. If it is greater, my output will be Anish, and if it is not, my output will be Shivani. And when I will press enter, you can see I am getting Shivani as an output. Our next question is, using nested if function, calculate the final grade of each student based on the following criteria, that is greater than or equals to 90, then A plus grade, greater between 75 to 89, then A, between 60 to 75, then B, between 50 to 60, it will be C, and if it is less than 50, then it will be D. So let's type the function that will be equals to if my average of English, Science and Maths is greater than equals to 90, then print me A plus. Otherwise, if the average of this is greater than 75, then print me A. And my next criteria is, if the average of this D42 to F42 is greater than 60, then print me B. Next criteria is, if the average is greater than 50, then print me C. Otherwise, print me D. And when I will press enter, you can see it is giving me B as an output. So let's check it out. The average of these three subjects is 74.33, which falls under the second criteria, that is between 60 and 75. So our grade is B. Our next question is, using if function, calculate the performance of the class in each subject based on the following criteria, that is, if the average marks in the subject is greater than equals to 90, A plus grade. If it is between 75 to 89, A, 60 to 75, then B, 50 to 60, then C, or if it is less than 50, then D. So let's write the function, that is, if my average is greater than or equals to 90, then print me A plus grade. Otherwise, if my average is greater than 75, then print A. Otherwise, if my average is greater than 60, print me B. Otherwise, if it is greater than 50, then print me C. Otherwise, if the average is less than 50, then print D. And when I will press enter, you can see it is giving me A because 78.1 lies between 75 and 89 and the grade for that is A. We will perform new functions, that is count, count A and count blank to count these values which are present here. So if we have to count how many cells in a range contain numeric data, we will write equals to count and we will provide our data range, and when we will press enter, you can see I am getting 5 as an output because there are only 5 cells where my numerical value is present. Next we have to count how many populated cells in a range. Means the cells which are not blank, I have to count that cells. So for that, I will be using this count A and then I will provide my data range and I will press enter, and you can see it is giving me 8 as an output because my 2 of the cells are empty. So to count the empty cells, we will be writing count blank and we will provide the data range, and you will see it will give me 2 as an output because 2 of the cells are empty. Next we will see how we can manipulate text. So for that, I have prepared some questions, that is extract the first name of each employee to the first name column using the left function from this table which is given below. So I want this Avinash to be printed here. So for that, we can use this left function. Then you can see it is asking me for the text, that will be Avinash Singh, and then it is asking for the number of characters. So Avinash is of 7 letters, so I will write 7. And you can see Avinash has been given as an output. But the problem with this function is that each and every time I have to count the letters that I want to print. So for that, we can use a different function. Let's say I am using left, then the name, and then we will be using this find function which will find the empty space between the total name, that is between Avinash and Singh, and it will subtract, we will subtract -1 from it to get our output as Avinash. It is a simple mathematics. We just removed this space and we just printed only Avinash. This time if I will drag and drop, you will see it is giving me the output as Sudeep, Samir, Anish and Diya. Our next question is extract the last name of each employee to last name using the right function. So similarly, we just have to print the last name. So for that, we will use just simple maths and we will write equals to right and the name column. Then we will calculate the total length of our name and we will just subtract our space. We will just subtract our space from this and we will press enter, and as you can see it is giving me Singh as an output. We just did simple mathematics, means we just subtracted our find, the value after the space and from the total length, and we got Singh as an output. I will drag and drop the same and you can see it is giving me the last name for all the persons which are present. Our next question is extract the domain name from each employee's email to email domain using the mid function. So we have to use the mid function to get this domain of this Gmail. So for that, we will be using this mid function and we will provide our text, that is email, and we will write another function, that is search, which will help me to find this @ symbol, and after that I will be adding +1 to it so that I will be getting my output from after this @ symbol, and the total number of characters will be 255. And when I will press enter, you can see gmail.com has been given as an output. I will drag and drop the same for the rest of the column. Our next question is, convert all emails to lowercase and put it into formatted emails columns using the lower function. So we have to convert all these letters in a lowercase. So for that, we will be using this lower function, and the text, that will be my email, and then enter, and you can see it has been successfully converted into a lowercase. Then I will drag and drop the same, and it will be applied to the table. Next, determine the length of each employee's name to length of name using the length function. So we have to determine the length of the name. So for that, we will be using length function, and then the text, that is my name, and enter. You can see it is giving 13 as an output. We will drag and drop the same to fill the table. Our next question is, combine the area code of and phone of each employee into column phone number using the concat function. Now, we have to combine this 91 and this phone number together. So for that, we will write concat and text1, that is my country code, and text2, that is my phone number, and press enter, and you can see I have successfully combined my country code with the phone number. I will drag and drop the same, and it will be applied to the table. Our next question is, convert all employee ID to uppercase and put it into employee ID column using the upper function. So we have to use this upper function for this employee ID to be converted into uppercase. So I will write the function, that is upper, and then the text, and enter, and you can see it has been converted into a capital letter. I will drag and drop the same to apply it for the whole table. Our last question is, join all the phone numbers separated by colon into all email IDs for bulk assignment using text join function. So for this to be applied, I will write text join, and you can see it is asking for a delimiter, which will be my colon, and then we have to ignore if the cells are empty. If you will set to true, it will ignore the empty cells. So it will be true, and the text, that is my email, and enter. And you can see, okay, I made a mistake. We have to provide the data range, that will be from D91 to F100, and press enter, and you can see all the emails have been linked together for the bulk assignment. The problem statement given to us is that you are a financial analyst working in a bank that offers various investment products to its customers. Your manager has asked you to analyze the investment data of the bank and identify the investment products that have performed well in terms of returns. You have been given a data set that contains information about the returns of different investment products over a period of time. So this is the data set which we have been given, and according to which we have to solve these questions which are present. The first question is that we have to assign a risk category, high for equity shares, medium for bonds, and low for mutual funds to each investment product based on their investment types. And you can also see that it is saying that we have to use this switch function. So this switch function will help us to switch the risk category for this different investment types. So let's write our function, that is equals to switch our expression, that will be our investment type, because we have to find different investment type. Our first value, that is equity shares, and for that the risk category is high. Similarly for bonds, the risk category is medium, and for mutual funds it is low. And you can see it is giving low as an output because the investment type is mutual funds. Let's drag and drop and fill this entire table. And you can see the risk category has been filled. Let's move to our next question. That is, calculate the total investment amount for all investments in bond using the SUMIF function. So we are using this SUMIF function because we are given a condition that my investment type should be bonds only. So we will write our function, that is SUMIF, because we have to give certain conditions. The range for our criteria, it will be our investment type, where the investment is done in bonds, and the range should be the investment amount. It should be comma, press enter, and you can see it is giving 12,50,000 as an output. We can double check it. As you can see, there are only two data entries that belongs to bond investment type, and the investment amount is 5 lakh and 7 lakh 50,000, which makes a total of 12 lakh 50,000. That is what we are getting as an output. Let's move to our next question, that is, calculate the average returns generated by investments that have a duration of 5 years or more using the average if function. So we have to use average if function and calculate the average of this returns amount where my duration is 5 years. So let's write our function. It will be average if the range for my criteria, that is investment duration. The duration should be equals to 5, and make sure you are putting this in double quotes or it will give you an error. And the average range, which will be our returns, and enter. And you can see it is giving 5520 as an output. Let's move to our next question, that is, count the number of investments with the investment in amount greater than 15,000 using the COUNTIF function. So we have to use the COUNTIF function to count the number of investment where the investment amount is greater than 15,000. So let's write our function, that is count if the range, that will be our investment amount, where the investment amount is greater than 15,000, and you can see it is giving 8 as an output. Means there are total 8 data entries where my investment amount is greater than 15,000. Let's move to our next question, that is, calculate the total investment amount for all investment in mutual funds with a duration of 5 years or more using the SUMIFs function. So this time we will be using this SUMIFs function because there are multiple conditions which we have to keep in mind. So let's write our function, that is SUMIFs. Our first we have to give the sum range, that will be our investment amount. And as you can see, now it is asking for criteria range 1. So our first criteria will be that my investment type should be mutual funds. Our next criteria will be that the amount should be, the duration should be 5 years or more. So it will be either greater than or equals to 5. And press enter. And you can see it is giving 1,05,000 as an output. Moving to our next question, it states that calculate the average returns generated by all fixed deposit investment with an investment amount greater than 75,000 and a duration of 2 years or less using the average if function. So let's write our function, average ifs, because we have to write multiple condition. The average range, our first criteria, that is the investment type should be equity shares. Let me fix it. It should be equity shares. Our next criteria is the investment amount should be greater than 15,000. It means greater than 15,000. And our third criteria is the investment duration should be 2 or less than 2. Means less than or equals to 2. Press enter and you can see it is giving 2040 as an output. Our next question is, count the number of bond investments with a duration of 10 years or more and returns greater than 20,000. So our two conditions are that the investment type should be bonds and the duration should be 10 years or more and the return should be greater than 10,000. So let's write it. We have to count, so we will be using count ifs because multiple conditions are there. Our first criteria range is the investment type should be bonds. Our second criteria is the investment duration should be greater than or equals to 10. Our third criteria is, there is a problem, it should be 34. The third criteria is the return should be greater than 10,000. Let's run it and you can see it is giving 2 as a count, and you can also verify it from the data. There are only 2 data entries in this bond investment type. Duration is 10 and the amount is greater than 10,000. Moving to our next question, it is asking that find the minimum investment amount for all equity share investments with a duration of 2 years or less using the minifs function. Okay, so here we have to find the maximum, so it should be max ifs. We will provide our maximum range, that will be our returns. Okay, let's rewrite it. The maximum range should be returns, where my first criteria is that the investment type should be bonds. Our next criteria is that the duration should be or equals to 10, greater than equals to 10, and enter. And you can see it is giving 90,000 because the maximum amount invested in bonds is 90,000. So our next question is find the minimum investment amount for all equity share investment with a duration of 2 years or less using the minifs function. So we have to find the minimum invested amount in equity shares. For that, we will write minifs, where our minimum range should be this investment amount. Our first criteria is the investment type should be equity shares, and our second criteria is the duration should be 2 years or less. So less than equals to 2. Enter, and you can see it is giving 10,000, and you can also see from this table that the minimum amount in this investment type of equity shares is 10,000. Moving to our next question, the question states that check whether Microsoft has duration greater than or equals to 2 years and returns greater than 2,000. So let's write our function. Equals to, we have to find two conditions, means I want my output to be true or false, a boolean value, where I am given that my duration should be greater than or equals to 2, and the second logic will be that the return should be greater than 2,000. Let's press enter, and you can see it is giving true because my both the conditions follow. That is why I am getting true as an output. Even if a single condition does not follow the statement, I will be getting false as an output. Moving to, let's talk about our date and time functions using the problem statement which is given. The problem statement is that a company wants to track the attendance and working hour of its employees. The HR department wants to create a spreadsheet to track attendance and calculate the total number of working hours each employee has completed in a given month. And the questions are as follows. The first question is, how many working days did John and Alice work in January 2022? So we have to find that how many days until now Alice and John have worked. So for that, we will be doing a count. So we will write count ifs because we have to find the count and there are conditions. So for that conditions, first we will check whether the employee ID of Alice is present or not. So that will be 2726. Our second criteria will be date of hiring, which should be greater than or equals to 01/01/2022. That is my 1st January 2022. my next criteria will be my date of hiring will be less than or equals to 31st Jan 2022 and enter, and you can see it is giving 12 as an output. Similarly, let's calculate it for John. It will be count ifs, where my first criteria should be checking that if John's employee ID is present or not. That will be 2741. Date of hiring, similarly it should be from greater than equals to 1 1st Jan, that will be 2022, and second it should be less than equals to 31st Jan 2022. Press enter and you can see it is giving 8 as an output. Means John has worked 8 days and Alice has worked 12 days. Let's move to our next question, that is, what is the current date and time using the now function? So we have to calculate the current date and time, means today's date and time which is currently going on, using our Excel function, that will be equals to now, and press enter and you will see it is saying that today is 09/06/2023 and the time is 3:58 or 15:58. Through this function you can calculate today's date and time, which will be automatically renewed after every time. Moving to our next question, the question is, what is the current date using the today's function? So we have to find today's date using our today function which is present in Excel. So we will write equals to today and enter, and you can see it is saying 9th June 2023. Moving to our next question, what is the day of the week for January 1st 2022 using the weekday function? So we have to find that which day is on January 1st. So for that we will write our function, that is weekday and our month name first, then the date with the year followed, and press enter and you can see it is saying 7. It means that on my 1st January 2022 I was having Saturday as a day. Moving to our next question, what is the last working day of January 22 for John and Alice? So we have to find what will be the last working day. So for that we will write this function, that is end of month function, and the start date for this Alice will be 2nd Jan, and okay, so for there are three conditions for this month. If I will write 0, so it will give me the end date of this month, of this current month. If I will write 1, it will give me the end date of our next month, and if I will write -1, it will give me the end date of our previous month. So I will be writing 0 because I want the end date of our current month, and enter, and you can see it is giving 31st January 2022. Similarly, let's write it for John. It will be end of month, the date, that is 3rd Jan, and the range, that is 0, and enter, and you can see it is same for John also. Moving to our next question, the next question is, what are the total working days in the month of January? So for this we will be writing our function, that is network day, which gives, the function will be network day, which gives the total working date between two dates. So our starting date will be 2nd Jan and the ending date will be 31st. Now press enter and you can see it is giving 21 as an output. It means there are total 21 days, 21 working days between my two dates. Our next question is, find out the remaining working days in the month of January. So for that we will be just subtracting, let me fix this question, remaining working days for the month of January. Yeah, it is correct. We will write our function that will be, means Alice has already worked for 12 days. So the remaining working days for her will be 21 minus 12. So let's write it equals to this minus this. And you can see only 9 remaining working days are for Alice. Similarly, you can also calculate it for John. So it will be 13. Means John has to work 13 days more. In Microsoft Excel, errors can occur when there is a problem with a formula, a reference, or data within a cell. These errors indicate that the calculation or operation in the cell cannot be performed correctly. Let's see the different kinds of error one by one. You can see I have different kinds of data sets for different kinds of error. In this first data set, you can see we are trying to demonstrate that we have set of numbers of different students in different subjects, and we are getting this division 0 error when we are trying to find the percentage from the total. So this zero division error occurs when you divide a number by 0 or an empty cell. Excel cannot perform division by 0, so it displays this error. The next error which you can see is this name error. So what causes this name error? This error occurs when Excel does not recognize a name used in a formula or a function. It could be misspelled formula name, misspelled name range, incorrect range, opening new version formulas in older version, or missing quotation around text in the formula. Moving to our next errors, that is reference error. In this example, we have this data set of 3 different subjects and the marks obtained by various students in these 3 subjects, where we are getting this reference error. This error occurs when a cell reference is not valid. It typically happens when you delete a cell or change the location of a reference cell in a worksheet, or when it can't find the value in the reference range. The next error which you see is #NA error. This error stands for not available and occurs when a value is not found or cannot be retrieved. It can happen when using lookup functions like VLOOKUP or HLOOKUP, and the search criteria is not found. Moving to our next error, that is null error. In this example, you can see we have 2 columns containing number, and we need to sum all the ranges together, and this null value occurs. So what causes this null error? This error occurs when you specify an intersection of 2 ranges that do not intersect, or when you use a space instead of a comma to separate function arguments. In this next example, you can see this #num error when we are trying to find the square root of a number. So this error occurs when we have an invalid numeric value in the formula. For example, taking the square root of a negative number or providing an incorrect argument to mathematical function can lead to this error. Moving to our next error, that is #value error. This error occurs when you use an invalid data type or an incorrect argument in formula. For example, using text instead of numbers in a mathematical calculation can result in this error. Our next error is, as you can see in this question, that it is now showing #####. So this is also, you can consider, a type of error. This error is displayed when the column width in Excel is not enough to show the stored value in the cell. As you can see, I have mentioned date here, and I have also written the date, which you can see. But I am not being shown the date. Instead, I am being shown this #####. Why? Because the width of this column is not appropriate to fit the entire date. So for that, just double click on it and you can see now that the date has been given. Our next error is this circular reference error. What causes this error? This error comes when we reference the same cell in which we are writing the function or formula. Whenever we create this type of circular reference in Excel, Excel alerts us about the same too. So next we will be moving that how we can troubleshoot our formulas. Checking formulas for accuracy or finding the source of an error may be difficult if formula uses precedent and dependent cells. Now you must be thinking what this precedent and dependent cells means. So let's first understand what these precedent cells and dependent cells mean. Precedent cells are cells that are referred to by a formula in another cell. For example, if cell D10 contains the formula equals to B5, then cell B5 is precedent to cell D10. Dependent cells are cells that contain the formulas that refer to other cells. For example, if cell D10 contains the formula equals to B5, cell D10 is dependent on cell B5. To assist us in checking our formulas, we can use the trace precedent and trace dependent commands to graphically display and trace the relationship between these cells and formulas with tracer arrows. We will see how we can add this trace precedents or trace dependents and check our formula. So for that, first we have to make sure that go to this files option, then this options. From this window, select this advanced option and scroll down, and for this option, display options for this workbook, make sure this all option has been put a tick. Then click OK, and now we are ready to insert a trace precedent or trace dependent. First, let's see how we can insert a trace precedent. So for that, select the cell where we have applied our formula. Then from this formulas tab, select this trace precedent value. Click on it and you can see it is showing the two precedent values which are used inside this final cell range. If you click on it again, you will be seeing another precedent values which are used to get these two values. To remove these arrows, we will simply click on this remove arrows and the arrows will be removed. These blue arrows show cells with no errors. Red arrow cells shows that the causes of error. If the selected cell is referenced by a cell on another worksheet or workbook, a black arrow points from the selected cell to a worksheet icon. The other workbook must be open before Excel can trace these dependencies. So let's now remove these arrows. So for that, click on this remove arrows and you can see the arrows has been removed. To check for a trace dependence, we will select the values which we are using in the formula. So let's select this value and select this trace dependent. Click on it and you can see it is showing that this final cell is using this previous cell as a dependent value. We can just remove this arrow if we want from this remove arrows option. When cells are not visible on a worksheet, you can watch those cells and their formulas in the watch window toolbar. The watch window makes it convenient to inspect, audit, or confirm formula calculations and results in large worksheets. By using the watch window, you don't need to repeatedly scroll or go to different parts of your worksheet. This toolbar can be moved or docked like any other toolbars. For example, you can dock it on the bottom of the window. The toolbar keeps track of the following properties of a cell, that is, workbook, sheet, name, cell, value and formula. So let's try to add a watch window for it. So for that, select the data range and from this formulas tab, you can see this watch window button. Click on it and you can see I have selected all my formulas which are present. And even if I am not on this present on this sheet, I will be able to see all the formulas with their sheet name, their cell reference and their values. I can even move it from here to here or anywhere I want in the screen. I can even resize it if I want. As you can see, it is being resized and you can also see the different formulas which are being used inside this cell. Moving to our next option, we will see how we can evaluate our formula by using this evaluate formula option which is present inside is Excel. So for that, we will be selecting our formula where a cell where we have applied our formula. Let's say I have this cell here. Now we will click on in this formulas tab, we will click on this evaluate formula button. Click on it and you can see one underline is being showed. It means it will evaluate this part. When I will click on this evaluate, it will evaluate and you can see it is giving me the value. And if I'll click again, you can see it is giving me this value, means the steps which are being performed on it, and then click evaluate again and you can see it is giving me the same output which I got inside this percentage. So this is how you can evaluate your formulas which you write inside this function, Excel window. Formatting and validating data in Excel are essential tools to ensure data accuracy and consistency. With data formatting and validation, we can ensure that our data is accurate, consistent, making it easier to analyze and draw meaningful insights. As you can see, formatting refers to changing the appearance of cell, ranges, charts and other elements in a worksheet to make them more visually appealing and easy to read. Formatting can involve changing the font size, font color, cell background color, alignment, number format and the other attributes of the data. Validation means it is a feature in Excel that helps ensure the data entered in a cell meets specific criteria. It is used to control what a user can enter into a cell to minimize errors and maintain consistency in the data. Let's take this data. The below data contains a list of sample employees with date with ID, name, age, gender, city, salary and date of joining. Let's just go to this header and make it a bold text. To do the same, from this font menu, select this B, or you can also press Ctrl+B to make it a bold text. And as you can see, the text which is inside this header has been made into a bold text. Now, let's just increase the font size of this text. To do the same, from this column, you can increase the text size. Let's say I chose 14. And as you can see, the text size of my text has been increased to 14. Now, let's just say I want to make this table to the center of each column. To do the same, I'll be selecting this center alignment and as you can see, my text has been centralized. Now, let's check how we can specify the column type or the data type for each column. Let's say the name should always be in text format, right? To do the same, let's go to this general and from here, let's select text, which is a name. As you can see, it is written here. Click on it and it will give you a text option. Now, the age should always be in number, right? You cannot have the age in text or any other format. To do the same, let's select the range and from this general option, select it as a number. As you can see, your age has been given. Now, same for the gender, you must apply it a text as it is a text. Now, for the city, it is the same. You will be doing this. And for the salary, it must be in the currency format, right? Select the same and click on this general and instead of the general, use this currency format. And as you can see, it becomes my currency. And as you can see, it is already in the date format, so no need to change this. Let's just change the color of the alphabets in the given table. Let's say I want to change this text color to, let's say, yellow, or let's take it green. As you can see, I have successfully changed my text color. Let's say you want to apply a certain background to the cell. From here, you can select any color to fill inside the cell. Let's say you can see this better. And as you can see, I have successfully filled all my cells with a particular color. Now, let's just say I apply a cell style to this B25. Let's say I applied a new cell style, that is this one. And as you can see, it has been applied to this B25. Now, let's just say I want to copy this format to this gender type. To do the same, select this cell and from this home option, select this format painter. Click on it and click the cell which you want to apply the same. I want it to apply to the male, so I'll be clicking on it. And as you can see, you have successfully applied the same to the male column. Let's take one more example. I want to copy this cell style to this Boston. To do the same, select this and go to this format painter. Click on it and select this Boston. And as you can see, I have successfully applied the same to my Boston. And finally, we will be seeing how we can insert our spark lines. So talking about conditional formatting in Excel is a tool that allows you to format cells based on a certain conditions. This means that you can automatically highlight cells that meet specific criteria, such as cells that contain a certain value or fall within a certain range of values. This can make it easier to quickly identify important data in your spreadsheet and make your data easier to read and analyze. So let's see what this conditional formatting is with a demonstration. So let's say inside this salary column, I want to filter out all those salaries which are greater than 70,000. To do the same, from this home tab, I'll be selecting this conditional formatting option, then highlight cell rules and then greater than rule. Here, I'll specify my criteria, that is 70,000, and let's give it a light red fill with dark red text. Click OK, and as you can see, two of my fields have been marked with red. So this is the criteria, or this is the salary range which I have filtered out, which is greater than 70,000. Now let's apply another conditional formatting. For that, click on this conditional formatting, then select highlight cell rules, and this time let's select less than. Here let's say I give 50,000. So all that cell ranges which are less than 50,000 will be marked with yellow color. And as you can see, two of my cells have been marked with yellow color. Now let's apply it once again. Go to this conditional formatting, highlight cell rules, and this time I want my salary to be between 65,000 to 75 or 70,000. Let's give it a green color. Click OK, and as you can see, you have successfully applied the same. Now you can also use this conditional formatting to give your own certain rules. So let's say I want all this mail to be in a bold and italic text. To do the same, click on this conditional formatting, go to this new rule, and here you can see various options are present. Select this format only cells that contain, and from here select specific text. As I want only mail to be begin. From here select beginning with, and then type in your condition. Click on this format button, select the text which you want. So I want my text to be bold and italic. Click OK, and then click OK. As you can see, all the employees whose gender is male are written in bold and italic text. So this was all about the conditional formatting. Let's understand about the spark lines. Spark lines are small, simple charts that commonly used to show the trends and variation in the data. They are miniature charts that are typically placed inside a cell, allowing you to easily see patterns and trends in your data without having to create a full chart. There are several types of spark lines, including line, column, win-loss spark lines, and you can customize the color, style, and the other properties of the spark line to suit your needs. Let's see how we can insert a spark line. To insert a spark line, select the column. Let's say I'm talking about the salary. Go to this insert option, and from here you can see this spark line tab. Select one of it. Let's say I selected line. So my data range is G16 to G27. That is my salary range. And here I have to provide a location range. That will be my J22. Click OK, and as you can see, you have successfully inserted a spark line. Let's do the same for the age column. Select the age column, go to this insert tab and select one of this. Let's
have a quick quiz question, guys, and the question is, which of the following represents the typical stages of business intelligence in the correct order? Option A, analysis, reporting, data collection, visualization. Option B, data collection, reporting, visualization and analysis. Option C, data collection, analysis, visualization and reporting. Option D, reporting, data collection, analysis, and visualization. Please do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state of the art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Business intelligence is basically a set of process where we have multiple things to bring on the same platform at the same time, depending on everybody's requirement. Right, when I say to bring multiple things on the platform, like few people want to bring cloud data sources, data warehouses, few people wants to bring some different integration tools, correct? So business intelligence is a set of process. Multiple technologies can also work, can also collaborate together. Why? In order to collect the data, integrate it, analyze it, and present it in a visualization manner. Okay, so business intelligence is basically used to extract the insights, right? To what is insight? Insight is just some fact or some information. In easy words, we can say it's just information, a useful information for organization to run their business smoothly, right? So if I say in business intelligence, we extract the data from databases, from Excel files, from different other sources. That's what just a collection of the data. After collection the data, we need to, obviously that data sometimes would be in a structured way, sometimes it would be in a unstructured way, right? So you need to apply some other technology, some other mechanism to make that into a proper format, into a, you need to process the data as per your requirement, right? Or we can say whatever the desired format you need. In that format, you need to prepare, you need to process that data first. Once the data is processed, you do some cleanup of the data, some null values remove, some other joins, SQL joins, or some lots of other things you apply in it, right? You do lots of hiccups on your data. Once your data is prepared, then you use that prepared data for visualization purpose. Visualization purpose means for showing the trends, showing the outliers in your data, right? You want to show when your business was growing or how it is growing, in which particular region, country, or based on quarters, years, how your business is performing. Business performing means how your, let's say if your company deals in trading, or if your company deals in, let's say in the sales purchase of any particular product, or in finance, or in any of the domain, right? Wherever you work, right? Doesn't matter in which domain you are, business intelligence can be used anywhere. Few people think business intelligence uh, can be useful only in the sales or in the marketing domain, right? But actually business intelligence can be used in any domain, anywhere. Wherever you have the data, you can use business intelligence there. So why we need the business intelligence? So currently all the business users, right, all the clients, right, the end users, like if you see the people in company, the people or a team who is creating the sales orders, or who is responsible for creating the monthly reports, weekly reports, or daily reports, they spend lots of time in Excel, right? In Excel, they do all, most of the time they spend in Excel by just pulling the data manually, applying lots of Excel formulas, cleaning the Excel, applying VLOOKUPs, and maintaining multiple versions of the Excel, right? So now they are really fed up by just doing all this thing from last couple of years, right? Excel has lots of limitations as well. The way of working in Excel is not effective utilization of the employee's time, right? Everybody is spending multiple hours for creating just a basic report or a basic analysis, right? If management need a basic report, then their employees are spending lots of hours manually creating all these things every time, correct? So to save the time, organizations are looking for a good business intelligence implementation or a good business intelligence tool, right? Other benefit of business intelligence is everybody needs some information quickly, because based on the quick information you need the quick decisions, and based on the quick decisions you want to apply some quick actions, right? So everybody needs the things quickly. If you observe in recent few weeks, right, in last few weeks, there were lots of offers, lots of, I would say, uh, sales, or lots of things were going on the online platforms, right? If you look at especially for all the learners who are from India, if you have noticed, you have seen that Amazon, Flipkart, lots of sales or offers were going on. So once the sale or the offer session is completed, quickly Amazon and Flipkart, they launched a report, right? It's there in Amazon or in Flipkart. If you see, they launched a report, analysis, to show how much quantities of iPhone they have sold, how many new customers they have got in this sale, what is the farthest location they shipped their order, in which particular state they shipped maximum orders, which particular shipping team or which particular shipping delivery candidate delivered the product within shortest time, right? So these type of lots of information is released, right? So how it all happened within just few hours, right? Because lots of modern technologies are implemented and we all needs the quick insights, right? We all needs the quick insight because we do not want to wait for a few days or weeks to know about the business health, to know about how our sales is performing. We want all the information quickly, right? So decision making is the another and the important factor, right? Decision making we are doing already, companies are doing, but it's not that much fast as they want or they expect. We have few stages of the business intelligence, right? So these are very generic stages of business intelligence. This is just, or I can say just, you can understand what you do, right? From the top, if you look what you do in business intelligence. So basically you do four things: collection of what? Collection of data. Everything is related to the data here, right? Collection, data cleansing, reporting and visualization, and then decision making. All right. Now, each and every step is interlinked with each other, if you notice here, right? So it has been said reporting is a never ending process. It's not like the other projects, like you complete one report, you complete one project, and that's it. It's an iterative model. It iterates, right? Continuously. Reporting never ends. So you collect the data. After collecting the data, you perform some data cleansing, right? Like if your data is having some null values, some blank data, right? You want to clean that. You want to do some more data processing. Then you create some visualizations, creating some charts or graphs, right? Using different visual elements. And then you finally share your reports with your business users, where you're with your clients, with managers, where they take the decisions after looking at the facts, correct? And again, this process keeps going on. They ask few more changes, few more data, few more information, then again you do the same thing, correct? So it's a cycle, it never ends. It's a short name or short form of the business intelligence, BI. So BI is everywhere. right? Don't think about like business intelligence is only in a particular domain or in a particular field. Business intelligence is everywhere. Wherever you have the data, business intelligence can be used there. Either you are in sales and finance and education and HR, services, supply chain, wherever you are, right? In any domain, business intelligence can be used there. We are taking example of data semantics. Data semantics is a company where this company is using few reports and dashboards for their sales team. Their sales team members are able to take the insights. They are able to take the decisions quickly by just looking at some visuals, right? Because human brain is habitual for the visualizations, right? It's not easy for us to read the data, to understand the data from a tabular representation, right? So we need some pictorial or graphical representation of the data. Here we have a sample. This is just a sample report, how a report looks like, correct? So when you create a report in any BI tool, so your report, or you can say dashboard, it looks like this. All right, so we have few visuals here, different color codings we have, right? So whenever you prepare a report, it looks like this, right? Another scenario we can have of Dell. Dell is also using the business intelligence solutions in their education department, where Dell is also having some dashboard where they can monitor the performance of their employees are taking, how much is the passing grade, how much is the total enrollment in different courses, correct? So business intelligence can be used in any domain, in any department, correct? On top of any data you can use it. Did you hear about Sisense, Click? Click is already there here. Sisense, Oracle BI. Business intelligence tool, Python is called as multi-purpose language, right? Where you can use Python for definitely for data analysis, for visualization. But Python doesn't comes into the business intelligence tools list, right? Zoho is not, I won't say it's a leader, but it's in demand. Reason, because there are lots of companies who are using those other products of Zoho, like Zoho CRM, Zoho ERP. That's why Zoho is in a bit demand, right? For a few of the companies. Zoho is mainly used by small or mid-sized companies, and these tools are mainly used in, I would say, in mid-size and large companies and enterprises. Okay. So now, when we have so many tools in the market, then why Power BI is gaining the popularity? The special thing you found about Power BI and you decided to learn Power BI. One reason could be it's because of your project requirement. That's one, right? But what other factors you have explored about Power BI? Why you want to learn the Power BI among the other tools? Just few responses I have started getting here. Friendly, user friendly, plus it's free. It's a Microsoft product. Auto refresh is everywhere in all the tools. You see that Pavani says I have been using it already and it's easy to use, correct? No doubt. From the user adoption point, it's very nice product, right? Another, yeah, obviously if your company is using this tool, so I mean that's it's another thing. Easy to understand because of the licensing. Tableau is getting more expensive, so organizations decided to go for Power BI. That's the important factor. If you just think about it, why you need a particular mobile phone or why you need a particular car. So almost each and every mobile phone, each and every car can do the similar thing, right? They have the same features, common features, right? They have almost similar things. If there is, let's suppose if there is some new functionality you got in a particular mobile phone, Next week, just in next week, you will find the same functionality, same feature almost in all the mobile phones. Other companies will quickly launch that feature, just copy paste. Correct? So same thing in BI tools as well, right? On internet, if you go, you will find that Power BI can do this, can do that, right? Or Tableau can do this, can do that. Almost each and every tool can do all these things. But the factors based on which we measure which tool is leader or which tool is good for us, for the companies, those parameters are user adoption, how much user friendly this tool is, cost is obviously the number one thing where organization consider it, but cost is not the first preference. Cost is important for companies, right? Licensing cost, I mean, it's important for them, it's one of the key factor, but it's not first factor, right? Because no company wants to just pick any tool if it's just because of its less expensive, or if it is free. Their first focus is on the adoption, right? On its capability, on its interface, how easy it will be for the non-technical users to learn, right? Because it's not like every time every company will be having a 100 of IT team or 100 of the developers, right? So they want to train their business users for self-service, right? For self-service business intelligence. So there they want to train their sales team, their finance team, their legal, their HR, right? Their managers, directors, so that they can create their day-to-day analysis, they can create their dashboards by themselves. Correct? So the key factors are, it's how much capable it is, right? How quickly users can adopt it, how easy its UI, its interface is, and the cost, right? And another important factor behind it is the brand tag. There is no doubt brand tag is having its own importance as well. So from the adoption point of view, Power BI is something like which any non-technical user, any non-technical person who is not coming from a technical, from IT background, who don't have any coding, any programming language experience, that person also can also learn Power BI easily. Because Power BI is basically a no code tool. No code means no code or low code. Microsoft is promoting it as a low code or no code tool, where you don't need to write any code, no programming, nothing is required, right? Nothing is mandatory to work in it. Although this tool has the capability to write the code, this tool has the capability to integrate with other programming languages like Python, R, but it's all not mandatory for everyone. Correct? So now when I say this tool is cost effective, how cost effective? It's not a very expensive tool. Any person, any company can easily implement it. Even a small company, a startup company can also easily afford this tool. It's not the expensive tool like its competitors like Tableau, like Click. Tableau is no doubt a very powerful and a very good tool. But the problem is, there are two problems personally what I observe, right? I have worked in the Tableau as well. Tableau is not a user friendly tool, right? That's not user friendly. Means if you are technical, if you are, I would say, if you have a lot of time, then only you can learn and you can become master in that. Another reason is cost. It's a very expensive tool. Tableau is expensive. Another important thing about Power BI is it's a Microsoft family product. So being a Microsoft family product, it has a very tight and easy integration with Microsoft products like Teams, SharePoint, Microsoft CRM, Microsoft ERP. With all these tools, it can be integrated easily, right? Okay, so these are the couple of factors based on which Power BI is in number one position. And it's not only because of I'm saying it's on the number one position. There are a few facts, few companies who have conducted lots of survey and researches, lots of events they have organized, and based on the collective feedback, companies are recommending, right, that Power BI is the leader in business intelligence segment. Okay, I will show you those companies or those reports where all these things are happening. Few things we can see here: affordability. Obviously, Power BI is affordable tool. Any company can easily afford it. It's not a very expensive. We'll come on the costing part, on the licensing part later. It has the natural language query. Natural language query means you can just write a question, and based on the question you can get the answers. Means you don't need to spend long time, or you don't need to be a technical expert for getting some visuals. You can just write a question like show me total sales, and once you write this question, Power BI gives you the visualizations. If you want to know your top 5 customers in USA, so you just write a question, show me top 5 customers where country is equal to USA. That's it. Similar, I mean, how we interact, how we communicate with our colleagues in simple, in plain English language. Similarly, you just need to put your questions, you need to ask the questions on Power BI. Power BI read your questions, understand your questions, and give you the answers in visualization form. I will show you these things practically. Real-time streaming. If your company is maintaining a real-time streaming data set, then in Power BI, you can create some real-time dashboards, right? Where you can quickly see the changes, whatever you have made in your company. If some data is changed or something is changed, you can quickly see that change. And the next and the last we have here in this list, custom visualization. We have 100 plus visualizations in Power BI, right? You have a wide range of the visualizations where you can work on all these visuals, right? You can freely bring those visuals in Power BI to create more interactive reports. Is basically a complete data analytics package. Power BI is not just only for reporting purpose. In Power BI, you can do a complete data analysis. Complete data analysis means like you can prepare the data, you can perform ETL stuff as well. Okay, so what is ETL? Are you guys aware with ETL stuff? What is this ETL term means? It's mainly related to the data warehousing, but it's a basic terminology of data warehousing. So you should aware with it. So it stands for extract, transform, and load, right? E for extract, transform, and load. So companies generally maintain a data warehouse, right? In that data warehouse, they maintain all the company's business data, right? Whatever the data we need for analysis purpose, for reporting purpose, for visualization purpose, all that data your companies will be maintaining into a database. And that database is called as a data warehouse. In that warehouse, you can store all your data. Whatever is needed, from there you can query, and you can bring that in the tools, in BI tools, and you can create some charts and some graphs on top of that. Correct? So ETL is a process where you extract the data from various data sources. After extracting the data from various data source, you transform it, because lots of joins, lots of other business calculations you want to write, right? You want to clean some data, you want to replace the nulls, remove unnecessary columns, lots of processing you want to apply on your data. Once your data is processed, then you want to load it into some centralized repository, some centralized database, right? So this process, collectively, this process is called as ETL process in short, right? So this ETL is basically a data warehousing term where different data warehousing tools companies are using, like SSIS, Informatica, and Azure Data Factory. So these are the few important, or I would say very popular tools in the market where companies use these ETL tools. right? And after using these ETL tools, they process the business data. They process all this business data, all the business data, and they keep the business data into a database. Correct. So in short, ETL allows companies to gather the data from different data sources and then consolidate it into a single centralized location. Correct. That's the basic process, basic, I would say, work of ETL tools. So to an extent, you can do the ETL within Power BI also. Like data transformation, you can do within the Power BI as well. So here you can see data connection, which means you can extract the data from different data sources. If your data is in SQL, if it is in Salesforce, SharePoint, SAP, Oracle, MySQL, or it's in Azure, in any of the source wherever you have the data, that data you can bring inside Power BI by just creating a data connection. After that, you can transform that data, right? You can apply lots of transformations on top of your data, like merging the data, joining it, splitting, replacing, lots of concatenation, a lot of basic stuff you can apply on your data. Once all that stuff is done, then you bring your data again to Power BI desktop, or we can say we load the data finally inside the Power BI. So we will be having a staging area, right? A staging area means like in memory, you can hold your data for temporary purpose where you can process your data, and after processing it all, you can finally move it, you can finally load it to Power BI desktop for the data modeling purpose. Data modeling means writing some business calculations, some formulas, mathematical calculations if you want to perform. Once all that stuff is performed here, then you start doing with the data visualization, right? You start creating some charts or graphs. Once all that stuff is done, then you share your reports with your business users, right? With your managers, directors, right? So this is just an overview what you do inside a Power BI. So Power BI is a complete business intelligence platform where you have the capability to aggregate your data, analyze it, and visualize and sharing with your different users within your company. Correct? Now, coming back to the point, what all the components we have of Power BI. When I say Power BI is a complete package, so in Power BI, we have multiple components. Power BI Desktop, Power BI Service, Power BI Gateway, Power BI Report Server, mobile app, Analyze in Excel, and Report Builder, and Power BI Embedded. All these tools we have, which we use depending on the requirement. Most of the time, these three tools are used, right? Most of the companies use these three tools: Power BI Desktop, Service, and Gateway. There are some scenarios where companies can use the other tools as well. In our training program, we will be learning all these 8 components, but our major focus would be on these 3 components, right? So most of the time we will be spending, even every Power BI developer, every BI, Power BI analyst spend most of the time only on these 3 tools. Correct. But depending on the scenario, let's say if anyone got some different project or some different work to work on these components, right? But that's very rare. Most of the companies focus on these 3 tools because these 3 tools gives you almost everything, whatever you need. Correct. Now, let's have a quick understanding of all these components, what these tools are doing. Power BI Desktop is used. Power BI Desktop is a standalone application which you can use, which you can install in your laptops and your desktops. Power BI Desktop cannot be installed on Windows 7. Power BI Desktop cannot be installed on the Mac machine, right? So if you are a Mac user, you cannot install the Power BI Desktop, right? Because Power BI Desktop you can install only on Windows operating system. So you need Windows 8 onwards Even on Windows 7 also you cannot install it. So Power BI Desktop is a free application which you can install on your local machine. It allows you to connect your data sources, to bring the data, almost everything. As a developer, you spend all of your time within Power BI Desktop. Once Power BI Desktop you open here, you will see this welcome screen. So no need to do anything on this type of on the right top, there is a cross button. Now here you see on my screen, this is Power BI Desktop, correct? This tool is completely free. No need to pay anything, no subscription, no license is required to install this tool, okay? Although if you compare it with Tableau Desktop is same as Power BI Desktop, but you need to pay $70, right? In order to use the Tableau Desktop, you need to pay $70 per user, which is a very expensive tool, right? So if let's say 10 users wants to use Tableau Desktop, so then they need to pay $700 per month for 10 users, right? So this is not needed in Power BI Desktop. Power BI Desktop is free. Okay, so anybody can install the Power BI Desktop. Now, this is just a quick look of the Power BI Desktop. Later, we will come back to Power BI Desktop to talk more about it, how it works, because module 2 is completely based only on the Power BI Desktop, correct? So in our today's module, we are just getting an overview of all the tools or applications we have. You will be having a URL. You can go to this link. In this link, you can sign in, right? To sign in Power BI, here you need a Microsoft account.
Let's have a quick quiz question, guys. And the question is, what is business intelligence or BI? Option A, a company's annual financial report. Option B, the process of spying on competitors. Option C, the use of data analysis tools and techniques to make informed business decisions. And option D, the management of customer relationships. Please do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
If you are having a Microsoft account, then it's good for you. If you don't have any Microsoft account, right, or any work account you don't have, then no worries. I will be providing you one Power BI license, one Power BI Microsoft account, which you guys can use to sign in into the Power BI service. Only one account you need in your companies. You can use your official email ID, the one which you use to log in your Teams, in your Outlook. Same account, same user ID password you can use inside Power BI as well. If your company has allowed you from the settings, right? Because they have a settings administrators, your company IT team or admin team have the control. If they have allowed you to sign in the Power BI, then you can do that using your official email IDs as well. Or else, if for any reason, if you don't want to use that, or if for any reason, if that's not working, I'll be sharing one user ID and a password with you guys in our upcoming modules, because for now we don't need any Power BI credential, right? Because for first 4 modules will be based only on Power BI Desktop, correct? But still, Power BI license I'll be sharing with you. If you click on sign in, then it will ask for a user ID and a password. My credentials are already saved here, that's why I didn't ask, but it should ask for a user ID and a password. Now I'm successfully signed in inside the Power BI service. So no installation, nothing is needed, it's just an online application, or we can say it's a SaaS based application, software as a service, cloud application. Right here you have lots of functionalities, lots of tools. This Power BI service is used by the report viewers. As a report developer, you create the reports, you develop the reports in Power BI desktop here, and after you publish the report, here you see a publish option. From here you publish your report on the Power. Right, once your report is published here on the Power BI service, then your report viewers, your business users, your clients, they can access the report from here. They can go to the different folders, different workspaces are created. All right, so once your users open the report looks like this. From here, they can interact with the report. They can slice and dice the data. They can filter the data. They can select a particular country or particular filter value, right? From here, they can export this report in Excel, in PowerPoint, in PDF, right? Lots of other things they can do here. If you want, you can give them the permission to edit the report. You can allow them to get the report by default in their mail, in their inbox through an email. Lots of other things they can do from here. So Power BI service is mainly used by the report viewers who wants to interact with the reports, right? To log in inside this Power BI service, you need an account. Like I'm signed in here using my organizational, using my dummy account. Similarly, you need an account here. Okay, so if you want, you can use your account, or account will be provided to you in module 5. Now, next we have Power BI Gateway. This Power BI Gateway is a component, is another tool which you all need to install in your machine. Okay, so these are the three most commonly used tools: Power BI Desktop, Power BI Service, and Gateway. Other than this, we have a Power BI Report Server, which is an alternate of Power BI Service. As you see, Power BI Service is a cloud application. It's an online tool. If any company do not want to use online tool, like any government companies or any financial company, financial institutions, banks, right? Or any company where they have some internal data security policies and they do not want to use any cloud service. They want to keep only the on-premises services. They want to keep all their data within their company domain. In such companies, this on-premises Power BI report server can be used. Next, we have Power BI mobile app. So if you want to access your reports or Power BI dashboards through mobile phones, then a Power BI mobile app needs to be installed in your Android, iPhones, iOS mobile phones, or in your Windows mobile phones. Correct? It's a free mobile app. You guys can install the Power BI mobile app in your mobile devices. Through this, you can view your reports, you can access your reports, but you cannot edit. Okay. Now, next you have Power BI Excel. Excel is very tightly integrated with Power BI because sometimes users wants to export the data in Excel for the further analysis, or they want to do some data reconciliation, especially the financial users. They want during their financial month and month ends or quarterly uh, ends, right? Depending on the requirements. So most of the time they want to take their data in Excel. They want to do then lots of research, lots of slice and dicing on the data, right? So in such cases, Power BI data you can export in Excel as well for any reason if you need it. Next, we have Power BI Report Builder, which is another tool. This tool is not much used in the companies. There are two reasons behind that, this behind the not much usage of this tool. One reason is it's expensive, right? It comes with a separate license, right? First, it is expensive. Another reason is this tool is not needed because most of the companies are already using the ERP tools. So the functionality, the benefit we get through this tool is already companies are having by their ERP tools. So obviously, if they already have one tool implemented, so they do not want to spend another thousands of dollars just for this purpose. So the benefit of this tool is to create some reports like invoice, receipts, delivery notes, to create some paginated reports, some document reports basically, correct? So invoices generally are printed through companies' other tools. Like if any company is already using a SAP ERP tool. So in SAP already there are these type of functionalities are there where they can print their invoices or receipts or other documents, other legal documents, correct? But we will understand this tool, how it works. I will show you the installation of it. I will show you how it can be used to create the reports. Next and the last, we have Power BI Embedded. Power BI Embedded is mainly used for the integration purpose. If you want to integrate your Power BI report in any other application, maybe in any website, in any blog, in any portal, in any third-party application, third-party tool, so you can just embed the Power BI report. You can integrate Power BI report in that application. Okay, so this is a quick overview of all the components which we have, correct? And on this report now, as a sales manager, maybe I want to see the data for a particular date range. So I'll just apply this filter. Right now, I expand the range and I want to see the data for, let's say, a particular category. I want to see the data of the seafood category only, not for all the categories, for the seafood. So here I'll go to this filter. I'll select the seafood here. Seafood I selected, right? So this is what I'm doing. I'm clicking the data from different angle for this particular date range, for this particular category only. For this category, my sales is $45,000, right? So this is what I'm doing. I'm slicing the data. I'm filtering the data basically, correct? So
how would I rate myself after this the touch base you will give on the paginated, if
so
out of 10?
see, on that part, see, it depends what as you mentioned that you only enrolled for this course for paginated reports.
Yeah, I mean,
so we have
yeah,
1 hour.
70-80%.
So we have 1 hour for the paginated report. Out of 27 hours, we have for 1 hour for the paginated reports. So I think that is more than enough for you to understand how much in depth we will be going.
And do we have any recorded material available in the learning board for the paginated report?
Definitely it's there.
Okay. All right. I'll connect with the support for more.
Sure.
Thanks.
All right. Okay. Another quick question here. I see another raised hand. I see from Rahman. Yeah, I unmute you. Right. So here you see. So predominantly we have 3 licenses, although we have one more license type that is called Power BI Embedded license, but that's not for the Power BI development or Power BI deployment. That's an integration license basically. Means if you have some integration requirements, you want to use Power BI Embedded Analysis, then you need to go with a different licensing structure. But most of the companies use these 3 licenses. So Power BI Free, Pro, Power BI Premium, right? So these are the 3 licenses we have. Power BI Free is completely free. You don't need to pay anything. But when you say you are not paying anything here, you do not have the access of many features. Power BI Free can be used for self-use, for individual use. Power BI Free cannot be used in a company, or Power BI Free cannot be used for sharing the reports. Being a free user, you cannot share the reports. Even you cannot access any shared report, right? So Power BI Free has a limited access of the features. It's kind of a test drive, right? You can just have a look for your self use, but if you want to use more features, if you want to use the full potential of Power BI, then you should have the Power BI Pro license at least. Power BI Pro is the most widely used license in the market. Most of the companies are using Power BI Pro. It's a per user license. In this license, you are getting almost each and every feature which is required from the development and from the user's point of view. The license cost of this uh, Power BI Pro is just 9.99 US dollar per month. This is per user cost, right? So for one user, you need to pay 9.99 US dollars per month, correct? Or we can say in short, $10 per month. In Indian rupees, it is 720 rupees cost, right, per month. So if in a company, if there are 10 users who wants to use the Power BI Pro, then company will purchase the 10 licenses, right? And after purchasing these 10 licenses will be assigned on top of their official email address, right? Let's say if you work in any company, right? So on your official email address, you will be having the Power BI license, right? When you use your official email ID in Power BI, automatically you get the access of all the pro features, correct? Now, what extra benefit you have in the pro, which you don't have in free? That is ability to share the reports, ability to access any shared reports, and other features as well, like export features. If you want to export report to PowerPoint, to PDF, all that functionalities you get here, right? Being a free user, you have 10 GB of space. Being a pro user also, you have 10 GB of space. But this 10 GB is not upgradable, means you can in case of pro, you can increase it. How? This 10 GB limit is for one workspace. Means for one group, in one folder, you can keep the reports or the data up to 10 GB here. And you do not have the flexibility to create another group, another folder. But here in Pro, you can create another group. And the group, what I'm saying, that is called workspace. So if I show here on the Power BI service, manage personal storage, and here you can see its limit, right? So personal workspace, right? This my workspace is called as personal workspace. In this workspace, you can see it has 10 GB of space. Out of 10 GB, I have consumed 134 MB. And as this is a free user, so only 10 GB is allowed. This user do not have the access of the other workspaces. Why? Because this user is a free user. This is not a pro user, correct? So free user has 10 GB of limit for one workspace, but in pro, you have the flexibility to create another group, another workspaces where you get another 10 GB, correct? Although 10 GB is a very big number, it's not like easily you cannot fill it. If you want to fill this 10 GB of space, then almost more than 100 reports you need to keep in one workspace. And keeping 100 reports is not an easy thing. I don't think so any company would be having 100 reports if you maintain the uniqueness of the reports. Correct? Next, you have data refresh rate. Being a Power BI Pro user, you can refresh 8 times in a day, right? The one you see here, this is 8 times in a day, you can refresh the reports. Here also you have the same benefit, 8 times in a day, you can refresh here as well. If you need more benefits, if you need more power, more luxury features, if you need, then you go with the Power BI Premium. Power BI Premium is a capacity based. It's not a license based, it's a capacity based, or we can call out it like it's a bulk license. If your company is having 1,000 users, right? If your company is having 1,000 users who wants to view the reports, so just for the viewing purpose, we don't want to purchase 1,000 Power BI Pro licenses. That would be very costly for us. That would cost us around, if I just multiply 10 with it, so it will cost me around $10,000 per month. It's very expensive. So it's better rather than I purchase an individual license for 10,000 users, for 1,000 users, sorry. It's better I just purchase a capacity, complete server, right? Where I can assign those 1,000 users on this capacity, and this capacity will give me almost all the benefits of Pro. On top of Pro, I get more frequent data refreshes. 48 times in a day, I can refresh one report, and I get 100 TB of the space, which is almost unlimited, and in just $5,000 per month. So instead of spending $10,000, you can spend only 5,000, 4,995 per month. Correct? So if you have a large user base, and if you need some more powerful features, more extra features if you need, then your company can purchase Power BI Premium. Otherwise, Power BI Pro is more than enough. We get each and every functionality, each and every settings in Power BI Pro as well. It is cost effective, only $10 per user per month, right? So any small company, anybody can easily afford this $10, just 720 Indian rupees per month. Got it? So I hope the licensing part is clear to you. So I'll be giving you a Power BI Pro account, right? That Power BI Pro account will be having a 60 days of the trial. That will be just a trial account. So for 60 days, you guys will be able to use Power BI as a pro user. How do we work in Power BI and how the tools are being used? Now, here we have a very easy representation of the things from a user perspective. Here, your company data will be stored in these data sources. Let's say your company data, your business data is stored in Salesforce, in Azure, in databases, in Excel, SharePoint, right? Then this data you want to bring in Power BI Desktop. In Power BI Desktop, you bring your data, you extract it. After extracting the data, you perform some data cleansing, some data transformations, right? Then you create some charts, you visualize your data. Everything you do within this Power BI Desktop. Once it's all done, then you deploy your reports, you publish your reports to Power BI service, right? Power BI service is a cloud-based application. So once your report is published in the Power BI service, then your report, let's say, publish here somewhere in Power BI service. Now, if your users wants to access this report, so they will just log in through their mobile phones or through their tablets, through their laptops. They will log into the Power BI service using their credentials, and they can access the report. They can filter the data, they can export the reports or whatever they want. All the things they can perform here, right? For your report viewers, it's not mandatory that they also install Power BI Desktop. They just go to the Power BI service, which is a browser-based interface, browser-based, or it's an online portal. In this portal, they log in and they access the reports. It's not mandatory for them that they install Power BI Desktop. Power BI Desktop is needed only for the development of the reports, or if you want to make any change in the data model of the report, only then you need the Power BI Desktop. Correct? Now, once a report is published here, you want to refresh the data here. Your users also wants to see updated data, right? So you will not be manually publishing the reports on daily basis, right? Manually refreshing the data, although it's not possible. Maybe for one report, you can somehow manage it to do a manual refresh, but let's say there are 100 reports. So how would it be possible to refresh data in 100 reports manually? So that's why we need a scheduler, we need a job or a external tool that is called Power BI Gateway. This Power BI Gateway will be having a connection with data sources and with your Power BI service report. Here you will just define, like, let's say at 6 a.m. I need the report refresh. Then at 9 a.m. I need the report refresh. So you just define these timings here. Once, based on the defined time frequencies, this data gateway will be fetching the data from your data sources and will be refreshing it to your Power BI service reports, right? So this activity will be will be going on in the backend. During your viewers are when your viewers are accessing the reports, there will not be any impact on the data when they are viewing the report. Once they refresh the report, they automatically get the updated information, refreshed data. Correct? So this scheduler, this refresh job, you can set up with the help of Power BI gateway, right? So this is called as a mediator or a bridge between your Power BI service report and your data source. If your data source is on premises, only then we need the data gateway. If your data source is cloud, without the gateway, you can refresh the data directly, right? If your data source is online, means if it is SharePoint online, Salesforce online, if it is Azure, you can refresh the data directly. You don't need the data gateway. Data gateway is required for refreshing the data from any on-premises data source, right? Which is hosted, which is deployed, or which is running in your company's server, and that company server is somewhere placed in a physical location within your company. Maybe in your company you have a CPU or a server. In that server or in that machine, any application is hosted or any database is running in that application, in that server, in that machine. So that is your on-premises database, right? Because that is accessible from your company network only. Correct? That is accessible through your company network. Once you are in your company domain, in your company network, only then you can access it. Or I can say it's an intranet, right? So intranet is your on premises. If you deploy it on the cloud, like Azure, like AWS, like SharePoint Online, like Salesforce Online, like OneDrive, Google Drive, all these are what? Cloud, or I would say online data sources. From these data sources, you can access the data from anywhere. If I place an Excel file in my local machine, right? If I explain an Excel file in my laptop and I shut down my laptop, I will not be able to access the file from somewhere else. I need my laptop to turn on and to access the file. If the same Excel file, if I upload on OneDrive or maybe on Google Drive, then I can access that Excel file from anywhere. Why? Because it's now uploaded on internet, on cloud. Got it? So if your data source, maybe if your SQL is in your company's domain, if it's in your company's intranet, it's your on-premises SQL. If your SQL database is on cloud, means on Azure databases, then it's your cloud database. It's your online database. Correct. So just these are some basic terminologies which you guys should understand. You should be aware, right? You can explore more about it. You can get more knowledge about these terms. Correct. Because if you are planning to switch inside in Power BI or in the IT field, then these are the few, I would say, few words of the dictionary which you should on which you should have very good understanding, because these are the couple of keywords, or these will be the few, I would say, uh, a few terms which you will be using very frequently when you face any interview. So if you are not aware with these terms, right, or if these terms are not very much clear to you, you won't be able to understand and you won't be able to use it. So means to impress your interviewers, you need to use these terms, these things very frequently. Okay. If you are coming from a BI background, then I hope you already understand the importance of these basic things like on-premises or ETL tools, data warehouses, data sources, data sets. Okay, so these are the basic terms which you guys should explore, right? Just do some Googling on it and try to get more knowledge on it. Or if you have any doubt somewhere, you can discuss that with me as well. Data source is something where your company's or your business data is stored. Wherever your business data, your company data is stored, that is data source. Maybe Excel, SQL, Oracle, all these are the data sources. Once you are connected to the data source, then the next step is transforming the data. Means you apply some data cleansing operations, and then you do a data visualization. When I say connecting to the data source, you can connect to SaaS. Data source means online data sources, some databases, Azure file, some other online data sources. From all these data sources, you can collect the data. You can bring everything inside Power BI, whatever is needed based on your requirement. Then in the next step, you transform the data, you apply different operations, like few operations you can see here. Group your data, you can do fill, transpose, merge, pivot, and pivot. These are the basic transformations which you can apply on your data. Once your data is processed, it's transformed, then you start doing the visualization. Means you start creating the charts or the graphs, you start bringing the data with the help of visuals. You have lots of visual elements, charts, cards, map, trees, tables, matrix, filters, lot of things you have. Correct. So all these things we use for creating a report in Power BI. Once a report is created in Power BI Desktop, then we will deploy it to Power BI service. When I see report view looks like this, right? Your report view will be like this. On this report view, you see multiple charts. So which charts are these? Could you please name out these charts? Which chart are these? One, I see pie chart, map. What the other two charts you see here? And this one is your column chart, right? Or we can say cluster column chart. And this is your funnel chart, correct? Okay, now when you see different charts we have added, so we can say this is one of my report. But inside this report, you will be having the data as well. To see the data, right? To see the underlying data or the raw data, you go to the next tab that is called data view, where the data looks like this. Currently, this dim promotion table is selected. For this selected table, you can see the data here. Dim promotion table, correct? On this table, now you can see you have the data of this table. So this data is coming from your data source, right? So the data source may be different. Maybe this particular first two tables data is coming from Excel file, then another 2 or 3 tables data is coming from SQL database, right? So whatever the data you load inside Power BI, that data view you can get from here. It's just the raw data, although you don't need to worry about it, because to your business users, to your report viewers, this data will not be visible. They will see only the charts, the previous screen which we were seeing, only those charts or the report, only that will be visible to them, correct? So this data will not be visible. They won't be able to see it. Only you can see it because you are using Power BI Desktop. Only in Power BI Desktop you can see it. Now, next tab we have, that is model view. Inside the model view, we manage the relationships between the data. So when you have multiple tables, in between your tables, you want to set up some linking. Linking means some logical joins. Well, we will understand this in detail, but for now, important thing is just to know under the model view, we can access the relations between the tables. Got it? Okay, now, okay, yeah. So the most commonly used data sources are SQL and Excel, right? Yeah, for sure, Muhammad Ali, multiple data sources can be used. Okay. So although few people will be using SAP, Teradata, and now if you have any data source, right, then you want to bring that data in Power BI. But how you think in real-time scenarios? For example, you got a project to work on Power BI, right? So first you will understand the requirement. You will be communicating with your business users, with your client, with your business analyst, depending on your role or your company to competence. So once the requirement is clear to you, then you do some research on data sources, how the data is placed there, how the data is structured, which all columns, which all tables you need from that particular data source, right? So this data discovery you need to do first. That's very important. Without doing the data discovery, you cannot perform multiple things in Power BI easily. So the basic thing is you should be aware on your data and on your business process. If you know these two things, then it means half of the work you have already done. Once requirement is clear to you, you know which data source will be used. You directly go to that source, get the data in Power BI, start processing that, visualize that, and publish that on Power BI service to share with the users. Okay. So we are going to explore different data sources, like how we get the data from various data sources. In your scenarios, you can get the data maybe from one data source or from multiple data source. It depends. All right. So to get the data in Power BI desktop, you have this option available, get data. If you click on get data, you see a list of common data sources. This list is predefined by Power BI. Now, if you want to see an entire list of the data sources, just click on more. Once you click on this more button, you get an entire list of all the supported data sources. These are 100 plus data sources from where you can bring data in Power BI. If you want, you can see it in different categories. Under the file category, you can see all these are your file type of data sources. All these are your databases, right? Similarly, you have different categories available here. Any particular data source, if you are trying to find, you can search that. Let's say you are trying to find SQL database, so you can search here SQL Server. Here you go. Okay. So for example, I have my data in Excel. I have my data in Excel. So first, let's get a quick overview of that Excel data. So I go to my data source in my OneDrive here. Under the dataset folder, I have a global superstore Excel data. This global superstore is very famous and free dataset, easily available on internet as well. This dataset contains 3 sheets. This Excel contains 3 sheets: orders, return orders, and people data. Now, this data I want to bring in Power BI. Sometimes your data may not be into a proper format. Like here you see your column, first row is your column header, and that column header is not properly adjusted. Actually, the second row you see, that is the column header. So if you want, you can correct it, you can format it in Excel also, or maybe you can take this data first in Power BI. In Power BI, you can process this data, you can format this data as per your requirement. So for now, we have these 3 sheets where we have sales transactions. Now, this data I need in Power BI. I go get data. Here I can see Excel is attached. Excel is available here as a quick access, although you can access the Excel directly from here, or you can click on this button as well. I click on Excel as a data source. I need to provide my data source. So maybe I can go to my OneDrive. From the OneDrive folder, I can pick the files, or I can go to my local drive. From my local drive also, I can pick the files. Once I select the file, I click on open. Now Power BI will read the data from the Excel file. When Power BI reads the data from Excel file, it gives me those 3 sheets which I was having in Excel file. But it gives me 3 additional tables here, which I was not seeing in the Excel file. So here, if you closely look at the icon of these tables and the sheet, this icon is of table and this icon is of sheet. So there is a functionality in Excel that any Excel sheet you can convert into a Excel table. So this returns sheet, you have this data we have converted into a Excel table. So this is an Excel feature. I'm just keeping it here so that you guys can understand. Sometimes when you get the data from your business users, you may have some additional tables here because it's an Excel functionality. Within Excel, a table has been created. That's why these are appearing here. But you don't need to worry about it. You just focus on your sheets. You select your sheets. When you click on the sheet, here you can see the preview of the data. This is not the entire data. It's just a preview so that you can understand what type of data you have inside the orders table. If I want to see returns table data, I select the returns table, and here I can see the preview. It's just a preview. It's not the entire data, right? Just a preview you can see here. Now, if you have a list of tables, you have the search box to search a particular table by its name. Now I select orders table here and I select people table. You need to select these checkboxes. If you don't select the checkbox, then these load and transform data button will not be enabled. It's grayed out. So if you want to enable it, first check mark it. So I need orders table and people table. I select these two tables and I click on transform data. Ideally, I should click on the transform data, right? Because when you click on transform data, your data will be loaded into a different window that is called Power Query Editor. From that window, you can process your data. You can clean your data. After cleaning it, or we can say after transforming it, we load the data inside Power BI desktop. So as per the best practice, you should click on the transform data first. And my data will be loaded inside the another window, and that window is Power Query Editor. So here you can see the window is Power Query Editor. Now in this window, you have lots of options available. We have a lot of different tabs, different buttons here, which we use for transforming the data. So what is this data transforming, or we can say what is this data transformation? So data transformation means you want to clean, you want to process your data as per your requirement. Like you want to remove the null values, you want to remove the duplicates, you want to link, you want to join two tables like Excel VLOOKUP, you want to split the column values, you want to concatenate, you want to merge, right? So these type of operations you want to perform on your data in order to make it into a structured manner, right? It depends on your requirement, project to project, company to company, and depends on the data quality also. Sometimes people will be having the data in a structured manner, so that in that case, your life is easy. Just bring the data, do a little bit transformation and use it further. If your data is not well structured, if it is, let's say, unstructured format or semi-structured format, then you need to perform lots of things to make that into a proper format, to make it into a usable format. Got it? So these things depends scenario to scenario. Okay. Now we are not going to focus on the data transformation for now, because for this we have a dedicated session, which is next module. But here, if you notice in the people table, my first row, you see that is a useless row. I don't need this row. This data is just a useless data here. So I want to remove this data from here. I want to remove this first row. So how can I do that? removing the first row. That's very easy. To remove the first row, I just go remove rows, remove top row, enter 1, click OK. That's it. The first row which you were having in your data, that has been removed now. And now the first row you have, this row you want to promote as your column headers. Means this first row should be the column header. So what you do for this? For this, you have an option available here, use first row as headers. You just click on that, use first row as headers, and your data means the first row will be promoted, will be treated as the column headers, as the column names. Correct? So this is just an example of doing the data transformation. Similar to that, we can perform different transformations here. For now, transactions have been applied. Now let's load this data in Power BI desktop, because when you see the data in a Power Query editor, it's a staging area, right? It's a staging area. Means before loading the data physically inside Power BI desktop, you hold this data into the memory for processing purpose. Once it is processed, then you load this data to Power BI desktop. So for that, you click on this close and apply button. Now the data will start loading inside the Power BI desktop. Once the data will be loaded inside Power BI desktop, memory will be cleaned automatically. Means your staging area, your memory area has been cleaned automatically. Now, once you have loaded orders and people table, you can go to the data tab, and from the data tab, you can select your table, and for that selected table, you can see the data. Correct? If I select people table, for people table data, you can see here. Got it? So you have loaded these two tables. If you want, you can load the other tables from other data sources. Maybe now you want to bring the products table, and product table is in different database, is products table is in different source. From there, you can bring the products table similar to these two tables. Correct? So this is how we bring the data inside Power BI. At any point of time, if you realized you want to do more data transformations, here you can click on this transform data button. Once you click, your data will be again loaded inside the Power BI query editor. In Power Query Editor, you can continue on few more data transformations. Correct? Like you don't need this ship date column, or you don't need the ship date column, or ship mode column, or any other column, whatever you don't need, or if you want to create something new here, right? So whatever you want, you can perform all these things here. But currently we are not focusing on the data transformation part. Our focus is on data extraction.
Let's have a quick quiz question, guys. And the question is, what is the primary function of Power BI desktop in the Power BI ecosystem? Option A, data storage and management. Option B, data visualization and report creation. Option C, data modeling and analysis. And option D, data sharing and collaboration. Please do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So I have just loaded data of an Excel file. Let's say I need the products data from a different data source. My products data is, let's say, is available in a different data source, and that different data source is a OData link. It's just a online or a web service link, or we can say a API link. I click on OData feed. OData feed is a data source name. OData is a web service name. If you have worked on the web services in your programming languages, then you would understand it, right? But it's a web service type. Through web services, through APIs, if you want to fetch the data from some custom applications, then you can use this. So let's say I already have this link. This link will be generated through that application which you have. Correct? Maybe if you have ServiceNow, if you have any on-premises application, any custom application, through that application, a URL will be generated. That URL you just paste here. You click on OK. But okay, when you click on OK, it give you a list of all the tables. Means behind that URL, you have all these tables. But the point is Power BI didn't ask for any credentials. It directly connected me to the data source. Actually, in Power BI Desktop, the data source settings are saved. When you very first time you make a connection with any new data source, the settings will be saved within the Power BI Desktop. In order to see those details, in order to see those settings or clear those settings, you go to File, Options in Settings, and there you see Data Source Settings. Then you go to the Global Permission tab. Here you can see these are the data sources which are being used previously. So I removed this OData service from here because the details were saved already. I removed that. Now, again, if I try to get the data from the same data source, get data, OData feed, paste the URL and click OK. Now it asks for the credentials. When you will be having the URL of your application by your company, then your company will be giving you some credentials as maybe Windows credential, basic credentials, API, or your organizational credentials, correct? So accordingly, you need to use the one which you get from your company. But as this is a online and a free open source link I'm using, so anonymously we can connect to this. I select anonymous, click on connect. Once the connection is authenticated, I'll get a list of all the table names, right? From this table, I need the products table. So I can search the products table here. Here I see I have the products table. I can select multiple tables as well, or if I need selected table, you can search that. I select the products table. Here I see the preview of the data, right? And now when I click on transform data, as I said, always you need to click on transform data here. Once you click on transform data, your data will be loaded to Power Query Editor. Now let's say here you need only two columns, product ID and product name. Other columns are not required. You can remove those columns. You can do different stuff, different operations here. But for now, let's load this data directly. Click on close and apply. Now products data will be loaded here. So the products data has been loaded. Got it? So you have seen first two tables I loaded from Excel. Third table, products table, I loaded from a OData link. I can load some other data from different data source as well. Correct? So it's fully flexible. You can bring the data from various data sources. Now let's see how we can get the data from SQL server, from SQL database. I have SQL server configured in my machine. Also, you guys are also having the SQL server configured in your machines. In case if you want to get the data from a different database, not from Microsoft SQL database, maybe you want to get the data from Oracle database, MySQL database, IBM DB2 database, Sybase database, Teradata, right? Depending on your requirement, you can pick that data source. The way of connecting with the data source will remain always same. Now, if I connect to my SQL server, this is my SQL server. So in your real-time scenarios, the SQL server will be configured, will be installed on some company's server, or maybe on the cloud server. But just for learning purpose, we have configured it in our local machine. So let it start, and then I will show you how we can get the data from any SQL database. Right. So now this is my server name. It automatically picks your server name. If you are using your company's server, then you will be having some IP address or a different server name. So this is my server name. I can copy this. Let's say this is my server name. When I connect to the server, maybe using my Windows authentication, or maybe you can pick SQL Server authentication, depends on your scenario, whatever you have selected. You can provide user ID password, or you can select Windows authentication as well. That is also fine. Click on connect. Now I have successfully logged in here in my SQL database. Now I go to the database tab. Here I can see there are multiple databases I have. These all are the sample databases. You can particular database from where you need the data. Let's say in this database, I need the data. So this is my database name. I copy this database name also. This one will be used. Inside this database, I go to the tables. Under the tables, I have multiple tables here, right? We have many tables here. We can pick any of the table. Let's say I pick customer table. Right, it's data. You can see in this table, we have all this data available. A SQL query is auto-generated here, but if you want, you can write SQL query from your side as well, right? For those who never worked on the SQL or never saw the SQL, this SQL query looks like this. Okay, you can write some joins, some subqueries, where conditions, and lots of other things as well, right? So whatever the data is returned by this query, if you want to get this data in Power BI desktop, then you have two options. Either you can get the table data directly, or based on this query, you can get the data. Means you can use the query also in Power BI to get the data. So this query is returning these 5 columns. So these 5 columns data will be extracted inside Power BI. Or you can load the data directly from customer table as well without writing the query. It depends on requirement. Now, if I go to my Power BI desktop, so my data source is SQL Server. I go get data and I pick here SQL Server. Or if I go to the more, where I'll see a complete list of the supported data sources under the database tab, I see we have many databases available here. Correct. But for now, I select SQL Server. You can select Access database as well. I saw there was a question on Access database. Can we connect? Yes, we can connect Access database also. I select SQL Server database for now. Click on connect. Here I need to provide my SQL Server name. So here is the server name. I copy it and paste this here. Next, I need the database name, which is optional here. I copy and paste the database name here. Although it is optional, maybe you can skip it for now, but on next screen, you can select the database. But ideally, if you know the database name, you should provide that. Correct? Now, I select import connectivity mode here. You have two type of connectivity modes, import and direct query. We have a detailed discussion on this thing in our module 6. For now, I'm selecting import. Selecting import means the data will be imported within Power BI, means a copy of the data will be loaded within Power BI. Under the advanced tab, advanced options, here you have a SQL statement box where you can write the SQL query. Let's suppose you have written the SQL query here. This query you can copy and now you can paste it here. Based on the SQL query, what you copy paste or you write, although we do not prefer to do it here. Generally, we write the SQL here because it's a more convenient way to write here. Then we paste it here. When I click OK, I will get the data based on this query, correct? But for now, I don't write a query. Let me skip this because it's an optional part. Now, when I click on OK, it will ask for the credentials. It needs a Windows credentials or a database credential or a Microsoft account. Depending on your company, whatever the credential is given to you from your company or whatever the credentials you have to connect with the SQL server. You select that. I have Windows authentication. So I select Windows as a on authentication mode and I click on connect. Once I click on connect, it says that your details means your connection details will be saved into a encrypted method, right? Means your details will be saved into an encrypted format. Just a message, you can click on OK and you see a list of the SQL views and a list of SQL tables. Here you can see all these SQL views and tables. From here, you can select whatever you need. If you need customers table, you can search that customer table. Here is that sales.customer table. You can click on it to see the preview of the data of this table. Right? Once you decide, yes, this is the same table which I need. So I can select this table. And as usual, you can select other tables as well. It's up to you. Then you click on transform data. Your data is loaded now in Power Query Editor. Here you can process, you can clean it. Like if you don't need the columns at the end, you see few columns. These are coming here because you are using a sample database. So these are called the relational columns. You can select all these columns with control key and you can remove these columns. Right click and remove columns. When you remove the columns, there will not be any impact on your data source. The columns which I removed, those are removed from the staging area, because when we load the data in Power Query, a clone or a copy of the data will be loaded inside the memory. So from that copy, we removed the column. It doesn't mean like the columns have been removed from my database table also. No. Power BI cannot write back anything to your source. Here is a one-way communication, which means Power BI can just read the data. Power BI cannot write back anything to your data source. Got it? Sometimes when we get the data from Excel, we add a new column or we remove a column. So it doesn't mean that your data source data will be changed. Never. Your data source, your original data, which you have in your Excel, which you have in your database, that remains unchanged. There is no change in that data. Correct? Because we are playing on the copy, on the clone of data. Correct? So after removing those columns, now I can take this data in Power BI desktop. Just click on close and apply. My data will start loading for customer table. Here you see customer table data has been loaded. If you want to rename the tables, you can just double click or right click and you can rename the tables, or the easiest way is to just double click and rename the tables. Got it? Okay, so this is how we extract the data from any SQL database. Let's say I have written a SQL query for in this, right? Let's suppose this is a SQL query I have. Maybe let me pick a different table this time. So I have a different table here. Sales order header. Okay, so from this table, I need some of the columns data, right? So let's suppose I write this. If you know how to write the SQL query, that's great. Or you should understand, you should learn the basic SQL. Although it's not mandatory, but it is always good for you to get a good job or to work effectively in your official projects. Most of the time, companies' data will be stored into the databases, right? So SQL is very essential skill for the data profile for the data professionals, right? Either you are a data analyst, you are a data engineer, you are a data scientist, or whatever, right? If you are related to the data anywhere, then SQL is a very basic thing which you should aware, right? So there are lots of courses available based SQL courses. So basic SQL knowledge will be more than enough. Now let's say we just write or we add or remove few columns from here, right? So this SQL script I have, based on the SQL script, I'm getting this data. Say this script I copy here, SQL, and now based on the SQL query, I want to get the data. So now I can write the SQL query. I can connect to the SQL table again, SQL source. I provide the entire data source and everything. Before that, let me paste the SQL query here. And then I select it will execute that SQL script. And based on that SQL script, it will give me the data here like this. Okay. Now, as usual, click on transform data, perform some cleansing on it, like removing some column, adding some column here, whatever you want, right? Then load it. When you load a data through by writing a SQL query, by default, the table name comes as query 1, right? So you should give a proper name to your tables. You should follow the naming conventions because these are important throughout the Power BI. So this table contains order headers. So I just provide a proper table name. You should manage the spacing in your tables, or you should just manage the underscore, right? This is your order headers. Got it? Now, let's see another data source. This time we are going to fetch the data from a PDF file. Although it's very rare, but in some cases you may be interested or you may have requirement to fetch the data from a PDF file. Most of the time, who work in finance domain, for them it is very important data source PDF file because they use lots of data and invoices in the PDF files. So sometimes from the PDF file they want to fetch data inside Power BI for some data analysis or maybe for doing some visualizations. So I have a sample PDF file available in my dataset folder. So I have this PDF file which has lots of text, lots of paragraphs here, but this PDF file contains a tabular data also, right? So this tabular data Power BI can extract. If I scroll it down, we have some more graphs. If I scroll it more, here you can see we have lots of other tables as well, right? Similar to that, you can see here also. So all these tables data, or maybe any particular, let's say this particular table data I need Power BI. So you just go to your Power BI desktop, get data, go to more. Here you can see the PDF as a data source. If you want to import the data from a PDF file, select it, click on connect, go to your data set, select the PDF file and click on open. Power BI will process the PDF file and it will give you a couple of tables. Now you need to cross check whether the data you need is that the same which you see in the table. So in this table, the data is extracted like this. It seems like the paragraph but I don't need this data. So skip this, go to next. This is the one which I was having in the tabular format. Go to next. Here you see the driver details data. This is what exactly I was looking for. So I check mark it and I click on transform data. Now, if you want to make some transformations, some changes here, let's say you don't need this date type of column here, you can remove it. Or if you want to perform some other stuff, you can do that. The table name is not proper. As I said, just double click and rename the tables. Give a proper name. So I'll call it driver details. Okay. Now, when you bring the data from any data source, Power BI automatically detect the data type. So if you see this column, speed, driver, car, engine, date, all these columns are having a small icon before the name of the columns, if you notice, right? So this means this represents the data type of the column. Data type of the column means what type of data you have inside your column. So when you see this small icon, which seems here, which looks as ABC, which means it's a text type of column. When it is a text type of column, you can see this column contains all the text values, all the string values. Text type of column can contain the numeric values as well, right? But if you notice this particular column, it's a date column and you see all the dates here. But the data type is considered as a text. Ideally, the data type should be date, correct? So data types play a very important role during the visualizations and calculations. If while you get an overview, while you review the data here, you notice that your date is in the text data type, it should be into the date data type. You can change it. Just click on this icon here. You can pick the data type which you need, or you can right click, you go to the change type, and currently the type is text, but you want to make it date, you can pick the date from here. You need to right click on the header. If you right click on the cells, right, on these values, you won't get those options. Sometimes I have seen people right click here and they say the option is not coming, because you need to click on the header, right, on the column name, right click, and then you see these options. So I go to change type and I make it date. When I select a date, it says that you already have a step here. These applied steps will be created automatically whenever you perform anything on your data. When I'm renaming a column, I'm deleting a column, I'm inserting a column, I'm changing the data type, whatever I do, for each and every step, one new step will be added here, correct? So I replace the current step. Now, if you see, few of the dates have been converted into the date data type. But in this column, I see there are few errors. Whenever there will be error, you will see it like this. Now, what's the problem with it? Why it's not converted into the date, although the other dates have been converted? Let's try to read the error. To read the error description, you need to click in front of the error, right? In the same record, you just click in front of error, click here. Here you can see there is a regional settings. So currently the regional settings are my Windows default settings, right? So if you need a different settings, you can pick anything from here. Maybe you want to use the state format, so you can pick it from here. All right, but if I do not want to make the changes in the settings and all, because the default setting is always recommended. So the last and the best option is I can split these column value in three parts. One part is date. Let's say this is I will say this is my month. This part is date, and this part is year. So I can extract this date. I can split this date in 3 components. And after that, I can merge it again in the sequence in which I need. Let's say first I need date, DD, MM, and YY. Correct? So I can combine them again. First, let's break it, let's split it, and then again combine it in the desired format. So as I applied this step, but that step was giving me the error, so I undo that step. In Power Editor, you have these options like you can transform the data, or if you want to undo that transformation of the data, you can just delete that step. I delete this change type step. I got the date column back. So first I want to split this column. Right click on the column. I go to a split column. Now I have many options here to split this column, maybe by delimiter, by the number of position, number of characters, by number of positions, multiple options you have to split it. Here, based on the delimiter, means based on the slash I have, I want to split it. So I want to split it based on the each occurrence of the delimiter, and my delimiter is this slash. You can update it, you can change it if you need something else, but PowerBI automatically picks the delimiter here. Now I need each occurrence of the delimiter. Based on the each occurrence of the slash, it should get splitted. So I click on OK. You can see we have splitted this column into the 3 parts, 1, 2, and 3. So which is your month column? This one, because here only I see all the dates which are less than 12. This is my month, this is date, and this is year. Now I want to concatenate them in DD, MM, YY. Date, month, and year. So I concatenate these now. For concatenating or to merge these columns, I select the columns in the same sequence in which I want to merge, I want to concatenate. First, I select date, then with control key, I select month, then I select year. Correct? Now right click and select merge columns. Merge column is like concatenate. I select a separator. Let's say I need the same separator slash, and the new column I'm creating, what the column name I need? Let's say the column name I need date. Click OK. 3 columns have been merged together, and I got only 1 column. Now let's change the data type of this column now. Right click, change type, and make it date. Here you go. It's got converted properly and the data type is changed as date. Once the data type is changed, now if you look at the icon here, it looks like a calendar, which means a date data type. Earlier it was ABC, means it was a text type of column. Once you have these date type of columns, on this date type of column, you can perform lots of other visualization activities. So the long story short is data types matters a lot. Make sure you are keeping the correct data type of your data. Although to an extent, Power BI can handle it on behalf of you, but it's your responsibility to cross check. Now, if I look speed, the speed cannot be into the text, right? Although Power BI detected it automatically, but manually I deleted that step. So the speed is appearing in the text value. If here it's clearly visible that it should be a decimal number, so I can click here and I can make a decimal number. Although I have a feature in Power BI to auto detect the data type. I can select a column or multiple columns, and then I go transform. Here I see detect data type. This will automatically detect the data type based on the data we have in this column. When I click on it, you see the data type has been changed and it is detected as decimal number here. Got it? Now let's load this data. So whatever the transformations, whatever the data processing I did, that will get applied here when the data is loaded. So driver details data is loaded here. Here you can see its preview. Got it? Once the data is loaded, let's say for this date, now you want to change the format. You can go here after loading the data, you can go to the format. Maybe you need this format of the dates. You can change it. Or maybe if you need a different style of the dates, whatever you need, you can just go here and change it. Well, just on your right click. You don't need to write any code, any script to perform your data transformation. That's the benefit we have here. Any non-technical user, any business user can easily transform the data. You don't need to be a technical or IT expert. That's why Power BI is in the demand, because any non-technical users can also prepare, they can also transform their data, they can also create their reports in Power BI. Correct? But sometimes if the data transformation is very complex, so in such cases, obviously some IT skill sets are required. Correct? But it's not a mandate thing, right? Without having IT skills also, you can start working, you can start learning Power BI. Right. So this Power Query, what you see here, this is having all the options. Not all, means to an extent, it support most of the common options which you use in ETL tools like in Informatica, in SSIS, right? So the basic transformation, basic cleanup of your data, you can do within Power BI, within Power Query editor here. Now, for the reporting or for the data analysis needs, you need the data in a centralized repository, means in a centralized database.
Okay.
Because you do not have, or you cannot connect every time to your SAP, because SAP is your production ERP system. So you cannot directly hit that every time to load millions of records.
Okay.
So your company will be using some ETL tools. Let's say they are using Informatica, or maybe they are using Data Stage, they are using SSIS, Azure Data Factory. There are a number of tools available in the market. Power BI, look inside that folder and it quickly find all the files which we have in that. So we have total 5 files. So 5 files details are extracted here. That the file name is this, all are the XLSX files, the date creation, when the file was last modified, and what is the folder path you have for these 5 files. Now, whatever the 5 files data you have, this you want to combine. So here you have a combine section now, but you want to combine and transform also. You have 2 choices: combine and load, transform the data, combine or load the data. So as I said earlier also, let's combine it and hold it outside the gate, hold it into the Power Query for some basic data transformations if needed. So I click combine and transform data. In Power BI Desktop, we do manual refresh, but once the reports will be published on Power BI service, there we can schedule the auto data refresh. So when I hit the refresh, it will start bringing the data again from that folder. It will process the data and it will give you updated file August 2016 here. So it has loaded the August 2016, means new files data automatically. Got it? So this is how you can read the files from one folder. You don't need to manually upload the data every month or every week. Just point the Power BI to that folder. Whenever any file comes in that, Power BI automatically loads the data. Is that clear, guys? What benefit we have of the folder as a data source? The column name is changed. Let's say it's changed. It has been changed like company segment. So if the column name has been changed, then it will throw error, because the column names should be same. If somewhere is the change in the column name, then in other files also you need to make that change. You need to reflect that change. Correct? Any new column is added, that's not a problem, but the existing column should be changed. Right? The column names should be same for the existing columns. Okay, so that's the only condition we have. If for this table, see, row ID. The data type for row ID has been automatically detected by Power BI, and it's coming here as 1, 2, 3, means a whole number or kind of integer number. Order ID is text, order date is date type of column. So Power BI has automatically detected these things. If you look sales, it's coming as 1.2, means it's coming as a decimal number, right? So if you see here, the data type for the sales column is decimal number. So Power BI automatically detects that thing. But still, it's your responsibility to cross check it. If for any reason, if Power BI didn't detect it, then you need to cross check it manually. So let's see how we get the data from world population website, or maybe from the Wikipedia site. Let's say I need world population. From this Wikipedia website, I can see lots of paragraphs are written about the world population. But here I see some tabular data, right? Like this. This is my tabular layout, tabular structure. I scroll it down here also. I have lots of other data like top 10 most populous countries. Let's say this data I need in Power BI, right? I want to get this 10 most populous countries data in Power BI. So I just copy this web page URL. Now I go to Power BI, going to get data. And here you see there is a data source available called web. So if you want to fetch the data from any web page, means any website, so you use this option. Click on web and paste that URL here. Click OK. It asks for the credentials, as we are using Wikipedia, which is open source, anonymously anybody can connect. So I select anonymous here, click on connect. All right, so now here you can select the tables which you need. Let's say I need this 10 most populous countries. Power BI will try to read all the tabular data. If it reads some unstructured data as well, means some paragraphs, so such data you can skip. You can just look at what you are expecting to bring in Power BI. So I need this table, select this and transform it. Now, as usual, from the Power Query editor, I can remove some columns. Let's say I don't need the date column, I don't need the rank column. I can remove these. Right now, let's load the data to Power BI Desktop. That's it. So this is how you can bring the data from any open source web pages as well. Got it? All right. So now, other than these data sources, if you want to fetch the data from Azure database. So for example, if you want to fetch the data from Azure SQL database, you select this option here, Azure SQL database, click on connect. And here you need to provide your server name, your database name, and just click OK. That's it. You will get a list of the tables and you can select the table which you need. Similar to this, you can get the data from other data sources also. Let's say if you are interested to get the data from Oracle database. So you select the Oracle database. There are few databases which needs a connector, first before you load the data. Let's say from Oracle database, you want to get the data. So when I click on connect, it says that there is a connector, or there is a, I would say, another plugin required, which is not available in your machine, right? So you need on data access client. To get this, you can click on learn more. It takes you to the Power BI's official website. From there, you have the link of the Oracle website. You can see here, you can click on this 64-bit Oracle data access component. It will redirect you to the Oracle website. From here, you can download the correct version, right? Based on your Oracle database, you need to download the correct version of this particular, I would say, connector, and then you need to install it in your machine, right? This is a one-time setting you guys need to do while you want to connect with some of the data sources, right? Let's say you want to get the data from SAP database. So you go more, you search another data source here, your SAP, because these softwares like SAP, Oracle database, these are not free, these are paid, right? And I would say very expensive one. So in your company, you will be having the excess of all these things. You cannot set it up for the just for the dummy, like especially Microsoft tools you can set up for dummy for trial license, but these products do not provide the trial licenses. For SAP HANA database, S4 HANA, if you want to connect, it again asks for a connector. That connector is not installed. You click on learn more, it automatically redirects you to the SAP website. And in your company, your SAP consultant or SAP engineers will be having a login ID, a support email ID for SAP. You need to log in here with your SAP account, and then you will have the download center access, right? From the download center access, you can download a particular connector depending on the version of SAP your company is using. Correct. So all these things are your IT related things. Your administrator needs to arrange all these connectors for you because it requires a support account. It's not like anybody can log in and can connect. No, only in companies, right? There will be a separate team or a dedicated person who will be having all these accesses. Correct. So maybe you need to reach out to them. You need to raise some tickets, right? They will give you the connector. Then you can install or they can install that in your machine. Then you will get the option to connect with SAP by just providing the server name, database name, and the credentials. Correct. So few data sources we have like Oracle database, SAP database, IBM DB2. For other databases, it's not needed. For example, you want to fetch the data from Snowflake. Snowflake is an online, I would say a cloud data warehouse. So you select the Snowflake and just click on connect. It didn't ask for any connector or nothing. Just provide your server name, provide your warehouse name, and click on OK. That's it. Got it? So whatever the data source you have, just try to connect with that. In case maybe you have SQL, you have SAP, you have Oracle, you have Sybase, Teradata, whatever. Just try to connect with that, having with your right credentials. It comes with a free edition as well, and with the paid as edition also. So you can use the R Studio Desktop free one. And this, just click on this download. This free edition will look like the one which I was having in my machine, like this. Okay. In that R Studio, you can write the script like I have written, and then you can copy paste that within Power BI. But before that, you need to make sure the setting under the file. Go to File, Option Settings, and Options. So here you go to the RS scripting. Here you need to make sure whether the Power BI has detected the R home libraries automatically or no. Although when you install the R in your machine, Power BI automatically detects that. In case in 1%, in case if it does not detect, you can click on other and you can browse for the folder and you can set the path. Correct? Same goes for the R Studio for the R development tool also. It's automatically detected, but in case if not detected, then you can just change the setting from here. Got it? So this is how R can be used with Power BI also. In case if you know R or Python, or in case if you are planning to learn R or Python, then R or Python skills you can leverage with your Power BI skill sets. Got it? So just a quick demonstration to give you a basic understanding on it. All right, now that's all from my side for this today's class. Now, if you have any doubt or any question, please let me know. Here we complete this data extraction. We have understood how do we extract the data, how we combine the data from different data sources. Now, although we have got a basic understanding of the Power Query Editor also, how do we transform the data, how do we prepare the data in Power Query Editor. Now, next module will be purely based on data transformation, right? Shaping or combining the data. How we prepare the data using the options which we have in Power Query Editor. You have lots of options here. How we use these options to prepare our data, to transform our data. Okay, so just give a try to connect with R. Okay, in case if you want to do that through Python, you can just go through with Python.
So now, coming to the first question, what are the steps involved in data analysis? There are several steps involved in data analysis. So now, talking about the first step in data analysis process is to define your objective.
And in data analytics, this is sometimes called the problem statement. Now let's move to the second step, that is collecting the data. Once you have established your objective, you will need to create a strategy for collecting and aggregating the appropriate data. A key part of this is determining which data you need. This might be quantitative data or qualitative data. Moving ahead, the third step is data cleaning or pre-processing. Once you have collected your data, the next step is to get ready for analysis. This means cleaning or scrubbing it, and it is crucial in making sure that you are working with high quality data. Key data cleaning tasks include removing major errors, duplicates, and outliers. Also, it is used to remove unwanted data points and bring structure to your data. So now, moving ahead, we are having next step as data exploration. Data exploration is used to explore and visualize data to uncover insights from the start or identify areas or patterns to dig into more. Next, we are having data modeling. Data modeling is the process of analyzing and defining all the different data your business collects and produces, as well as the relationship between those bits of data. The next step is data validation. Data validation is the practice of checking the integrity, accuracy, and structure of data before it is used for a business operation. And last, we are having implementation. So in this, we're going to implement our business operation. So these are the important steps for data analysis. So now, let's jump into the second question. What are the key differences between data analysis and data mining? Talking about data analysis, it involves the process of cleaning, organizing, and using data to produce meaningful insights, whereas data mining is used to search for hidden patterns in the data. Also, data analysis produces results that are far more comprehensible by a variety of audiences than the results from data mining. So this was the difference between data analysis and data mining. Now moving to the question number 3, what is data profiling? Data profiling is a methodology that involves analyzing all entities present in data to a greater depth. The goal here is to provide high accurate information based on the data and its attributes such as the data type, frequency of occurrence, and more. So this is all about data profiling. So now, moving to the question number 4, what are the top tools used to perform data analysis? So there is a wide spectrum of tools that can be used in the field of data analysis. Here are some of the tools. The first one is the Microsoft Excel. As we know that Microsoft Excel is used in major companies for the data analysis. Along with that, we are having PowerBI, Tableau, RapidMiner, and many more. So these are the top tools that are used to perform data analysis. So now, let's check out the next question. What is an outlier? Outliers are the data points or observations that are significantly different from other data points because of their abnormal distance from the rest. Here you can see that in this graph, we are having the outlier present that is marked with an orange color, right? So as I told you the formal definition that outliers are the data points that are significantly different from the other data points. Here you can see that the data points are having some pattern, right? But this is an outlier that is significantly different from other data points. Now talking about the outliers, there are two types of outliers. The first one is univariate and the other one is multivariate. So this is the basic idea about an outlier. Now moving ahead, what are some of the popular tools used in big data? There are multiple tools that are used to handle big data. Some of the most popular ones are as follows. The first one is Apache Hadoop. Moving ahead, we are having Apache Spark, Apache Storm, Flink. You can also use MongoDB and RapidMiner. So these are the popular tools that are used in big data. Moving to the next interview question. What is the use of pivot table? So this is a question of Excel, right? So talking about pivot tables are one of the key features of Excel. They allow a user to view and summarize the entirety of large data sets simply. Most of the operations with pivot tables include drag and drop operations that aid in the quick creation of reports. So this is the idea about pivot tables. So now let's move to the question number 8. Explain different types of data validation techniques used in data analysis. There are many types of data validation techniques that are used today. Some of them are field level validation. Talking about the field level validation, it is done across each of the fields to ensure that there are no errors in the data entered by the user. The next one is form level validation. Here, validation is done when the user completes working with the form but before the information is saved. The third one is data saving validation. This form of validation takes place when the file or the database record is being saved. And the last, we are having search criteria validation. This kind of validation is used to check whether valid results are returned when the user is looking for something. So this is the basic idea about different types of data validation techniques. Moving to the next question, we are having what are the top Apache frameworks used in a distributed computing environment. So we already know that Hadoop and MapReduce are considered to be the top Apache frameworks when the situation calls for working with a huge dataset in a distributed working environment. So we are using here Hadoop and MapReduce for the distributed computing environment. Moving to the next question, what are the ideal situations in which t-test or z-test can be used? It is a standard practice that a t-test is used when there is a sample size less than 30. Now, coming to the z-test, it is considered when the sample size exceeds 30 in most cases. So this is the situation in which we use t-test or z-test. When the sample size is less than 30, we use t-test, and when it is greater than 30, we use z-test. Now, moving to the question number 11, what are the disadvantages of data analytics? Compared to the plethora of advantages, there are few disadvantages while doing data analytics. Some of the disadvantages are listed below. The first one is data analytics can cause a breach in customer privacy and their information such as transactions, purchases, and subscriptions. Moving ahead, some of the tools are complex and require prior training. So this is the biggest disadvantage of data analytics. And the last point, it takes a lot of skills and expertise to select the right analytics tool every time. Alright guys, it's time to move to the next question. Moving ahead, how can one handle suspicious or missing data in a dataset while performing analysis? So let's suppose if there are any discrepancies in the data, a user can go on to use any of the following methods. The first one is applying several strategies together to find missing values and using approximation if needed. Moving to the second point, user can replace the invalid data with the corresponding valid and up-to-date data. Moving ahead, it can create a validation report with details about the data in discussion. And the last point is that escalating the same to an experienced data analyst to look at it and take a call. So this is a way to handle missing data. Also, you can replace the value with mean, median, and mode. So these are the ways to handle missing data. Moving to the next question, what is the difference between the concept of recall and the true positive rate? So let me clarify you, recall and the true positive rate are totally the same. Talking about the recall, recall is a metric that quantifies the number of correct positive predictions made out of all positive predictions that could have been made. So when somebody is asking you the formal definition of recall, you can say that out of the total positive, what percentage are predicted positive. Now talking about the formula of recall, it is true positive upon true positive plus false negative. Now moving to the question number 14, what is the simple difference between standardized and unstandardized coefficients? In the case of standardized coefficients, they are interpreted based on their standard deviation values, whereas the unstandardized coefficient is measured based on the actual value present in the dataset. So this is the difference between standardized and unstandardized coefficients. So basically, it is asking what are the ways or techniques that are used to detect outliers. So the first one is box plot. So we know that while using box plot, we can easily find outliers, right? The second technique is z-score, and the last one is interquartile range. So these are the techniques to detect outliers. Moving to the next question, what are z-test, chi-square test, f-test, and t-test? As I already told you about the t-test is used when your sample size is small, basically when the sample size is less than 30. Alright guys, so now after understanding what is t-test, now let's see what is z-test. So z-test is used for large sample. Basically when your size of the sample exceeds more than 30, we are using z-test. Now coming to the chi-square test, people used to pronounce it chi-square test also. This kind of hypothesis testing is used when there is a requirement to find out the level of association between the categorical variables in a sample. The test of significance is to determine the difference between observed and expected frequencies of certain observations. Now, moving ahead, we are having f-test. So in f-test, hypotheses of interest are about the differences between population means. So this is the idea about z-test, chi-square test, f-test, and t-test. Moving ahead, we are having what are the advantages of using version control? There are numerous benefits of using version control. Now let's see. The first one is it establishes an easy way to compare files, identify differences, and merge if any changes are done. Moving ahead, it creates an easy way to track the life cycle of an application build, including every stage in it, such as development, production, testing, etc. It also brings a good way to establish a collaborative work culture. Along with that, it makes ensure that every version and variant of code is kept safe and secure. So these are the numerous benefits of using version control. Moving to the next question, what is collaborative filtering? Collaborative filtering is an algorithm used to create recommendation systems mainly considering the behavioral data of a customer or a user. For example, when browsing the e-commerce sites, a section called recommended for you is present, right? This is done using the browsing history alongside analyzing the previous purchases and collaborative filtering. So this is the idea about collaborative filtering. Moving ahead, the next question is, what are the properties of clustering algorithms? Any clustering algorithm, when implemented, will have the following properties. The first one is hierarchical or flat. Moving ahead, we are having iterative, and the last one is disjunctive. So these are the properties of clustering algorithms. Now, moving to the question number 20, explain the term normal distribution. Normal distribution is also known as Gaussian distribution. It is a type of probability distribution that is symmetric about the mean. It shows that the data is closer to the mean and the frequency of occurrences in data are far from the mean. In normal distribution, mean, median, mode are equal. So this is the basic idea about normal distribution. Now, moving to the next question, that is question number 21. What is the difference between overfitting versus underfitting? Overfitting and underfitting are the two main problems that occur in machine learning and degrade the performance of the machine learning models. Now, talking about overfitting, it occurs when our machine learning model tries to cover all data points or more than the required data points present in the given dataset. Because of this, the model starts catching noise and inaccurate values present in the dataset, and all these factors reduce the efficiency and accuracy of the model. The overfitted model has low bias and high variance. The chances of occurrence of overfitting increases as much we provide training to our model. The more chances of occurring the overfitted model. For example, the concept of overfitting can be understood by the above graph of linear regression output. For example, you can see this graph. In this graph, the model is trying to covering all the data points. Hence, it results in the overfitting. Now, after understanding overfitting, let's see how to avoid overfitting in the model. So there are several ways by which we can reduce the occurrence of overfitting in our model. The first one is cross-validation. The second one is you can train with more data. And the last one is removing features. And there are some other techniques such as ensembling, regularization, and many more. So after understanding overfitting, it's time to understand what is underfitting. It occurs when our machine learning model is not able to capture the underlying trend of the data. To avoid the overfitting in the model, the fed of the training data can be stopped at an early stage, due to which the model may not learn enough from the training data. As a result, it may fail to find the best fit of the dominant trend in this data. In the case of underfitting, the model is not able to learn enough from the training data, and hence it reduces the accuracy and produces unreliable predictions. An underfitted model has high bias and low variance. For example, in this graph, you can see that the model is unable to capture the data points present in the plot. So this is the basic idea about underfitting. Now let's see how we can avoid underfitting. So we can increase the model's training time, and also we have to increase the number of features to avoid underfitting. So this is the basic idea about overfitting and underfitting. Now moving to the question number 22, what is RMSE in a linear regression model? RMSE stands for root mean square error. It is computed by taking the square root of MSE. The lower the RMSE, the better the model and its predictions. So this is the basic idea about root mean square error. Moving ahead, we are having the question number 23, what is naive Bayes? Naive Bayes classifiers are a collection of classification algorithms based on Bayes' theorem. It is not a single algorithm, but a family of algorithms where all of them share a common principle. That is, every pair of features being classified is independent of each other. The fundamental naive Bayes assumption is that each feature makes an independent and equal. So this is the basic idea about naive Bayes. Moving ahead, we are having the question number 24, that is explain univariate, bivariate and multivariate analysis. So now, talking about the univariate analysis involves analyzing data with only one variable, or in other words, a single column or a vector of the data. This analysis allows us to understand the data and extract patterns and trends out of it. For example, analyzing the weight of a group of people. Now, let's move to the bivariate analysis. Bivariate analysis involves analyzing the data with exactly two variables, or in other words, the data can be put into a two-column table. This kind of analysis allows us to figure out the relationship between the variables. For example, analyzing the data that contains temperature and altitude. Now moving to the last one, that is multivariate analysis. Multivariate analysis involves analyzing the data with more than two variables. The number of columns of the data can be anything more than two. This kind of analysis allows us to figure out the effects of all other variables on a single variable. For example, if you want to analyze data about house prices, which contains information about the houses such as locality, crime rate, area, the number of floors, etc. So this is the basic idea about univariate, bivariate and multivariate analysis. Now, moving to the next question, what are the different statistical techniques used in data analysis? The first one is the correlation. It establishes and measures relationship between different variables. For example, let's suppose if you are having a data set, so in that data sets you will be having features as well as the output variable. So basically the correlation will establish the relationship between the features and the output variables. Now talking about the regression, it allows identifying if the evolution of one variable affects the other. So we are having different types of regression such as linear regression, multiple regression, right? So in linear regression we can see that one variable can affect the other dependent variable. For example, you can consider experience versus salary. So as the experience will increase, your salary will also increase. So this is an example of linear regression. Now, the last one is time series. It predicts future values by analyzing sequence of past values. So basically, you can use the time series for the forecasting, right, based on the past data. So this is a basic idea about the different types of statistical techniques used by data analysts. Moving next, we are having type 1 and type 2 error. So the question is, what is type 1 and type 2 error? Talking about the type 1 error, so type 1 error is also known as false positive. Basically, it occurs when a null hypothesis is rejected based on the statistical findings, even if it is true. For example, if a person is having a symptoms of COVID and he knows that he is COVID positive, but in the end, the results come negative. So this is a type of false positive case, right? That is type 1 error. Now talking about the type 2 error, it is also known as false negative. It occurs when the null hypothesis is not rejected based on the statistical finding, even it is false. So this is the basic idea about type 1 and type 2 error. Now moving to the question number 27, what is the difference between where and having? So the first difference that I will tell you about where, that in where you are not allowed to work with the aggregate functions, whereas talking about the having, you can work with the aggregate functions. Now, where is a clause which is used to filter records prior to grouping, whereas having clause is used to filter values within a group. Also, where is implemented in row operations, whereas having is implemented in column operations. So now talking about the last point of where clause, this clause can be used with the select, update and delete statements, whereas having clause can only be used with the select statement. So this is the difference between where and having. So now let's move to the next question. Next question is, what are the different types of methods to create a data frame? Now you can create a data frame with the dictionary, with the list. Also you can create a data frame by uploading the CSV file or Excel file. So now let's see the first way, that is dictionary. So here I will create a dictionary with the variable name as dict1, right? So as you know that dictionary will have key as well as value pair, right? So this is the key. So the key is here as student and the value is here Gaurav, Dilesh, Rishabh, Wasim and Priyansi. So the another key that we are having as marks. So this is a key and the values are here, right? Now if you want to create a data frame, then I have to upload the library, right? So I will just simply write here import pandas as PD. Okay, so here I am writing here as PD. So PD is an alias. So I'll just simply write here PD dot data frame function. Make sure that D and F are capital, and inside that I will put the dictionary, right? So this is the dictionary variable name dict1, right? So when I'm just writing this, you can see that the output will be displayed with the student and marks as the column, right? And here the value of the key will be displayed, that is nothing but Gaurav, Nilesh, Rishabh, Vaseem and Priyansi, and so as the marks. Okay, so this is the way to create a data frame via dictionary. Now if you want to create with the list, so what I will do here, simply I'll just create a list with list 1, and here I will simply write Gaurav and 82, right? And then I will just simply write the another name with the marks. So you can see that when I'm writing here pd dot data frame list 1, so there will be no column, since I'm just writing here the records. So now if you want to print the column, so I'll just simply write pd dot data frame, and inside that I will pass the list, and I will just pass another parameter with the name columns, and inside that I will just write student and marks. So what will happen when you are executing it, you will see that student and marks are the columns, right? And these are the records. So this is a way to create via list. Now another way, as I already told you, that you can upload a CSV or Excel files to create a data frame. So for that, let's suppose if you are having a CSV file, so you have to write pd.read_CSV, and inside that the file name. And for the Excel file, you have to write pd.read_Excel. So in this way, you can create a data frame even through the CSV or Excel files. So these are the ways to create a data frame. So this is the basic idea about how to create a data frame. Now moving to the next question, that is question number 29, extract, store and type columns from the data frame. So here you can see that this was our data frame, right? And from this data frame, I want to only extract, store and type, right? So our data frame variable name was df. So I'll just simply write here df, and inside that I'll just create a list, and I will just write the column name, that is store and type. So you can see that this is a way to extract, store and type columns from the data frame. So now coming to the question number 30, is telling that fetch the records where size is greater than 50,000 and type is B. So you can see that it's basically a condition based statement, right? You have to write here condition. So first I have to write here the data frame, and our data frame is having the variable name as df. So inside that df, I will just write the column name as df size and greater than 50,000, and here I will use the AND operator. And what is the type here? Type here is B, right? So simply I will write here df type is equal to B. And when you are writing this code, you can see that here we will get the type, that is of B type, and size is greater than 50,000. So this is a way to fetch the records where size is greater than 50,000 and type is B. Now moving to the question number 31, is telling that add a new column with an address. So in our data frame, let's suppose if you want to add any new column. So the data frame variable name is df. So I'll just simply write here df, and inside that I will just write here address. So our new column has been generated. Now I have to put the value there. So I just simply write random values. Let's suppose Bangalore, Chennai, Gurugram, Mumbai and Delhi. So when you are writing df.head, then it will display the new column also along with the records inserted in it. So this is a way to create a new column. Now moving to the question number 32, what are the different types of sampling techniques? So there are different types of sampling. So now let's see the first one, that is simple random sampling. In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population here. To conduct this type of sampling, you can use tools like random number generators or other techniques that are based entirely on your choice, right? So this is the basic idea about simple random sampling. Now, let's see what is systematic sampling. Systematic sampling is similar to simple random sampling, but it is usually slightly easier to conduct. Here, every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals, right? Moving ahead, we are having the cluster sampling. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. So this is the idea about cluster sampling. The next one is the stratified sampling. It involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. Alright guys, after that we are having the purposive sampling. Purposive sampling refers to a group of non-probability sampling techniques in which units are selected because they have characteristics that you need in your sample. So these are the different types of sampling techniques. Now coming to the question number 33, what are the different types of charts that Tableau provides? So there are several charts that Tableau used to provide, starting from bar chart, line chart, pie chart, maps, Gantt chart, scatter plot, tree map, box plot, density maps, and many more. Okay, let's move ahead. Now, coming to the question number 34, explain hypothesis testing. Now, let me give you an idea about the hypothesis testing. Talking about the hypothesis testing, it is the process of testing assumptions for a population parameter on a sample of data. The process involves different hypotheses and statistical proof to accept or reject the hypothesis. Here, the null hypothesis is represented by H0, whereas alternate hypothesis is denoted by H1. Now, let's see the steps involved in hypothesis testing. The first one is stating the hypothesis. Moving ahead, we are having the collect data. Then we will see the evidence to fail or accept the hypothesis. Then we will test the hypothesis, and according to that, we'll make the decisions. For example, let's suppose there is a student with height more than 5 feet have BMI more than 20. So this will considered as a null hypothesis. Now, what will be the alternate hypothesis? The students with height more than 5 feet do not have BMI more than 20. So this is our alternate hypothesis. Now, what we'll do, we'll apply here statistical test to support the hypothesis, whether we have to accept null hypothesis or reject null hypothesis, right? And at last, we'll make our decisions. So this is how hypothesis testing works. Moving to the next question, what do you mean by the term data wrangling? Data wrangling, also called data cleaning, data remediation, or data munging, it refers to a variety of processes designed to transform raw data into more readily used formats. The exact methods differ from project to project depending on the data you are leveraging and the goal you are trying to achieve. Now let's see some examples of data wrangling. It is used to merge multiple data sources into a single dataset for analysis. It also identifies gaps in data and either filling or deleting them. It deletes data that's either unnecessary or irrelevant to the project you are working on. Data wrangling can be manual or automated process. In scenarios where datasets are exceptionally large, automated data cleaning becomes a necessity. That being said, this is the basic idea about the data wrangling. Now, moving to the question number 36, what is the difference between count, count blank, and countf in Excel? The count function in Excel is used to count cells that contains numbers. Talking about the count blank, it is used to count cells that are blank. Now what about the countf? COUNTIF is used to count the cells that meets a specified criteria. Now moving ahead to the next question, we are having what is the difference between correlation and covariance. Talking about the covariance, it indicates the direction of the linear relationship between variables, whereas correlation is a statistical measure that indicates how strongly two variables are related. For example, in a data set we are having the feature and the dependent variable. So what will correlation do here? It will see how much a variable. So here the correlation will tell the collinearity between the two variables. Now, next point is covariance range from minus infinity to infinity, whereas correlation ranges from -1 to 1. Right? Now talking about the covariance, it is affected by scale of a variable, whereas correlation is not affected by a scale. So this is the difference between correlation and covariance. So now let's see when do we use normalization and standardization. So first I will discuss about the normalization. Normalization is used when features are of different scales. Also, it scales values between 0 to 1 or -1 to 1, depends. Along with that, the important point is note here, it is really affected by outliers. Now, if you want to implement normalization, then there is a library known as scikit-learn. So using scikit-learn, you can apply a transformer called min-max scalar. Now, it is useful when we don't know about the distribution. So now, after understanding what is normalization, let's see standardization. So the most important point of standardization is that it is useful when the feature distribution is normal or Gaussian. Talking about the standardization, it is used when we want to ensure zero mean and unit standard deviation. Also, it is not bounded to a certain range like normalization. In normalization, the range was from 0 to 1 or -1 to 1. But here, it is not bounded to a certain range. Along with that, it is much less affected by outliers. So here also there is a scikit-learn library that provides a transformer called standard scalar. So if you want to standardize your data, you can apply this library. So this is the basic idea about normalization and standardization. Now let's move to the question number 39. So what is the use of p-value? We use the p-value to understand whether the given data really describe the observed effect or not. Basically, p-value is the measure of statistical importance of an observation. It is the probability that shows the significance of output to the data. If the p-value is less than 0.05, we will reject the null hypothesis, or we will accept the null hypothesis if it's greater than 0.05. So this is the basic idea about p-value. Moving to the last question for this top 40 data analyst interview question. What is a skewed distribution? A skewed distribution takes place when one tail is longer than the other. So there are basically two different types of skewed distribution. The first one is left skewed distribution and the other one is the right skewed distribution. Talking about the left skewed distribution, it occurs when the long tail is on the left side of the distribution, whereas in right skewed distribution, it occurs when the long tail is on the right side of the distribution. Now, let's see the figure to understand in a simpler way. So here you can see that in this graph, the tail is on the left side, right? So what is it? This is a left skewed distribution. And here the tail is on the right side. So this is a right skewed distribution. Okay? In left skewed distribution, mode is greater than median and median is greater than mean. You can clearly see that mode is greater than median and median is greater than mean. Now talking about the right skewed, here the mean is greater than the median and the median is greater than the mode. Also, talking about the left skewed distribution, it is known as negatively skewed distribution, whereas right skewed distribution is known as positively skewed distribution. So this is the basic idea about the skewed distribution.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.